Business analysts serve as the bridge between business objectives and technology solution. They play a crucial role in understanding organization needs, analyzing processes, and recommending improvements that drive efficiency, innovation, and growth. By leveraging data analysis, strategic planning, and communication skills, business analysts facilitate informed decision-making within companies, ensuring alignment between business goals and IT initiatives. With that being said, hello everyone and welcome to this session on the Business Analyst Full Course. This course is designed to equip you with the skills and knowledge necessary to excel in the dynamic field of business analysis. But before we get started, let's take a moment to outline the agenda for today's session. To start, we will explore the path to becoming a business analyst, discussing their required skills, salary expectations, and career prospects. Following this, we will have a look at the roles and responsibilities that define what a business analyst does. Advancing further, we will learn the predictive analysis using Python and then data analytics using Excel, followed by an in-depth exploration of Agile and Scrum methodologies. This will include the advantages of Agile, its implementation strategies, and various frameworks within Agile and Scrum. Moving ahead, we will explore the top 5 AI tools for business analytics. These AI tools harness cutting-edge algorithms to reveal actionable insights, enabling predictive analysis and informed decision-making from complex datasets. Progressing, we will introduce Power BI, covering its components, architecture, and fundamental building blocks. Additionally, we will learn about creating Power BI dashboards and exploring data visualization using Power BI Desktop. Moving to Tableau, a tool for visual data analysis, we will explore its strengths, functionality, dashboard creation, and establish a solid foundation in Tableau fundamentals. This includes specific topics like Tableau charts and graphs, parameters, functions, and sets. To conclude, we will discuss essential BI analyst interview question and answers to help you succeed within the field of business analysis. Before we begin, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, check out Edureka's Business Analyst Master Program, the link to which is in the description box below.
What is business analyst? Business analyst helps in business process, products, and services. When it comes to product and services, they will not particularly associate with the creation of tangible products. Rather, they will focus on analysis, systems, and services. They will analyze and evaluate the problems and opportunity to develop solutions through software data analysis for the organization to meet its objectives and maintain a close relationship with the stakeholders to meet their requirements. Business analysts use analyticals to bridge the gap between the IT and the business team by evaluating process requirements, delivering solutions, and generating reports for the executives and the stakeholders. Next, we will discuss on how to become a business analyst. Qualification. A degree in a business or a related field can be useful, but it is not always the same because BA come from different fields such as business, economics, and computer science field. Consider getting a bachelor degree in one of these fields. Relevant skills. Develop the necessary skills such as analytical, communication, problem solving, technicals, and as well as the leadership skill. Courses and certification. Consider taking online courses or pursuing certification such as CBAP, Certified Business Analysis Professional, from the International Institute or in any other related field or institutes. Learn and grow. Look for internship opportunities in business or data analysis to expand your knowledge. Try entry-level jobs with analytical compounds such as data analyst or junior business analyst. You can also gain experience by working on projects and attending conferences and workshops. And take up courses provided by Edureka. Job hunting. After gaining knowledge and skills, begin your job search for business analyst or related position on various job portals such as LinkedIn, Indeed, and others. Alternatively, you can apply from the company's main website, which include career section. During the interview, be prepared to discuss about your experience and skills, as well as how you can contribute to the company. Make sure you let them know that you are confident, a good listener, and a problem solver. Now, we will discuss on the skills required to become a business analyst. A BA should have necessary skills to efficiently analyze client requirements, whereas critical thinking will help a business analyst in examining different solutions and in a professional work. Some of the important skills are analytical skills, technical skills, problem solving skills, communication skills, and leadership skills. Let's take a brief look on each skills. Analytical skills. These skills are very essential for a business analyst because they will be analyzing data, identifying trends, and making data drive suggestion to support decision making and business improvements. Next is the technical skills. Depending on the type of industry, data analysis tools such as Microsoft Excel, Google Sheet, and others, as well as basic knowledge of database systems such as SQL, MySQL, and Oracle, are essential for data management, software development, and project management software. While business analysts are not particularly responsible for coding or development. Next is the problem solving skills. A BA must be a good problem solver and a critical thinker because they will be identifying and resolving business issues. Problem solving ability are required to evaluate different solutions. Next is the communication skill. Communication is very essential for a business analyst because they will communicate with different people, including the client, the product development team, and the implementation team. Business analysts must be able to communicate with the stakeholders at all the levels. For example, they must communicate clearly with the client, collect all the requirements, and process forward with the execution team. Finally, we are up to the leadership skill. Leadership skill is very important for a business analyst because they will frequently bridge the gap between business stakeholders and the IT team, guide projects, and ensure that the business objectives are met. Leadership ability and quality enables individuals to guide and inspire and influence others to achieve the organization goal. Next, we will go through the roles and responsibilities of a business analyst. BA must be well versed in organization goals and objectives. They collaborate with the key stakeholders to identify and define business requirements and opportunities. They oversee gathering and documenting specific requirements. Interviews, workshops, and surveys are used to determine what a business needs from the project or the system. BAs examine the requirements gathered to ensure that they are clear, complete, and flexible. They also see how the changes will affect the existing system and the process. They must be able to communicate efficiently. They act as a go-between the business stakeholders and the development team, translating technical support into the business team. Contribute to the identification of the risk and develop solution through those risks. Now, we will discuss about the certification required to become a business analyst. The value of a BA certification is determined by several factors, including your career objectives and the industry in which you work. Let us discuss some of the business analyst course certification that can help you in your career. Business Analyst Master Course. Check out the Business Analyst Master Course by Edureka, designed by industry experts to provide learners with the understanding of business analysis, concepts, and methods. Through this, participants will gain hand-on experience in critical areas such as data modeling, preparation, analysis, and visualization. To know more in detail, please view the link in the given description box below. Next is the Business Intelligence Masters Program, where Edureka trains you with the tools and the system used by business intelligence professionals. This business intelligence certification course covers data warehousing, BI, Power BI, and Tableau in depth. Please see the link in the description box below for more information. Tableau Certification Training Course. In Tableau Certification Training Course, Edureka provides programs designed to develop expertise in business intelligence, data visualization, and reporting. For more information, please see the link in the description box below. Applied Business Intelligence for Decision Making by PwC, where Edureka offers you one-of-the-kind opportunity to master the art of decision making using applied business intelligence with the designed course from PwC Academy in India. To know more in detail, please view the link in the given description box below. Microsoft Power BI Certification Training Course, where Edureka helps you gain expertise in business analytics and you will master concepts such as Power BI Desktop, DAX, Service, mobile apps, and many more. Please see the link in the given description box below for more information. Now, we will look at the salary status for business analysts. Salaries in India and United States may differ. It must be noted that it greatly depends on a specific location and job role. In India, the annual salary for a business analyst job may range from 8 lakhs to 17 lakhs per year, whereas in United States, it may range from $91,000 to $100,000. Now, we will take a look at the career opportunities for a business analyst. Some of the career opportunities for business analysts can help in various fields, such as business analyst, data analyst, business intelligence, data science, and project manager. Business analyst is one of the highest paid jobs now and in the upcoming future.
Who is a business analyst? So, a business analyst is somebody who bridges the gap between internal IT team and the business using data analytics to assess processes, determine requirements, and deliver data-driven recommendations, and finally present reports to executives and stakeholders. So let's break that down a little bit, shall we? First, a business analyst is a person who stands between the internal IT team and the client that has certain requirements. So a business analyst understands those requirements, whatever it may be, to build an app, to get an insight on what direction their business should take, whatever it may be. They understand all of the requirements for the clients and they act as a proxy for the clients and help the IT team develop the results that are going to be satisfactory for the client, that will help the client make data-driven decisions. And that is exactly what a business analyst is. So now you might ask yourself, well, that is all nice and dandy, but what do they actually do in order to accomplish that? So let's use an example of Stuart, who is a business analyst working for an application development firm. And so that's the business analyst. And let's take a look at the client. So the client in this example is Martha, who is an IT manager at a modern hospital, who is tasked with making a mobile application that allows its customers to make appointments, consult doctors, view their medical reports and receipts, and make payments for hospital bills through their online account, all without having to wait in line, which is so much of a discomfort and inconvenience for patients. So Martha thinks instead of hiring a whole team to make this application, she's just going to approach a company that is going to help her with this. So Martha approaches Stuart's company to see if they can help her with making the app. That's where she meets Stuart, who's been assigned to work on Martha's project from start to finish. Martha discusses the vision behind the app, and Stuart probes Martha to form a picture of what the final product should be like. He assures Martha that he will take it from here and deliver the product as per requirements, budget, and time frame. But how does he do all of that? Well, let's find out. So in this section, we will attempt to understand the roles and responsibilities of a business analyst by using the same example of Stuart and Martha. Okay, so let's get started. So first thing that Stuart has to do is to understand the vision behind the app, what Martha and the hospital are trying to achieve with this app. Here he understands properly what the motives behind making these applications are. Next, he gathers all the requirements from Martha by asking her the appropriate questions about the apps. He does this so that he can understand what the app should look like and how it should function. So he coordinates with Martha to gather all the functional requirements like features and how they function, customer data security, payment system, automatic assistant on the app, etc. And non-functional requirements like look and feel of the app. After he documents all of this, he then allots resources. So what does that mean? He assigns the various parts of the projects to respective teams, such as the development team, the user experience and user interface team, and so on, and finalizes all the tools and software they're going to need for the project, keeping in mind the budget of the client, of course, and the time frame. So the project has been delegated to appropriate parties and they are all off to races in order to finish the project. And so his next duty is to make sure that he tracks the progress and offers recommendation. So what do I mean by that? So as the project develops, he monitors its progress to make sure that the client's needs are addressed. He also makes useful suggestions to improve the project and points out corrections to make if needed, in order to make sure that clients' needs are met. But not only that, he also conducts meetings between Martha and the assigned teams to discuss and decide on how to rectify the issues quickly. Making an application is a complex process, so there are bound to be mistakes that are happening and issues to be cropping up. So to iron them out, he conducts meetings so everybody is on the same page. This also ensures that Martha is always in the loop and knows how the project is coming along. So let's say they worked hard and a prototype is ready. So once it is ready, he begins user testing and after thorough testing collects their feedback. This helps with improvement, correction, and finalization of the product. This also helps with deciding whether the app has met the client's expectations. It gives an idea on improvements and corrections to make, which are communicated to the development team, and this cycle continues until a deliverable product is ready. So the prototype has been through a few iterations of corrections and improvement and now is finally looking ready. So now what Stuart does is he analyzes the gathered data of the app and uses data visualization tools like Tableau, Power BI to make reports that provide insight on the app's performance. These reports could be as simple as charts in a document explaining the data, or could be in form of dashboard with multi-dimensional visual reports based on key performance indicators of the app. Or, outside this example, it could be used to portray business sales figures, employee performance, and endless other possibilities. But stay with me, let's stick to this example. After analyzing the data and generating reports and putting it in a nice visual form, now Stuart can move on to the last part of the project. Finally, the project is complete. Stuart documents all pertinent information about projects such as app documentation, like how to use it, maintenance processes, and so on, along with the findings and reportings after testing. Stuart presents all of this to Martha and other stakeholders from the hospital and give them a walkthrough of the whole app and explains the reports. And so now is the product delivery time. Stuart carried out all his roles and responsibilities in Martha's project and is ready to deliver the hospital health app to her on time and in budget. Martha, her CTO, and the hospital are all happy with the app. It will help their customers and staff immensely.
Let us understand what exactly predictive analysis is. So what is predictive analysis? Predictive analytics or analysis encompasses a variety of statistical techniques from data mining, predictive modeling, and machine learning that actually analyze the current and historical facts to make predictions about future or otherwise unknown events. So this is the basic definition from Wikipedia. So we basically use the previously collected data to predict an outcome or an event. So typically, historical data is used to build a mathematical model. In our case, we can call it a classifier or a predictive model or a regressor, which actually captures the important trends. And then the current data is used on that model to predict what will happen next or to suggest actions to take optimal outcomes. So let us take a look at various applications where we can actually use predictive analysis. So we can use predictive analysis for a lot of things. First of all, we have campaign management. So let's say we have a campaign, we have to figure out what kind of audience will be there or what kind of our target audience is. So we can analyze the previous data of our previous campaigns that we might have managed previously And according to that, we can figure out some suggestions or the course of action that we have to take. So this is one campaign management that we can do using the predictive analysis. Or for recent examples, let's say an election campaign, a lot of people are gathering a lot of data of previous elections, like how it happened and what are the major factors that led to the winning of some so and so person. So this is how we can use predictive analysis in campaign management. Then there is customer acquisition. So we can analyze the whole business and we can figure out different points to figure out what kind of task or events we can actually produce in order to make our business better, so that we'll be able to make customer acquisition better. And then we have budgeting and forecasting as well. Similarly, taking a look at previous data, we can finalize some budget and forecast few related pointers. For example, we have stock prediction using Python or any other language such as R also. And then we have fraud detection, so we can manage a lot of data. Like for credit card companies, they make use of hundreds and hundreds of users, and they analyze the data to predict or detect the fraudulent transactions in their data. And then there is promotions as well, so we can analyze the target audience. We can follow the trends, like they are following the types of content they're actually going for. And then similarly, you can make promotions according to that. Then there is pricing also, like you can figure out, let's say you have a supermarket, somewhat like what Walmart does. So you have all the pricing and everything. So what you can do is figure out the price of a product after several times based on the recent purchases and also the recent scenario or the previous historical data upon which the price has been distributed accordingly. And you can also plan for the demand as well using the predictive analysis. So these are a few applications that I can think of right now. And these are only a few applications where you can use predictive analysis to predict for example, I'll talk about football, guys. So let's say if you have a favorite player and in the next season you want to see how much price he might go for in certain other clubs. So you can make use of the data at your bay, and depending on the purchases that happened in previous seasons or the windows, you can actually figure out somewhat around what kind of price your favorite player is going to go for. So that is one example I can think of right now. So these are a few applications of predictive analysis. Now let's move on to the next topic of the session, guys, which is steps involved in predictive analysis. So this is a very important concept in this session, guys. So you have to fully understand what kind of steps that goes in while you're doing a predictive analysis. So the first step has to be a data exploration. So what you have to do is gather data, upload it into your program. Then you have to take a look at your data in a perspective which will clear certain things for you. Like you have to figure out what kind of data you're dealing with, what are the columns, what are the features that you have inside your data, what kind of data it is, how many numerical values are there, what kind of data types are there inside your data, is it a CSV file or not, so on. So you have to figure out a lot of things while data exploration. And after that, you can figure out how to clean your data. By cleaning, I mean you have to figure out the redundancies that might hinder your model. So for that, you have to check for null values, you have to check for missing values, and then you have to figure out what kind of columns will be actually better if you put them inside your model, and what are the redundant variables, like what kind of columns that you can actually remove and will not make a difference in your model. So that covers the data cleaning part. And then there is modeling, where you have to model your or you have to select your predictive model, guys. So there are a lot of models that you can go for, but in this session I'm going to use the linear regression model because it's the very simple or the basic one, so that the beginners also will be able to learn it properly. After modeling, you have to check for the evaluation, or you have to check for the accuracy, how your model is actually performing. So let's talk about these steps in a little more detailed way. So we'll talk about data exploration first of all. As I've already told you, data exploration is gathering your data and then taking a look at your data in a perspective that will clear a lot of things. For example, you will be able to see the number of columns, number of rows. You will have a description of all the data types, what kind of variables are there. You will have the mean values, the average values, minimum values, and you can also check for unique values in your columns as well. So this all comes in data exploration. And after this, the second step is data cleaning. And I've already told you guys, data cleaning is basically getting rid of redundancies in your data, which includes the missing values which may hinder. And you have to make sure that your model is not going to cause overfitting or underfitting due to the noise. And noise is basically irrelevant data that may be in the form of null values. So you have to make sure you get rid of them or replace them with average values in the column. And then there is redundancies like outliers, which are not necessarily required in your model, so you can remove them as well. So this is all about data cleaning. And then we have the third step, which is modeling. So for data modeling, first of all, you have to understand the relationship between the variables in your model so that you'll figure out what kind of model you're going to go for. So for example, if let's say if you have a target variable, in our case, which will be a price of certain goods. So let's say you have to figure out the relationship between variables. So if you're going for linear regression, you have to make sure that the relationship is continuous. And let's say if you are going for logistic regression, it is important that you go for continuous variables. The target variable although has to be dichotomous, or what you call it, categorical, which is like, let's say if I'm trying to predict something using the logistic regression, the answer would probably be yes or no, or be 1 or 0, something like that. But in case of linear regression, we have to make sure that there is some continuous relationship between the variables, which is my target variable and my independent variables. Taking a look at the fourth part, or the fourth step and the final step, is performance analysis. So after you're done making a model, so you have to perform certain analysis, which is, checking the accuracy of the model and making sure that it's above 70. I mean, if you're a beginner and if you are trying to make your first prediction model, anything above 70% accuracy score is very good, guys. But I would suggest that if you are working on a good model and if you want your model to be good, the accuracy should be ranging around 0.9, which is more than 90%. And if you get it the first time, it's well and good, but it solely depends on your data and the kind of model selection that you do. So let's take a look at the next topic in our session, guys. So this is basically where I'm going to perform predictive analysis using Python on a data set. So I have a problem statement in which I have a data set which has certain values or certain variables, which has columns like, how many bedrooms does a house have, and what kind of square feet it is grabbing, and all these things that I'll show you in the data. And using that data, I am going to predict the house of a price. So let's take it up to Jupyter Notebook, guys, and I'll show you what I'm going to do over there. So I have a Jupyter Notebook over here, guys. And if you're not familiar with Jupyter Notebook, guys, I suggest you to check out our tutorial on YouTube. We have a Jupyter Notebook tutorial. You will be able to learn it properly. I mean, there's not really so much to learn in Jupyter Notebook. It's quite easy. That is why I'm using also. And we have a cheat sheet as well, so you can go for that. So first of all, I'm going to import some dependencies. So for the first step, that is data exploration, I have to get the data. So for that, I'm going to use the pandas library, and I'll import a few other libraries as well. Like I'm going to use the cborn to check the relationship between the variables, basically for EDA, exploratory data analysis. And if you guys don't know what EDA is, I suggest you to check out another tutorial, which is exploratory data analysis, that we have on our YouTube channel. And then I'm going to import NumPy as well, just in case. All right, and you can see, guys, I have to just press shift and enter, and this is why I'm using a Jupyter Notebook, because the implementation is very easy and I can segregate my data or the code in different cells. So I'm importing this and I can just make it, okay, I'll make it a little bigger so that it's visible to you, everyone. What I can do is I can comment a part, let's say installing dependencies, and it is in a separate cell, so that makes it quite descriptive when you're coding, and when you are trying to figure out what's wrong in your code, it helps actually. So after this, what you have to do is I'll have to import the data. For that, I'm going to use the read CSV module, which is basically going to go to the file and read my data, guys. The name of the file is house.csv. We have a truncated error. Alright, so guys, I have to show you something. So usually when you do this, when you copy the file location, you get that Unicode error. But let's see if I change these backslashes to forward backslashes, what happens? Do I still get the error or not? Okay, we have right. So I was doing something wrong here. So this is one exercise for you guys. Like earlier when I was using the backward backslashes, I was getting a Unicode error, but when I change it to the forward backslashes, I'm not getting that error. So this is one question for you guys. Tell me why you think it happened in the comment sections below. Now moving on, I'll take the first look at my data, guys. So I'll just use the head method to get my first data. So these are the first 5 rows in my data, guys. So I have ID, we have date, the price is there, bedrooms, we have bathrooms, square feet living and square feet lot, we have floors as well. Waterfront is 0, okay, it has to be 0 and 1, I guess. There is view, then grade, square feet above. So these are the columns that I have inside my data, guys. So I'll check the last 5 rows as well. For that, I'm using the tail method. So as you can see, you can get the first look of your data using the data.head and data.tail method. After that, I check the columns of my data, and let's check the shape as well, guys, so that we'll know what we're dealing with. Okay, it's not callable. All right, so we have 21,613 entries with 21 columns. Okay, it's a quite big data set, and let me tell you guys, this is one data set that I found on Kaggle, and it's very easy to find the house dataset, and I'm using this example of house dataset because it's very common, and to find this dataset is very easy. You go on to Kaggle and you just look for house prediction datasets, and it will show you a lot of datasets that you can download there from. Okay, so you can find the dataset on Kaggle, guys. Now we have checked the shape as well. Okay, I'll use one more method, that is data.describe. All right, this is callable. All right, so we have all these numerical values, and using the describe method, we can get the 50% minimum, maximum, and the standard deviation. We can get the mean value and the count as well. So let's say for bedrooms, the mean value is 3. The most common entry in the bedroom section is a 3-bedroom house. And then for bathrooms also is a 2-bathroom house. Square feet is almost 2079 square feet. And then for maximum values, we have even a 33-bedroom house as well, and we have a house with 8 bathrooms, and the square feet is 13,540. All right, so minimum value is we have a 0-bedroom house. Okay, that's going to be something else, and square feet 290. So this is how you use the describe method, and this is the first step, guys. I'm trying to do the data exploration. Now after this, I think I'm pretty sure about what kind of data I'm dealing with. Now what I'm going to do, I'm going to move on to the next step, that is checking for the relationship between these variables. So for that, I'm going to use the data visualization, and I'm going to use a few plot points using the 𝐶born library. And if you don't know about 𝐶born, we have a YouTube tutorial on 𝐶born library as well, so you can find out different kinds of plots that you can use for data visualization. And data visualization is nothing but it's a process where you can visualize your data, and you can try to figure out the relationship between the variables. Before that, I want to check for null values or missing values, because I don't want to get any hindrance in my data set while I'm modeling. So first of all, you have to do check for null values, and let's get a sum as well. So we have 0, almost. Okay, so we have no null values in this data set. So usually if you find a null value, and if it's a big data set, and let's say if all these values are, let's say 2000, and if you have 10 missing values, you can just remove those 10 values. But if there are more null values, I suggest you to replace them with the mean value. And to find out the mean value, you can just go over here. Let's say if you have let's say if you're checking for bedrooms, how many null values are there, and let's say there are 500 out of 21,000. So you can just replace the 0 with this value, which is 3. And similarly for any other column, you can do the same using the mean value. So since there are no null values inside this data set, because it's a very clean data set that I downloaded it from Kaggle, so we're going to move on to the next step, which is visualization. And mind you guys, this is the step in my data exploration part and the data cleaning part, not the other steps that we use for predictive analysis. All right, so I have no null values, but there are a few redundancies that I want to get rid of. I'll talk about that later, guys. First of all, I'm going to use a relation plot. X I'll use. Okay, so I want to check, or my basic aim is to predict the price of the house. All right. So for X, I'll just take price, and let's check the relationship between these variables. So I'll check for bedroom. All right, kind is equal to Okay, we'll not use kind. Data is equal to data. Okay, all right. So I think we can, like, almost, there are so many, I mean, so this is one relationship that I'm getting over here. Price is not very clear, but we are getting the relationship of the bedrooms, or the most common bedrooms, so which is around over here, that is 0 to 5. And similarly I can check for other variables as well, like bathrooms. See guys, so the price is actually increasing with the number of bathrooms, but it's not necessarily same for everything. So there has to be some other dependencies as well, because as we can see, since the bathrooms are pricing, price is not actually rising that much. Okay, I'll just copy this. For bedrooms, the price is actually increasing pretty much with each bedroom. I mean, not really. If we take a look at 10 bedrooms also, the price is pretty much the same. So there's not one decisive factor I can think of for this. All right, so we'll check for some other as well. So we'll check for square feet living. So this is one linear relationship that I'm seeing over here, guys. So with each square feet rising, most of the prices are actually in this area only, like from 0 to 40, 400,000 or 40 million actually. But we can see that it's a linear relationship. With each increasing square feet, the price is actually rising. So this is one thing that has to be there inside our train set. I'll tell you what a train set actually is. Then there is floor as well. We can check for floors. All right. Okay, so floors is actually pretty descriptive over here. So for most of the values are in the 2 floors area, and then we can check for waterfront as well. Okay, we can do one thing. I'll tell you one trick. So we'll add the hue over here, and this is going to be waterfront. So with the houses which actually has a waterfront are in oranges, and the other ones are in blue. So you can see the relationship between them. And similarly I can use other. Okay, so let's say latitude and longitude. So you can figure out the relationship between the variables using the visualization. So for me, I think in this data set, to get the price out, we're going to have to use bedrooms, bathrooms. There has to be square feet. A lot of square feet has to be there. Floors also we can get, and then water view, front view, we'll use. Square feet we have to use, and year built and year renovated we can leave it out from the train set. And zip code also we don't actually need. Latitude and longitude are also not decisive in prediction, because we can use it for visualization, and we can actually get the picture over there. And square feet living is actually important. So these are the redundancies that I was talking about inside your model. So now we'll move on to the modeling part, guys. So what I'll do now is I'll import a few dependencies, guys. So from sklearn. So first of all, I have to import the linear regression from linear models. And I'm going to import linear regression. All right, so I'll import the model selection, import train test split. All right, so first thing that I have to do is I have to segregate my data into a training set and a test set. So I'll do one thing, guys. Right, so I'll get my data in this cell. So two things that I don't actually need inside my data are date, because I'll get the training data, or I'll write it as train. So which is going to be data, and I'm going to drop a few columns. So I'll have to drop, a few columns. So first of all, I have to drop price because it cannot be in my training set since I'm gonna predict it. And then there has to be ID. We don't actually need it. And then I'm going to drop date as well. Does not really prove a lot of things over here. So for now, I'll just remove all these columns. And for our test set or the dependent variable, let's say I'm going to take the variable as a test, let's say. And for this, I'm going to use data dot, or we need actually just one column, that is price, right? Method object is not subscriptable. I'm sorry, I made a syntax error over here, guys. I have to add the axis as well. Now it's fine, guys. So now what I will do is I'm going to segregate my data into X train, X test, Y train, and Y test. And now I'm going to use the train test split method. So first we have train, then we have test, we have test size, which is, let's say, 0.3, and we have the random state is equal to, let's say, 2, right? So we have made our xtrain and xtest method. Now I'll use one variable, let's say regr regressor, and now I'm going to call my linear regression model. It's made, guys. So now I'm going to use the fit method to fit my xtrain and y train data, guys. The training data I have to fit, right? We have no errors here, guys. After this, I can just okay, I'll take one variable, let's say predict, and regr dot predict x test and y test. All right, wait a second, guys, I'm sorry. So now the modeling part is done, guys. So I'll explain what I've done over here. I took the linear model, which is linear regression, and then for segregating my data into training and testing set, I'm using the train test split. Before that, I segregated the data for my model, inside which I'm using the training set, which has all the values from the data set except price, ID, and date. So I've removed these 3 columns because I thought these are redundant for my model right now. And the variable that I'm going to predict over here is the price. So I'm taking that alone. So after that, I use the train test split method to actually separate the data into training and test set. And then I call the linear regression model over here. Using the regression model, I'm fitting the training data. And after that, I am using it to predict a value. So now comes the part where we have to check the efficiency of the model. So for regression models, it is very easy, guys. You can just check the score. For this, you have to provide a few values, x test and y test, and we have the accuracy of 0.70, which is not bad, guys. If you're using the model or the data set this big, it is quite predictable, get this kind of accuracy. But you can do something else to improve the accuracy. I mean, you can look at the data and remove all the values that you find will help you into improving your accuracy. Like you can remove latitude, longitude, you can remove zip code, a year renovated, year built, that you can actually remove waterfront and view as well, or keep only a few values that you actually need, which is bedrooms, bathrooms, I think, and everything related to square feet. That if you keep in your training set, then it's going to be a higher accuracy for you guys. All right, so now that we are done with the session, guys, I want to give you a exercise sort of which you can do for practicing this. So I have used the linear regression model over here. So I want you to do one thing, guys. Check out other classifiers and regressor models that you can use to predict a value. I mean, we have a tutorial on all of them on our YouTube channel, and see if you can use the same data to make a prediction model using other classifiers like a random forest classifier. Then we have a decision tree. Then you can use the logistic regression for this as well. I mean, if you have continuous data, then you can go for linear regression. But if you find a categorical data, let's say we have waterfront or not, so you can check for that as well.
To start with, we are going to start with the statistical functions. The first one is average function. What does the average function do? It's an inbuilt function in Excel that is categorized as statistical function. Average does exactly what it says and works similar to sum. It will return the average value of the given series of numbers in Excel. Let's say we need to identify the average salary paid to the employees in the organization. Where is our salary data? In the H column. So what I'll do is I'll enter the average function followed by the open bracket. In the cell, we need the result. In our case, it is J2. So I start with an equal to, I enter average, open the bracket. Now I'll have to select the range of cell for which I need the average. And in our case, it is the salary column, which is H to H. I close the bracket and press enter. I get the average salary as 15,538. This is the average amount paid to each of the employees in the organization. The next function in our list is the median function. The median function is again a statistical function which returns the median of a given number. What is median? It is a middle number in the set of numbers. That means if I have 10, 12 and 15. So there are three numbers that I have to identify the middle number from this. So is equal to, I'll use the median function here just to identify what is the middle number and then select the range of cells that has numbers. Close the bracket, enter, it will give me the middle number, which is 12 in our case. Because it is not the highest, it is not the lowest, but the middle value. The same goes if I want to know what is the middle value in the salary column, I'll use the median function in cell L2. Is equal to median, open the bracket, select our salary column, which is H to H, close the bracket and enter. 15,750 is the middle value of the salary column. Next we're going to see is the mode function. The Excel mode function returns the most frequently occurring numbers in the numeric data set. This function only works with numbers. It will identify amount or the number that occurs maximum time in the range of cells. So for example, here we have the basic salary where I can see the highest number is 49,000 and then there are few employees earning the same salary, but I want to identify which salary is being earned maximum time by the employees. So I can use the mode function as equal to mode, open the bracket. It is only mode. Select mode, open the bracket and then select H to H column because I want to know from the salary column. Close the bracket. 17,500 is the amount that occurs maximum time in this cell ranges. Moving on to the next one is the standard deviation function. What is a standard deviation? Its a formula is to identify the standard deviation of the set of numbers. The standard deviation function calculates the standard deviation in the sample set of data. Standard deviation is a measure of how much variance there is in a set of numbers compared to the average of the numbers. Standard deviation .s function is meant to estimate standard deviation in a sample. If the data represents an entire population, use the standard deviation .p function. So we will look at a standard deviation sheet. Here I have a sample data. So sample of few students have been picked up who have scored a particular number or a particular marks in the different subjects. So we have taken a sample and we have not picked up all the student data. So if we are using it for a sample only, we will use the standard deviation, which is standard deviation .s. It estimates standard deviation based on the sample. Ignores logical value and text in the sample, so it has to be only numbers. Okay, so it's standard deviation .s when you have a sample data where you just want to identify how much variance is there as compared to the average, you will use the standard deviation .s. But if you have a full population, that means if you have all the marks of all the students in the school or the college, you will have to use standard deviation .p, which is also there here. Calculates the standard deviation based on the entire population given as an argument. But here we are using the standard deviation for a sample data. So I select that, and then for which I need a standard deviation, I'll just go and select that particular range. I close the bracket, I press enter. It is giving me 4.89, which is a standard deviation value for that scores. So this is how your standard deviation works. Next function that we are going to see in our list when we are going through our function list is our large function. What does a large function do? Large function returns the nth largest value from the sample. For example, if I go back to my data where I have the salary data or the employee salary list, I have to identify what is the highest salary that I'm paying. I can do it by using the sort and function, but it can be that as of now I have sorted this data, but later on this person Asha Trivedi has moved to a different department. Director Sheetal Desai has left and Asha Trivedi has moved into being in the board of directors list. Not only Asha, we have also identified Bharat to move into the board of directors. So now we have two board of directors, but both their salaries will be a little different. Say I will change the board of directors salary to 51,000 for Bharat, and for Asha Trivedi it is about 60,000. So this is the salaries that we have decided for the board of director, which are two board of directors. Now, in this case, if I have to see the first value, first find out what was the largest value in the salary section without changing the two values that I had now. So is equal to large, open the bracket, I'll select the array which is our salary, and K, when I say, what does the K mean? K mean I have to tell which highest number. That means if I want to know the first highest value or the first largest value from the list, I can put the number as 1. But if I don't want to know the first largest, I want to know the second largest salary paid to the employee, I will press number 2. Close the bracket, enter. Now if you see, our largest value is actually 49,000. However, the answer that you get is 24,500. Why? Because we are looking at the second largest value in the range of cells. If I am looking at fifth largest value, I'll put it as 5 and press enter. It will give me the fifth largest value in the set of cells, so which is 22,750. Like in our example where I mentioned that Asha Trivedi is now moving to the board of directors. Let's not remove Sheetal Desai for now. She's still there in the board of directors. We also move Asha Trivedi to the board of directors list, and this time the board of directors salary that I'm moving to is 60,000. So when I say the board of directors salary is 60,000, when I move this salary now and say that which is the first largest salary, the first largest salary will be 60,000. The second largest salary will be 49,000 instead of 24,500. Why? Because now there is even one more larger salary. The first largest salary has become Asha's salary, which is 60,000. Earlier it was 49,000 was the largest. So this way, if you keep on changing anybody else's salary, say I make it to 65,000 just to get a gist of how it works. If you will see that earlier it was 49,000 was the largest. Now the 60,000 has become the largest salary or the second largest salary. Same goes with the small. I am trying to identify what is the smallest salary that I'm paying or the lowest salary that I'm paying to the employee. Now again I have to give the K value. Now K value again, like I said, it will be the value of which smallest number that you want. Is it the first smallest that you want to know? Is it the second smallest that you want to know or the lowest that you want to know? Is it the third that you want to know? So according to what is your requirement, you can put the number there as, say if I put 2, so it will give me the second lowest salary paid to the employees in the organization, which is 7,000. If I make the lowest salary as even more lower, so let's see what is our lowest salary. It is 5,950. Let's make one of them to 5,500. What will happen is now if I go back and see the second lowest salary value, it is now 5,950 because the first has now changed to 5,500. So depending on how your value is, which is your lowest salary, it will automatically calculate and give you that number. So moving on to the next one, which is our correl. What is correl? Or it is the correlation, you can say. We can use the correlation function in Excel to find the correlation coefficient between the two variables. I'm sure we have all learned coefficient correlations in our college days when we were doing maths in the college. If you had opted for maths in college, you would have done the correlation coefficient. However, if you're not done it, which is not a big deal, the Excel is already doing it for you. Correlation coefficient formula are used to find out how strong a relationship is between the two data. Like here in our case, the relation between the age and the relation between the glucose level of the person. Is it that the age increases and the glucose level increases, or is it that the age decreases and the glucose level decreases, or is it that the age increases and glucose level decreases and vice versa? So depending, we are trying to understand what is the relationship. Formula always returns a value between -1 and 1. What is the relationship of -1 and 1? Why is it always giving you in -1 and 1? And how is it bifurcated or split? If your relationship is 1 or close to 1, rather I would say 0 to 1, it would indicate a strong positive relationship. A correlation coefficient of 1 means that for every positive increase in one variable, there is a positive increase of a fixed proportion in the other. For example, shoe sizes go up in perfect correlation with the foot length. So when your foot length increases, your shoe sizes increases. So it's a proper correlation. That is when your one correlation, it is exactly how much your foot sizes increases, your shoe sizes increases. If the correlation coefficient is -1, it indicates a strong negative relationship. A correlation coefficient of -1 means that for every positive increase in one variable, there is a negative decrease of the fixed proportion in the other. For example, the amount of gas in the tank decreases in perfect correlation with the speed. Every time the amount of gas in the tank decreases of your car, so when you're running the car, if you're increasing the speed, your gas keeps on decreasing. Why? Because you're increasing the speed, so the gas is getting used or your fuel is getting used, and that's the reason the fuel is decreasing but your speed is increasing. So there is an opposite reaction. Fuel decreases but your speed increases. That's how your coefficient correlationship works if in case of -1. If the result is 0, it indicates no relationship at all. 0 means that for every increase, there isn't a positive or negative decrease. The two just aren't related. Anything that is 0, no relation at all. 1, where there is a positive relation. That means with the increase, the other part will also increase. While with -1, it is the opposite side. With one increase, the other one will decrease. That's the three differences that you will see. Of course, you will not get the result as 1, -1 or 0. It will be in between. So we will try and understand that if it is between 0 to 1, then it is a positive one. If it is between -1 to 0, then it is -1. And if it is 0, then it is no relation at all. So let's see an example in our sheet where I have the age considered as the X value, age of the person, and then I have the glucose level of that person as considered as Y. We are just trying to identify what is the relationship between the human age and the glucose level in their body. So if you see the human age, the X level, it says 43, the glucose level goes to 99. 21, the glucose level shows as 65. But does it make sense by just looking at it? Because we can't identify what is the relationship. Is it -1, is it 1, or is it 0? So to identify that, I can use a function called correlation function, which is correl in Excel, in the cell where I need this result. So is equal to correl, open the bracket, and then I will select the different arrays for which I need to identify the relation. So first relation that I have to identify for is the age. So I will see that age against glucose level. So the age is sitting in B2 to B7. So I'll select that as the first array. The second array is C2 to C7. So I select that second array, which is C2 to C7, and close the bracket. Press enter. It is giving me a value as 0.53 if I remove more decimal places that I have. So our answer is 0.53, which is a positive result. That means there is a close relationship between the age and the glucose level. When it is positive, it means that the increase in age does increase the glucose levels in the body. If this was a negative point, then it would have been the other way around. That increase in age reduces the glucose level in the body. So this is how your correlation function works. Let's see another example that we have on our sheet, which is a correlation function. We have the price of the stock A that changes, or the percentage change in the price of stock A. And then we also have S&P 500 weekly change, or the percentage change of S&P 500. The S&P 500 is a stock market index that tracks the stocks of 500 large cap US companies. It represents the stock market's performance by reporting the risk and returns of the biggest companies. So what are we doing here is we are identifying if there is any relationship between the S&P change and the stock A change. So if there is a relationship, they will be able to take a proper decision in the future when they are making some investments. So to start with, I am going to find out the correlation. So I'll do is equal to correl, open the bracket. Now we have two set of data, which is two arrays. So I'll select the first array as this one, which is C5 to C24, comma, the second array will be D5 to D24. I close the bracket, I press enter, you will see that it is very close to 1. So it is 0.89 or rather 0.9. This means that every time there is a 1% increase in the S&P 500, then there is 1% increase in the stock A prices. Similarly, if there is a decrease in the S&P 500, accordingly the stock prices of A will decrease by 1%. That's how the exact correlation is. While in the previous example, there is 0.5 correlation. That means when there is a 1 year increase in the age, 0.5% of increase in the glucose level. So that's how the correlation is identified using the correl function in MS Excel. Next, we are going to see the charts in Excel. What are charts? When you want to graphically represent some data, it is very difficult to interpret Excel workbooks that contains a lot of data. Charts allow you to illustrate your workbook data graphically, which makes it easy to visualize comparisons and trends. Excel has several different types of charts, allowing you to choose one that best fits your data. In order to use charts effectively, you will need to understand how different charts are used. So we will start with the column charts. So you'll see all these different types of charts that we are going to learn today. So to start, we'll go back to our example sheet where I have the sheet for column chart. That means there is a data that is already available where I have the data for the region along, or rather the sales data for each region, which is split into 2 years, which is 2016 and 2017. This data is in millions. So you can see that the Mumbai has done a sales of 65 million in 2016, while it has done the sale of 70 million in 2017. Same goes with London. It has done 55 million in 2016, while in 2017 they have done 65 million. USA, you can see 45 million and 52 million. While if you see Nagpur, you will see that the sales have reduced from 2016 to 17. Here, this is smaller data, so you're able to even identify where it is going wrong and how is it related, how is the comparison done. So instead of doing that, if you want to send it to your management, you can just select this data and create a chart that will show exact comparison on your screen and it will represent it graphically. So how do I do that? I go to insert. In 2016, there is a new option that has come up, which is called as a recommended chart. That means whenever you select any data and then click on insert, it will give you an option as recommended chart where the Excel will recommend you the types of chart that will look good with these kind of data, or rather it will properly represent this data which you are looking at. So I select the data that I want the graph for, and then I go to recommended charts. When I go to recommended charts, you will see that there is the first chart that it is recommending is the column chart. This is your column chart. But as we are now seeing the column chart to start with, or each type of chart, we will start with the column chart for now, and then we'll come back to the recommended charts. So you'll see the first one, the column chart is here given in the icon for 2016. First 2D chart that you can see is the column chart. I click on that and the data is coming next to one another. When is the column chart really useful? The column chart is useful in such kind of datas where there is a comparison required. So column charts use vertical bars to represent data. They can work with many different types of data, but they are most frequently used for comparing information. Like in our case, 2016 and 17. So I have got this data as column chart and it is comparing between the 2016 and 17. Now looking at this chart, it looks very nice. However, you will see there is something missing, as in when I'm looking at the data for Mumbai, If I don't see this table, I will not be able to identify what is the real sale done by Mumbai. I'll have to mouse over it to get the number. When I mouse over it, it says series 2016 point Mumbai, value 65. It gives you all the data. However, if I am just outside this data, I will not be able to see the information in one go. It just shows which one is the smaller value. In Gujarat, I can see that in 2017, they have done less sale as compared to 2016. But I need the exact number. So for exact number, what I can do is, one way of doing that is I can go and look at it by doing a mouse over it. Another way to do that is to just see it. I can add the data labels. How do I add a data label? There are different ways to add a data label. One way to do that is first select where you want to add the data label. Say I want to add the data label for 2016 and 17, both the bars. So I cannot do it together. So what I can do is I can select one at a time by using the left click and then right click on that same data and then click on add data label. Once I do that, it will add those numbers on that data. Secondly, I can do it for 2017 also by selecting it. However, there is another way of doing it. If I now want to delete the data labels, I'll just select and click on delete from my keyboard and it will work. Now, I do not have the data labels here. I want to add it using this plus sign. It's only available in 2016. When I select the chart, there is an option as a plus sign. I click on plus and I click on data labels. It will automatically add data labels for both the bars. I don't have to select each of the bars. This is how your data labels are added. Now, if you can see, there is an axis Y which is given here, which has some numbers. Why those numbers are there? Because earlier we did not have data labels, and that's the reason we could see with these numbers where our data sits. So just above 60, somewhere between 60 and 70. So I assume that it is 65. So that is how it was showing. However, now that I have the data labels, I will not need this information, or I will not need this access on the left hand side. So how do I remove that access from the left hand side that you can see there? There are, again, one way of doing that is going to the design mode, which is after you select the chart, go to design mode and then under add chart element, I will see axis, which is the x-axis that we used to call. Another one is the primary vertical axis. Vertical axis is the vertical which is on the left hand side that we were just talking about. This one. This is your primary vertical and this is primary horizontal. So I want to remove the primary vertical. As of now, both are highlighted. That means both are there. I want to remove the primary vertical, so I select that. It just goes away. That's one way of doing it. Easier way or the quickest way to do that is just select the axis. Be very careful that only the axis is selected. You will see that 4 small ball kind of a thing that comes on the 4 corners of that axis. Once I do that, once I select that, I can press delete DEL from my keyboard and it will go away. Third thing that I can see on this chart is the chart title. I have to add a title to this chart. So how do I add a title? It is already there on the list. I just have to add the title. I select the data there and add the title as sales comparison or sales for 2 years. And in the bracket, I'll put in millions so that they don't get confused that why is it showing as only 50, 40 or whatever. So this is how I can show my data. One more thing that I would recommend doing is removing these grid lines. The grid lines will be more useful when you don't have the data labels, because then it gives you where exactly your data sits. With the y-axis, you'll be able to see the number. But when I don't need this grid lines at all. So I'll just select the grid lines and then click on delete on my keyboard. That's one way. Another way to do that is just go to that plus sign and press the grid line. Grid lines are there by default. Now if you see the data, it looks even more cleaner or it looks even more presentable because there is no grid lines at the back. It's all clean. This is how you can tweak your data as per your requirement. This is how your column chart works, but you can do the same thing with the other charts as well. There are other quick things that you can do with the chart is by also changing the chart type if you want to, or changing the data that you have selected. So you have selected this data in order to get this chart. However, I want to change the data. So I can click on that design. Under design, you will see under data, select data. Once I click on that select data, it will give me an option here to change the data range for the chart. So I can click on this data range to change the chart. Very important part that you will see here is switch row or column. So what happens is, as of now, my y-axis only contain the numbers and the x-axis contain the Mumbai, London and everything, and the data which is the colors or the bars which are there that are in the colors. That is 2016 and 17, which is the year is showing in two different bars. Now, when I click on this switch row and column, what will happen is all the region which is there will become your color of the bar or different bars, while your 2016 and 17 will come on the x-axis. Let's see how that happens by just clicking on switch rows and columns. Once I do that and click on OK, you will see that 2016 data is showing under the x-axis and all the bars are showing now with the regions. This also can be done. However, in this case, it is a little difficult to identify or do the comparison between the 2 years. You can do comparison between in 2016, what is the sales that you have done for each region. That kind of a comparison can be done to identify. If you see, Gujarat has done the lowest sale in 2016. While again in 2017, Hyderabad has done the lowest sale. So this kind of comparison can also be done, but depending on what kind of a comparison you're looking at, you can always click on switch row and column. You can also use this button to switch row and column. Otherwise, you can click on select data and then use this information. This is how your charts will work in Excel and how you can add new data into or data labels, how you can format your data using the different data sets under design. Moving on to the next chart, our next chart in the list is the line chart. Line charts are ideal for showing trends. Like you have in our list, I have the number of days and the temperature that is changing as per the number of days. On day 1, so we are trying to say maybe in December. So in USA, we have this days. If you are trying to see that on day 1 of December, if I start with day 1, what was the temperature and how is it going up or is it going down? So that kind of information, if I'm trying to identify, I can use the line chart because the line chart will give me a kind of a trend on different days. So how do I create a line chart? When we have the data where we have to show the trend in a particular time frame, that time we are going to show it as in the line chart. Like for example, in our sheet, we have the days from day 1 to day 6, identifying what is the temperature like in these days. So we have a trend, like in this first day it is 43, the next day is 53, third day it is 50, then fourth day it again goes up by 57, fifth day it going up 59, and then sixth day again it is 67. We're just showing a trend of the data. In that case, I'm going to use the line chart. So I'll use the line chart by selecting the data. It is giving me the line and it's showing you how it is going up. So it starts with the day 1, it is lower, then it goes higher and then it keeps on going higher, higher, higher. Only in the day 3, it dips a little down, but it keeps on going after that. This is how your line chart works. So whenever you have this kind of a data where you have to show a trend, we are going to use the line chart. What is the next one? The next one is a pie chart. Pie chart make it easy to compare proportion. Each value is shown as a slice of a pie. So it's easy to see which value makes up for the percentage of the whole. So for example, I have this book type, which are the book types that is being sold by the bookstore, which is the classic, mystery, romance, science fiction, and spiritual. The revenue that is generated out of these books are also listed here. For classic, it is $18,500. By mystery, it is $78,970, and so on and so forth. I'm trying to identify what is the total revenue that I have generated, which book type is giving me the maximum revenue, while which book type is giving me the lowest revenue. To do that, I can use a pie chart because it's going to give me the part of a pie. Like here, you will see that the orange part is actually the mystery part. Mystery is being sold maximum time part of the time, and the revenue is also generated. Now, similarly, like we did it for the column chart, you can also use the data tables in the pie chart as well. How do we use the data tables in pie chart? By again using that plus sign on the right hand side or just right clicking and selecting the add data label. As of now, we'll use the plus sign and click on the data labels. Once I do that, the data labels will be added on the list. Now in this case, the numbers are being added. However, I also want to add the chart title. The chart title is also already mentioned as the revenues. So we can leave it as it is. If you need to change that, you can always double click inside and start changing the name of the chart as well, or the chart title. In the data labels that we have added, you will see that only the numbers have been added. I have to check which color belongs to which in order to see where does the highest number land. So if there are bigger lists, there are only 5 different lists, so that is fine. So if there are about 10 to 12 lists and you want to see which one belongs to which, it is a little difficult to identify that. So what I can do is I can add the chart labels on each of them, like a data labels. I can also add the labels on each one of them to identify how does that look. So how can I do that? By going to the data labels in the add chart elements and then click on more data labels option. As soon as I do that, a new window or a new level has opened up on the right hand side. I can select the category name. What will happen is as soon as I select the category name, it automatically gives me the category name in the list. Now the category name you can see is separated by a comma and it is coming next to each other. If you want to change the separator, you can use any of these as a separator. I can use new line. So what will happen is the number will go in the new line. So it looks a little better. Again, like the earlier one where we removed the x-axis, in this case, now we have added the names on the chart itself. So I can remove these legends from the bottom. So it looks a little cleaner. Now I can even make this a little bigger because we have enough space to make it bigger as I have removed the legends from the bottom. So this is how your pie chart will look. Moving on to the next one. The next one is a bar chart. Bar chart works just like the column chart, but they use the horizontal bars instead of the vertical bars. Where is it useful? But it is useful in the data where you have the bigger names of the headings, like in this case. Yes, the inbound marketing demonstrator ROI. If I insert the normal column chart like this, now your the data is smaller, so it is just giving you in that same line. However, if you have a bigger data, or even it will look better if you have the bar charts, which is shown in the horizontal level like this, because you can clearly read the headings here on the left hand side and your bar charts goes on the right. Again, removing the grid lines, adding the data labels will remain the same. Moving on to the next one, that is the surface chart. What is a surface chart and how is it useful? Surface charts are useful when you want to find the optimum combination between two sets of data. Like in our list, we have the marketing, finance, and effort, and they are which field is used or which department is used to get these details, like recruitment, how much you have to recruit in these 3 departments, which is the financial, marketing, and the effort. How much contribution is of the environment in the financial, marketing, and the effort. How much assets are there in the financial, marketing, and the effort, and the building, how much is there in the expenses that has been formed part of these 3 departments. So if I want to know these, so I'm trying to combine the recruitment part, I'm trying to identify the combination of marketing, finance, and effort, how much recruitment has been done in the combination of all 3. In this kind of a situation, I'll be using the surface chart. So how do I use the surface chart? Where is it located? Again, if I go to recommended chart also, I'll be able to see the surface chart under recommended chart. Under recommended charts, there is a window or tab called all charts. I can select that, go to surface. Here I'll get that option of 3D surface. I click on OK, you will be able to see the surface chart here. So it gives you the effort, marketing, and finance. So you will see that the combination of the recruitment here, which is this part, is showing your total recruitment done for all the 3 departments. Same goes with environment, how much environment is affected due to finance, marketing, and effort, asset that has been used by these 3 departments, and so on and so forth. So how we are adding the values to this. So this is how it shows. You can again remove the grid lines if you want from this list so that it looks a little better. And it also gives a number as 0 to 200 as blue, which is this part, because the 200 only is affected. When I say 0 to 200, this is the effort is 159. That's the reason it is showing as 0 to 200. The second one is marketing, 200 to 400, which is 345 in case of finance. So that's a little bigger. It is showing here the orange one. The next one is actually your gray, which is 400 to 600, which has got a little even bigger. So this is how your data is identified by using the surface chart. Moving on to the next one. So we have learned how the charts work in Excel and how you can make a little bit changes in order to identify the best chart that fits into it. You can also use the change chart type option to change a particular chart. So if you think that the surface chart is not fitting into this, you can select the chart and click on change chart and then use one of these recommended charts from the list. This is how we learned the charts today. Let's move on to the next one, which is the pivot tables. What is the pivot table and how is it useful in your day-to-day life? Many people have the idea that building a pivot table is complicated and time consuming, but it's simply not true. Compared to the time it would take you to build an equivalent report manually, pivot tables are incredibly fast. If you have well organized source data, you can create a pivot table in less than a minute. So let's see how you can do that. First of all, I have a sheet with all the data information there. Like in our sheet, I have the list of employee code, their names, so department, region, branch, and their salary information. I am going to create a pivot table in order to show the different departments' salary, how much salary are we paying to different departments. However, before I do that, I'll have to show you how to create a pivot table. To create a pivot table, I first will go to the database for which I need to create the pivot table. So I go to the database, I click on insert. After I click on insert, there is an option called pivot table. I click on pivot table. A new window will pop up. In the pivot table wizard, I have to select the table or the range for which the pivot table is to be created. So I select range A1 to H101. The next one that I have to select is either the new sheet or the existing sheet. New sheet, that means when I click new sheet and click on OK, it will automatically create a new sheet in the existing workbook and the pivot table will be placed in that new sheet. However, if I click on existing worksheet, I have to give a new location. That means the sheets that I already have on the workbook, from that sheet, which cell do I need the pivot to be placed? Hence, I will click on the location and select the location that I need the pivot table on. I can select from any of the existing sheet that I have on the workbook. However, this time I'm going to use a new worksheet and click on OK. This will create a new Excel sheet for me just before the Excel sheet that I was working on currently. So it is now creating that Excel sheet. Once the Excel sheet is created, on that sheet you will see the pivot table wizard is already available, or a blank space where it will show you the pivot table number. And on the right hand side, you can already see the pivot table fields that are shown. Under the pivot table fields, all the headings which were there in the database have already occurred here, like employee code, first name, last name, department, region, branch, hire date, and the basic salary. So everything is already showing here. Now, before we start with the pivot table, we need to understand these 4 fields that are there on the pivot table. So every field has its importance. So let's start with the values area, which is this one. The values area is the large rectangular area below to the right of the column and the row heading. The values area calculates and counts data. That means anything that you enter here, it will give you the calculation of that value. For example, if I pick salary, which I drag and put it on the values column, it will automatically give me the sum of the salary. You can see it says sum of basic salary. That means the total salary that has been paid. You can change this to any other field. For example, if I click on this and click on value field setting, I can then give other calculations, right? Count, average, max, min, standard deviation, anything that I need in this field, I can select and give that option. If I don't want the sum of the salary, I just need to know the count. Can click on count and it will give me the count of that cells which has the salaries. So I click on sum for now. The data field that you drag and drop here are typically those that you want to measure. Fields such as sum of revenue, count of units, or average of price. Row area, which is this part. Placing a data field in the row area displays the unique value from that field down the rows on the left side of the pivot table. That means because I said that I want to do it at the department, when I drag it to the rows, it will pick up all the unique values. So even if admin is coming 10 times in our database, like admin comes a lot of times here, it will only show once in the pivot table. Same goes with CCD, same goes with director. What does that mean? It will group all the admin together. Then it will sum the salary of admin, the next cell where I have done the values, and it will give me the answer here. So it will giving me the salary for only for admin, then for CCD, then for director, finance, marketing, personnel, R&D, and sales. This is how your database will look if you put the data into the rows area. Next is the column area. The column area is composed of headings that stretch across the top of the column, which is this. So if you want to give a heading other than this, if you want things like region to be shown in the column, if I put column, what will happen is Now it will show me the east, west, north, south. It will be split as per the east, west, north, south in the column, and it is kind of heading that is given on the top. Like for East and Edwin, this is the total salary. This is how it is giving you the split. Next one is the filter column or the filter area. Filter area is an optional set of one or more drop-down list at the top of the pivot table. Here the filter area contains the region field. The pivot table is set to show all the region like this. If I put it on the top here, it is actually an optional area, but it will only show me the region on the top. Then it will not show in the column. The filter area allows you to easily apply filters to the pivot table. For example, if I leave my region here and try to put a branch in the filters column, I can select which branch I need the data for. For example, if I need only for Ambala, I can click on Ambala and click OK. It will only give me data for Ambala. Same way, if I select the rest of the other data, it will give me the list for other. If I want more than one data, I'll just click on select multiple items and I can select 2, 3 at a time and then it will be filtered as per the branch and give me the rest of the data. This is how your pivot table actually works. Like I said, you can use these value field settings to get the other calculations to be done with this value field setting. This is how your data or the pivot table works. Now, this was a simple part of the pivot table. If you ever want to sort on the pivot table, let me first remove the region to make it look easier. So to understanding will be more easier. I'm removing the branch from the filters as well. I'm just leaving the department and the sum of the basic salary. Now what I'm trying to do is I'm going to filter as per the salary. So I want to understand which department I'm giving the maximum salary. I select the salary column or I just click or keep my cursor in the salary column. I go to data and the same way as we do the sort, I'll just click on sort there. Once I do that, it will give me a wizard where I have to select whether you have to sort as per smallest to largest or largest to smallest. I will do is largest to smallest. And I can see that in the sales department, I'm giving the maximum salary, which is 3,45,075. So this is how your sort works in the pivot table. So there are other things that you can also use in the pivot table, which are really, really important that we are going to see here. There is something called as a slicer in pivot table. What is slicer in pivot table and how does that work? When you go to analyze data, there is an option called as insert slicer. If you are anywhere outside the pivot, you're not keeping your cursor in the pivot, you will not be able to see the analyze button. To go to the analyze button, you have to click on the pivot table and then click on analyze. Once you click on analyze, there will be an option called as insert slicer. Now, insert slicer in the sense it's a kind of filtering of data. So the same way, similarly, like I did it for putting the branch on the top or the region on the top where I could filter the data, I can use the slicer to filter this data. So if I click on slicer and select which field I want to filter it with, like if I want to filter it with the hire date, I can select an hire date and click OK. Now it will give me a slicer or the list of hire dates which I can select from. So if I select only this hire date, it will automatically give me data for only the employees who have been hired on this particular date. So this is how your slicer works. However, now you can see that in the slicer, okay, I can only select one data or one date at a time. But if I want to select more dates, then there is this something called as multi-select, which is on the top right hand corner. This is only available in 2016 version. So when I click on multi-select, it will give me options to select multiple dates at a time in the slicer. So it is not necessary that you have to only do the dates. You can also add some more information other than just the dates. Click on analyze, I go to slicer again, and now I can select anything else that I want. Now department is already there. I can select maybe branch this time. So it will give me another slicer. So you can see the another slicer which is there here. So there are two slicers now. So not necessary that you have to only work with one slicer. You can work with two slicers or multiple slicers. I select Calcutta and Darjeeling and it gives me data for the Calcutta and Darjeeling for these two dates only. If I select one more date, it will give me data for Calcutta, Darjeeling for these 3 dates. So the slicers can be multiple slicers on the list and it will give you information as per your requirement. How to create a chart from the pivot table. And it also looks the same as a normal chart. So when I click on the database where I want to create the pivot table from, and I then click on the pivot chart by going to Analyze button and then Pivot Chart, it will automatically create the chart that I want to. Similarly, as we get the column chart in this case, so I click OK. Once I do that, it will automatically create a chart. In the chart, you can, similar to the normal chart, you can give the name as a chart title that we are looking at. Add the data labels by clicking on this plus sign and click on add data or just add data labels. Once you do that, the data labels will be added. All these fields which you can see, sum of basic salary, department, if you don't want to show it on the table because it is a pivot tables chart, it is giving you these information also. If you want to just hide that, you can right click and click on hide all field buttons from chart. It will automatically hide those fields. Now if I add any additional information, like in this one, you can only see that the sum of the basic salary is given. There is nothing on the row columns. So what I can do is I can also add data in the row. Once I do that, it will automatically update the pivot chart as well and give me the information as per the row column also. Now, again, like where we had used or changed the chart type by selecting the data and switching the row to column, you can use a similar function here to switch from row to column. So here the data will show in a different way altogether. So as you update your pivot table, your pivot chart also keeps updating. And all the same functionalities that is available in the normal chart is also available in your pivot chart. The only difference is that it is linked to your pivot chart, the other data is linked to your database. That is the only difference. But pivot chart, when you are looking at that, it is very, very useful because your pivot chart is on updating as per the new data that is updated there. Also, you are only giving the information or you are only requesting the information that you want in the chart rather than everything coming into the chart and then you selecting which parts you want to display. So that's how your pivot table and the pivot charts work. If they are really, really useful in your day-to-day reporting that you do for your companies, and it will really help you to do that. Now we have also learned how to do the pivot table and how to use the slicers in the pivot table. There is another important part of the slicer is that you can link two pivot tables to the slicer. For example, here I have one pivot table which is splitting the department and giving you the total salaries as per each department. Now I'm creating a new pivot table from the same database. Say I just copy and paste, that will also give me another pivot table. But I do not want department. This time I want to know the salaries given to the employees in different regions. So this is split as per the region. The slicer that I can add here is by clicking any pivot table I can select and then click on slice on analyze and then click on insert slicer. The slicer will be as per the region or the date or the last name, whichever you want to. As of now, I'm selecting the branch and click on OK. Once I click on branch, it will give me the options of the branch with which I can select and analyze the data. But what I need now is I want to link this pivot table, which is a pivot table 2, to pivot table 1. That means when I select Ambala, you will see that only second pivot table has given me the data for Ambala, which is the north region. The first pivot table stays as it is because this slicer is only linked to pivot table 2. I want to link this slicer to both the pivot tables. How can I do that? I will have to click on the slicer, right click on that, then click on report connections. Once I click on report connection, it will give me the list of pivot tables available in your workbook. Now we know that in the sheet 1 we have both the pivot tables. Sheet 10 is not our sheet. So both the pivot tables are in sheet 1. So I'll select both the pivot tables from sheet 1 and click on OK. Once I do that, now I will be able to link both the data. And now when I select Bangalore or one branch, it will automatically give me data for that one branch. Just like that, �:𝐿, it will be giving me data for that one branch. Same goes with Ambala or Aligarh, and if I select more than one, it will give me all the ones selected and give me data for that 2 or 3 branches that I had selected. So basically what I'm trying to say is you can connect 2 or 3 pivot tables to one slicer so that you will be able to get the filters with one slicer for both the pivot tables. So this is how your pivot table is, or the slicers are useful in case of trying to get the filters for your data. The next topic that we are going to see today is the data analysis using Excel. So how do you do a data analysis using Excel? So there's something called as the analysis toolpack in Excel through which you can do the data analysis. The analysis toolpack is an Excel add-in program that provides data analysis tools for financial, statistical, and engineering data analysis. To load the data analysis toolpack, you have to execute some steps in Excel. So how do you do that? Let's go to our Excel. On the File tab, I click on the Options. Once I click on the Options, under the Add-ins, select the Analysis Toolpack and click on OK. So when I go to Add-ins, under the Analysis Toolpack that you see here, under the name where you see Add-ins, select the Analysis Toolpack and click on Go button or click on OK button. Once I click on OK button, what happens? It will open the new data for you or the new window for you. Click on Analysis Toolpack and click on Go. Once I click on Go, it will give you that option of Analysis Toolpack, Analysis Toolpack VBA, Euro Currency Tools, and the Solver add-in. I will add the Analysis Toolpack and click on OK. Once I do that, now I will be able to see that under Data, there is something called as Data Analysis added to my ribbon. So you can now click on the data analysis to create your different analysis that you want to do from the list that you have. Now let's see how we can create data analysis using the Excel data that we have. So what do we have here? On our Excel sheet, I have a list of data like I have the quantity sold, the price of the product, and the advertising. Now this example teaches you how to perform a regression analysis in Excel and how to interpret the summary output. So now in the below data we can see here on the list, the book question is there a relation between the quantity sold and the price in the advertisement? So what is it? Is there a relation between this and the output is? So what are they trying to understand is if this is the price and this is the kind of advertisement that we are doing, or this is the amount that we are spending on the advertisement, is the quantity sold increasing or decreasing, or any relation that we are able to see? So can we predict the quantity sold if we know the price and advertising? So if I know only these two things, can I predict what will be my quantity sold? That is, to do such kind of analysis, we can use this data analysis toolpack. So I go onto the data tab in the analysis group and click on data analysis. Now select the regression from this list and click on OK. Now there is a range that supplies some basic regression statistic. So how do you do this? Now there are two things that we have to give: the input Y range and the input X range. This will always be by default blank, and we have to give the ranges to the Excel. So how do you give the range and how do you decide what should be the range? So the first thing that we'll give to Excel is the Y range. Select the Y range A1 to A8. This is the predictor variable, also called as the dependent variable. So this is something that we have to predict. It is dependent on these two things. We don't know the quantity sold. We are trying to understand what will be the quantity sold if we have the price and the advertising. So your dependent variable will be your Y range, which is your A2 to A8. Second one that you have is the X range. These are the explanatory variables. These are also called as the independent variables. These columns must be adjacent to each other. So whichever you're selecting. So I am selecting C8. These two should be adjacent to each other. Now I have to ensure why I'm taking these two things, because these are my independent variables. That means this two I know and this is dependent, or the quantity sold is dependent on this two. That's the reason the quantity sold is called as a dependent variable, while the price in the advertisement is called as the independent variable. Now we have to check on the labels and click on the output range box and select the where do we need the output. So where do I need the output to be shown? So I click on the output range box and then I click on wherever I need the output. Say I need the output in A11. So I select that, then check on residuals. Now the residuals will not be checked. You will have to check the residuals and click on OK. Once I click on OK, the answer will be displayed in the summary output box here. What does that say? So if you see the results here, you can see that there is a range that supplies some basic regression statistics, including the R square. So what is it doing? It's giving you the basic regression statistics. Regression statistics means we were trying to find the regression, and that's the reason that is what it is giving you. The standard error, the number of observations. Below that information, the regression tool supplies analysis of variance, which is ANOVA, including information about the degrees of freedom. This is called the degrees of freedom, sum of squares, mean square value, the F value, and the significance of F. Now, beneath the ANOVA information, the regression tool supplies the information about the regression line calculated from the data. Now, what is that calculated from the data? So it says that including the coefficient, standard error, that's the same thing that we're looking at, the standard error here. Then you have the t-stat and the probability value for the intercept, as well as the same information for the independent value. So this was for the dependent, this is for the independent value that you can see. Then, which is the number of ads. Excel also plots out some of the regression data using the simple scatter chart. So you can also add the scatter chart that you want to according to your detail that you need from this. So this is how your regression analysis works. So this is more of the statistical analysis or the financial analysis that you are planning to do when you are to the financial department using Excel. This is how your Excel helps you to do your work when it comes to working on the data analysis.
So back in the day, there was something called as waterfall development or the waterfall model of development. So when I say waterfall, you can think about something like, a banking application or an insurance application or some police department application. So the moment I say waterfall model, you can think of like a really huge application, which is, made up of small chunks of code. For example, this application might have a front end, this application would obviously have a back end, and then it has some DNS routes and a few services that it's dependent on. So it doesn't really matter how many services are a part of this application, but this entire application was shipped as a one whole application. That's how things used to happen back in the day. And this was referred to, or this method of development, the waterfall method, the application was referred to as a monolithic application. Now it's called monolithic, if I can write it properly, monolithic application. Now, everything was fine and dandy unless like 2000s and 2002. That's when things started to become a bit extreme because the clients would have 10 different requirements that would change almost every day. Now, if you have one single application, you have a single point of failure. So if you were changing even this little part of this application, and if this part was to fail, this entire application would stop working. That's when people started brainstorming about better approaches to software development. And how can you meet the requirements of the millennium, of the today's world, without actually affecting how the software is written or any application is written in the first place? That's where the ideas of agile development came into the picture. So that was one part of the problem. The second part of the problem was because it was a monolithic application, the time that it required to actually push the changes. For example, let's say you have an application up and running in your production environment, and your development team actually created a new feature, or they modified the existing feature. Now that feature is supposed to go in production, right? But it actually used to take days and months back in the day because you would never really know what's going to happen if you put it to production today. There are so many moving parts that you're never sure if it's going to break the existing application that you have. So people used to actually schedule the maintenance. I'm pretty sure you would have received those emails, right? Like, we will be unavailable during this weekend because there is a scheduled downtime. Now that's what used to happen. Now that cannot really fly anymore, right? Think about companies like Netflix, Uber, Amazon. They can't really be down even for a moment because you never really know how many people are accessing the service. Now that is the second part of the problem that people were trying to solve. That's when Agile came into the picture. Now Agile, put in simple terms, is a philosophy to rapidly deploy an application in much more organized way. Now, obviously, there's a lot more details than meets the eye, but in a simple sentence, that's what you mean by Agile. You want rapid deployment of the software or the code that you're writing without having to wait for a longer time. At the same time, you want to make sure that you have small chunks of code that can be shipped to the client or whichever application you're working with. That's the reason Agile exists today. And now we're going to look at what do you mean by Agile and how can you actually implement this. So I hope we are pretty clear about why was there a requirement of Agile to begin with. This is what you mean by waterfall model. Now this is the traditional software building practice, right? So you would gather the requirements, you would design or architect how you imagine your software to be, and then there would be actually coding that would be executed, there would be verification, and there would be maintenance post deployment. So this is what has been happening for the past 4 decades, but this won't really fly in today's world because there are multiple changes being pushed every single day. So you can't really just go through the months of planning for a little change. So the way applications are developed have changed, and so is the way applications are deployed. So that's what you mean by waterfall model. Now, I think I have explained it pretty well. There are a lot of companies that still follow this model, but at the end of the day, all of them are trying to, migrate to a more agile development. It's not so easy depending on the size of the company, but you will still see a few companies using waterfall, and they are in process of moving away from this model. Then comes Agile to rescue. So what is Agile? We've talked about the requirement, or why does Agile even exist so far. Now let's look at what do you mean by Agile. So Agile is nothing but a chain of rapid development and deployment, meaning the first section of your software development is always the planning part. But now you obviously know what you're about to build, but you kind of break that entire application down into small chunks of code, and then you work on those small services one service at a time, ensuring that first of all, you kind of follow the microservices model, and at the same time, you don't really affect the entire application in general. So you plan, you design, you architect, and you actually develop the application, you test, you deploy it, and you review it. If you notice, launch is actually outside of this entire circle, meaning every time you make a change, it could be something as simple as just one line of code change, just a variable being renamed. So it doesn't matter how small or how big the change is. The idea is the moment the change is made, it has to be deployed even in a dev environment so that you can get a constant feedback over what's happening with the code that you have. Imagine if you actually had to wait for 1 month or 2 weeks just to get the feedback on if you really want that change or not. Now that could be a little annoying or frustrating from the developer's point of view. So that's the first aspect of Agile. You plan, you design, you develop, you test, you deploy the changes, and then you review the changes before you actually launch them into production. The other major aspect of Agile is now, instead of working with like a huge chunk of application, you work in iterations. So when I say iterations, what I mean is you have a specific set of tasks that have to be completed in specific priority so that you already know what you're supposed to be working on, and you are not really worried about 10 different microservices at the same time. You have a specific requirement where you should be focused. So you have the first iteration, which might be the first part of your application, second iteration, third iteration. So think about it this way. If you have Amazon.in, if you're working for Amazon.com or Amazon.in, which is a shopping website, you might visit Amazon.com and you might think, yeah, it's a one website. It's not really one website. It's a website that's broken down into several other services. For example, the website itself might be called a front end. Now, the moment you reach to Amazon.com, you can click on a product, right? And then you can view the details of the product. So that service, it's not really a part of the front end anymore. That is being called from something else called as catalog. Now, once you decide that this is a product that I want to buy, you click on buy now, and then it's going to take you to something called a shopping cart. And after you made the payments and all of those things, you have email notifications and you have text notifications. The point here is, even though all of these things are working in synergy, they are actually completely separate services, completely separate tasks in the underlying architecture. So if I am working on something on the front end, I don't really have to be worried about the catalogs and the shopping, because first, I'm getting a constant feedback even before the launch. I'm getting a feedback about what's going to happen once we launch your code to the production. At the same time, I don't really have to be afraid that it's going to break my entire application. Because all of them are developed as separate microservices, your one service will never affect another service. Of course, the dependent services might be affected, but the idea is you never really want a single point of failure. That's the idea of Agile. Now, let's move forward. Now, what are the terms and the values of Agile? So the first value is people over processes and tools, working software over comprehensive documentation, customer collaboration over rigid contracts, and responding to change rather than following a plan. So people over process and tools, this kind of gives you, a development-centric and client-centric environment, meaning just because you've been doing something in a traditional way for the past 8 years, it does not mean you don't really explore the options that you have right now. For example, whatever you did with PHP MySQL yesterday can also be done with Python and Flask today, right? I'm not saying change your entire application. What I'm saying is the model is pretty much people-centric. The people, like the development team and the customers and the end users, are given more importance, and working software over comprehensive documentation. Now, this is something that all of us would have noticed at some point in time, right? So every application would have an internal document of how long? 100 pages, 150 pages about all the classes, all the methods, how the application is being built, and why the application is being built, who's the owner, and like plethora of other details that you as an individual is not even concerned about. You are concerned about what you have to build and how far along are you in that development task. So in Agile, the functional application is given much more importance than the documentation. Because if you think about it, the code itself is a documentation, right? If you knew how to interpret the code, you could look at the code and that can also act as a documentation. So I'm not saying there won't be any documentation. All I'm saying is the development is given more importance over the documentation part. And then customer collaboration over rigid contracts and responding to change rather than following the plan. So Agile is really feedback dependent, meaning back in the day, the managers and the product owners will have multiple meetings. They'll come up with the kind of software that they want. Everything would be discussed over like 3-4 months, and then people would want to stick to the plan. Because you already spent 4 months planning this thing, now if you wanted to change even a little part of this, the entire meetings and planning would have to be done all over again. Now, Agile changes that. Agile works more on the feedback. Just because the plan has been made does not mean there cannot be any changes. Because you've broken things down into smaller chunk of tasks, any one of the tasks can be modified according to the requirements at any point in time. So these are the values that Agile bring to the table, right? So there are two parts of the puzzle. You have a benefit and then you have a value. So benefit is what you get, like right off the bat, and value is what you derive out of it. So what we saw before were the values where everyone, on the table receives some or the other kind of benefit because of Agile. Principles of Agile: satisfied customer, welcome changing requirements, deliver working software frequently, frequent iterations with stakeholders, motivated individuals, face-to-face communications, measure by working software, maintain constant pace, sustain technical excellence and good design, keep it simple, empower self-organizing team, reflect and adjust continuously. Now, this might look more like a textbook thing, like here are the 10 benefits, just go with Agile. But that's not really the case. We are actually going to look at how all of this materializes, like, over the future slides, when we actually talk about how can you implement Agile in the working or the team that you're working with. So let's move on. Now, advantages of Agile. We pretty much kind of, touched upon all of these things for now. Persistent software delivery, increased stakeholder satisfaction, inspect and adapt, welcome to changes at any stage, design is important, and daily interactions. Now comes the meat of the entire presentation. Now you have a basic idea of Agile, right? But question that everybody has at any point in time is, what's in it for me? Okay, you told me what's Agile and how can it help? But how can it help me as an individual, or how can I actually implement Agile? So there are multiple frameworks or philosophies when it comes to Agile. So Scrum, Extreme Programming, Lean, Kanban, Crystal are some of the examples. The most popular one out there, it's called Scrum. Now again, these philosophies are not really set in stone. It's not like if you're following Scrum that, it's 100% what Scrum dictates you how to do it that way. That's not really the case. In majority of the cases, what people do is they primarily implement Scrum, and then they have some ideas from Kanban, Extreme, and Lean, and then they kind of have their own philosophy that works for their organization. But Scrum is the one that's used by the majority of the people. So even before looking at the slide, before we go through what we see in the slide, I can just kind of explain Scrum to you the way I know it, right? Because I've worked with multiple development teams, I've seen most of these being implemented, and I know how each one of them work in a real world example. So what is Scrum? So Scrum is basically an iterative philosophy, meaning you iterate over the changes, you iterate over the deployments in software development one at a time. So if you wanted to talk about Scrum, Scrum is an iteration of plan, then build, then test, and then review. Now, you would constantly be iterating over all of these aspects. Now, what do I even mean by this? So let's first look at how or what does a Scrum implemented team looks like. So in Scrum implemented team, you have the very first person that I want to talk about, someone called as product owner. Now, when I say product owner, if you're coming from, more of a traditional software development environment, you can think of a product owner as a manager. He is the guy who holds the responsibility to make sure that the application is deployed as and when committed. At the same time, the application is built exactly as the way it has to be built. So product owner is the guy with the ideas. He might not necessarily be a technical person. He might as well be a guy from the management. He does not necessarily have to know the development or the technicalities in detail. He's the guy with the idea and the owner of the application that would be developed. So pretty much all the accountability lies on him. And then there is someone called a Scrum Master. Now, Scrum Master is someone that you would have traditionally referred to as a team leader or a project owner. Now, you can think about Scrum Master as a team leader. In the hierarchical sense, this is the person that's right below the product owner. And this is the person who actually does the or handles the day-to-day operations, like, running the meetings or planning the tasks that have to be done. And then you have the team itself, which will consist of your developers and testers. And, depending on your requirement, it might have a few more roles. But then you have the actual team who will execute the tasks. So these are the three roles that you have. But now that we know the people that are involved, how exactly this works, this looks pretty much similar to what you do at your office. It's just fancy names, right? You have a manager, you have a team leader, and you have a team. So how is it any different from what you do at your office? So that's what we want to look at now. I hope the roles are kind of clear to you. Now that you have the roles defined, let's look at the first thing about the development. So the first part of the development that we want to look at, it's called product backlogs. Now here's where things start to get a bit different from how you might have been working at a traditional environment. Now in a traditional environment, you have an application that has been already planned for months, and you along with others have been working on deploying the application, and the project usually goes on for a few months or even a year or two, depending on the size of the project. Now, in product backlogs, you actually have the same application iterated over in smaller tasks. So when I say smaller tasks, you can think about the same Amazon.in example that we talked about. So the first iteration will have plan, it will have build, it will have test, and it will have review. Now, in this case, I'm not really building the whole application. I obviously have an idea as to what the application is supposed to look like. But for now, let's say I'm only concerned about the front end or what the main or the primary website would look like. Then I have a second iteration where I would, the same cycle, plan, build, test, and review. But this is where I'm actually working with email notification. I'm actually coding how would my email notifications be sent out, and how do you manage the email queues and the rest of the things. And then you have a third iteration, which might just be your payment processing. So in this case, again, the same cycle, you plan, you build, you test, and you review. But the benefit here is that once you have the product backlog, these are all your product backlogs. These are the things that are supposed to be done over a period of time. So the first thing you do is you define the product backlogs, not you as a developer, but the product owner and the Scrum Master. These are the people that would actually come up with all the backlogs instead of, just one single application that says, I want this thing to work. They actually break it down into small chunks of code. So that is the job of the product owner and the Scrum Master. Because as I said, product owner might not be a technical guy necessarily. So Scrum Master is the one that would always be a technical guy, right? So both of them would come up with the product backlogs. Once you have a product backlog, there's something called as user stories. So each one of these would now be referred to as user stories, and your Scrum Master actually ends up prioritizing them. Meaning, if you have front-end, email, payment processor, and 10 other backlogs that have to be developed, let's say over next 5 or 7 months, in that case, the Scrum Master and the product owner would kind of prioritize. Now, obviously, payment processor is of no use if you don't even have a front end. So logically, I would want to prioritize my front end over my payment processor. So Scrum Master and Product Owner will prioritize the user stories that you have. And depending on the priorities that has been set, they come up with something called a sprint backlog. Now, sprint backlog is when your development team actually gets involved in this, because now you already have an organized and prioritized user stories that you are supposed to be working on. So 10 different things are not just dumped on you at the same time. You are given a logical and reasonable tasks that have to be executed one at a time. And once you have the sprint backlog, you can actually start working on it as a developer. Now I'll get rid of this beautiful drawing that I've made for now, and let's just look at sprint backlog. I'm sorry, I can't really, write with my mouse, but I hope you realize it's called sprint. Now there are different, you could call them ceremonies or rituals, but there is something called a sprint planning. Now, the sprint planning, again, it's just a fancy name for the meetings and discussions that you have. During the sprint planning, the product owner will actually explain how he imagines the end goal or the product or the application to look like. So you have something called as sprint planning. You have something called as daily scrum. Now, daily scrum is nothing more than, the 15 minutes meeting that happens every day, where the developers and the testers and any other role that you have in the team can actually discuss what happened and where you stand, if you need any help, there are any blockades, and what do you plan to do today or tomorrow. And then there is something called a sprint review. So sprint review actually occurs at the end of the user story or the backlog that you've been working on. So each and every one of these user stories, right, they usually are designed with the timeline of 2 weeks in mind. Now, some companies, the sprints may vary, like it could be 2 weeks to 4 weeks, but in majority of the cases, each sprint will last 2 weeks so that you know exactly what you're supposed to do for the next 2 weeks. Now, at the end of the 2 weeks, along with your planning, your daily meetings, once your sprint is completed, you have a sprint review where you actually demo the code that you have, or just some kind of verification to make sure that sprint is actually completed, and then you move on to a new sprint, or you move on to a new user story that you have to work on. So that's the idea. That's how things work in general. Now, with that in mind, if we move on to the next slide, this is what the Scrum looks like. So you have a product backlog, and then you have a sprint planning. Now, as I mentioned before, each one of these sprints, the timeline is usually a couple of weeks. Depending on the size of your organization, it might last up to a month. But for all the companies that I've worked with, it's always been between 1 to 3 weeks. So you plan for what has to be done during the next 2 weeks, and then you have the user story or the backlog that you're supposed to work on, and then you have your team that actually works on it, along with the daily scrums. So you have the daily meetings at the same time, and at the end of the sprint, you have the review, and then you ship the part that you coded. Now, when I say you ship the part, I don't mean you necessarily put it in production, but you know that the part is ready to be assembled into the application that you have. So the idea is, at the end of every 2 weeks, you have a shippable part of the application that is ready to be deployed. So instead of working a huge application that would have taken a year anyway, now you kind of break it down into things that can be actually shipped in 2 weeks, depending on the priorities that have been set by the product owner and the Scrum Master that you have. That's the idea of Scrum, to break everything down into smaller chunks of code, smaller chunks of tasks, so that everyone knows exactly what they're supposed to do. That's like the methodical part of it, right? You have a method, there's a specific best set of practices that you're following along with the technical side. Because you have a rapid deployment, the moment you write a code, you can actually test it in the dev environment. Now that's where people like me, DevOps, come into the picture. But the idea is you don't really have to wait for a month just to see what you coded right now. If you push the code right now, in matter of minutes, you would actually see that working in the dev environment. So that's the technical side. You have the instant feedback to figure out if you have to move on, or if you have to make some changes to the code that you have right now. Now that's Scrum and Agile in general. Then there is a second method. So Scrum was one of the philosophies or framework. Then you have something called as extreme programming. Now this was one of the first ones. A group of developers came up with it back in 2001. I think the guy was called Kent. So they kind of came up with the idea of agile development. They came up with a set of best practices, and then they even signed a manifest. So they actually came up with a manifest that, these are the things that we should be following in the industry. These are the best practices and these are the principles, and they even signed it. So extreme programming has been around for almost a couple of decades, and Scrum is kind of the next iteration of extreme programming. It's a bit different, but as I said before, majority of the organizations use Scrum programming. So in extreme programming, they came up with, the basic sets of principles like people-centric environment, discipline, and then you have rapid deployment. So project requirements, stories, test cases, task, completion, customer input, iteration planning. Now, both of these things are happening in parallel. So you have project requirements, you have stories, test cases, task, and completion. And at the same time, you have customer input. And at some point, you have customer iterations in the meeting. For example, you developed 20% of the application, and your end user or your client came back with a better idea, or if they need some modifications. So those are the changes. Then you have your UAT testing, you have client-side UAT testing, and acceptance at the end of it. So extreme programming, the ideas are somewhat similar to Scrum, but at the end of the day, all of these philosophies are trying to make the lives of developers, the end users, better, and not compromising on technicalities. Rather, making the shippable product better and faster is the idea. All right, let's move on. Then you have lean programming. So lean principles, even this has been around for a while. So eliminate waste, amplify learning, decide as late as possible, decide as fast as possible, empower the team, build integrity, and see the whole. Yeah, so you could call it a framework, you could call it a philosophy or methodology. Now, it really depends on, the word that you want to use. But at the end of the day, it's again trying to become developer-centric and people-centric, and setting best practices to make sure everyone in the team knows exactly what they're supposed to do, and you have a cross-functional team. When I say cross-functional, essentially, I'm pretty sure if you're watching this video, is because you have some or the other development experience. And if you do, then you would have come across this point, right? When you talk to someone, hey, have you seen that feature? Have you looked at the code? And that guy would be like, that code doesn't concern me. It's none of my concern. I'm working on something completely different. Now, we are used to that sort of development, right? Where people individually know what they're supposed to do, and they're not even worried about what the other person is doing. Now, it's time we actually break the silos. Just because you're not coding that part does not mean that the code does not concern the part of the code that you are writing. So everybody has to come together and work on the same application, which is what you'll call a cross-functional team. In the Scrum example, once you have the user stories and the backlogs that you're supposed to work on in the next 2 weeks, it doesn't really matter what role do you play in the team. It's your team's responsibility to make sure that the task has been completed. And the task is also being designed with the timeline in mind. So it's not like you're expected to do 6 weeks worth of development in 2 weeks. So the task itself is designed with the timeline in mind. And then you have something like Kanban. So Kanban is similar to Scrum. The difference here is, in case of Scrum, you have smaller chunks of backlogs that you're supposed to work on for the next 2 weeks or 3 weeks. In case of Kanban, it's a continuous process. So there is no such thing as sprint in Kanban. What you do in Kanban is you have a list of tasks that are supposed to be done. And for example, you have something like, a whiteboard. You have a build queue, you have a test queue, and you have a ship queue. Now, this is a hypothetical example. You would obviously have plan and the rest of the things. But the point is, you might have 4 things that have to be built, or let's just say 3 services that have to be built. And once the first service has been built, it actually moves on to the testing queue. And then this place is occupied by another service. And once this is done, this is moved on to testing, and this is occupied by another service. Meanwhile, if this testing is done, it will move to the ship queue, and it will eventually be shipped. So the idea is, whatever tasks have been achieved will be replaced by a new item in the queue. So if you have a build queue, test queue, and ship queue, all of these would be moving parts. So if your job is to build this, and let's say your colleague's job is to test this, the moment you push this first item into the testing queue, another item will replace this first item so that you know what is the next thing that you are supposed to be working on. So Kanban is more like a continuous implementation of the software development. So that's what you mean by agility in general. Even if you think about it, the English word agility means to be really rapid, right? Agility would mean whatever you're doing is happening in rapid successions, right? That's what you mean by agility in general. So in case of development, by bringing agility to your team, you're ensuring that everyone's happy at the end of the day, and you still have a technically smarter team that's able to get instant feedbacks. Now, I'll give you a quick example of this. Now, I'm pretty sure all of us, or at least most of us, are aware about Netflix. Now, you would be surprised to know that Netflix is pushing more than 1,000 changes every day into their productions. If you actually worked at a Netflix development team, you would know that these guys are pushing 1,000 changes in production every day. Now, how do you think that's possible? Obviously, they are not pushing it to production without reviewing it or without testing it. Even with all of those things in place, how are they able to deploy more than 1,000 changes every day? Now, these could be very little changes, like, some UI fixes, some database fixes, some payment processor fixes. So we are not really concerned about what the changes are, but I know for a fact that that's the number. That's the amount of changes that they actually push every day. That's possible because you mean rapid deployment by agility or by becoming agile. So that's the level of agility you can actually obtain the moment you have an organized team that is working on the principles of agile. Now, obviously, there are external factors like, how's your infrastructure, how's your DevOps team, but it is possible at the end of the day. And then there is one more framework that's called Crystal. So these are the ideas of agile. Now, I hope I was clear into how can agile help your team in becoming a better development team. So there are 3 aspects of it, right? Philosophical, technical, and the way software is built. So philosophical being the best practices, like how do you define your teams, who's a scrum master, who's a product owner, what's the team, what is a sprint, what are the tasks that you're supposed to do. Then you have the technical side of it. Like if you build a code, how exactly can you deploy the code, like automatically? How can you review the code? How can you test the code automatically? And then there is a software development aspect of it, that you're moving away from a monolithic application towards the idea of microservices. So these are the 3 aspects that move parallelly. And at the end of the day, it gives you a peace of mind, it gives your product manager a peace of mind, and the end user a peace of mind with better ideas of deployment, so that you don't really have to run around on 10 different desks confirming if your changes are actually deployed or not.
So what is Scrum? Now, to understand the importance of Scrum, let's look at how Scrum compares to the older alternative, which is the waterfall development. The waterfall model consists of a long time which is involved in planning. Then again, by long time, I mean a couple of weeks, maybe a couple of months. Then it might take about the same amount of time to build the product, say a couple of months more. Then testing, followed by reviewing, and then finally deploying the product. At this point, you might end up bringing the wrong product according to the market demands to the market. Because when you started out with planning this product, it was almost a year ago, and now the market demand might have changed. Now, I'm sure a lot of you might already have guessed what the problem is with such a model. Firstly, the entire plan should be complete before you start building or testing your product. Now, obviously, if you're doing this in one whole iteration, it means that most of the planning is being done without understanding the project or the difficulties that you might face while building the project, the drawbacks, the loopholes, and most times after you start building the project, it is sent back to the planning phase again, which brings you back to your square one, in which case your project has to start over, or the developers are just criticized for not understanding the plan properly. This process can be repeated many a times, which consumes a lot of time, followed by the product getting thrown over the fence to test, where, in case you encounter problems, the project is thrown back to the building process or sometimes again back to the planning process. And the same thing can happen over the next few steps, including a lot of backstepping and doing over. This can lead to lag times and many months or several years in order to get a product out the door. Scrum solves this problem by breaking the project into smaller parts. First, you start out with just enough planning to get the project started. Next, you build the project with the minimum amount of features, which is like your base features. And then you test for the same and review for the same. And once this cycle is complete, you have in your hands a potentially shippable product. Now, this process takes around 2 to 4 weeks and it is repeated time and time again, reducing the time taken for the cycle of planning to testing to reviewing a certain product. This way, you end up with several different versions or several different incremental releases, each taking lesser time than the previous or just about the same time. And by the time you have 5 iterations of these, you already have 5 vividly improved versions of the same product, each keeping up with the market development that's going on outside of your company. And this is called Scrum. So Scrum is a framework within which people can address complex adaptive problems while productively and creatively delivering products of the highest possible value. Now, you need to understand 3 things about Scrum. Firstly, Scrum is lightweight. Second, it is simple to understand. And third, it is very difficult to master. Scrum itself is a simple framework for effective team collaboration based on Agile. And it is the opposite of a big collection of interwoven mandatory components which are a part of the previously discussed waterfall alternative. Now, Scrum promotes developing products through processes, techniques, and practices with various iterations and increments to deliver maximum value, as I had mentioned before. So that way, the first cycle of your planning, building, testing, reviewing shall be called your first iteration. The second one will be your second iteration. The third time you plan, build, test, and review will be your third iteration, followed by the fourth, and finally the fifth. Now, these iterations are called sprints. And at the end of each sprint, you have the launch of a potentially deliverable software. Each software version much better than the previous one. Each sprint takes up about 1 to 4 weeks, and you keep repeating these sprints until your product is feature complete. Sometimes you might even end up shipping your product after just the second sprint. But sometimes it may also take 3, 4, or 5, or even more sprints. But at the end of it, you have a good product, and that is what matters. Now, Scrum follows an agile approach to tackle complex problems. Now, agile is not a methodology or framework or a process. Now, agile promotes self-learning and self-organization as opposed to a lot of planning and a big collection of interwoven mandatory components. It implements a scientific method which replaces a programmed algorithmic approach with a more heuristic one, with respect for people and self-organization to deal with the unpredictability of complex problems. This approach basically means not planning the whole entire process to create a potentially shippable product, but to only plan enough to start out with and then react to the responses that you get with each sprint or each iteration. Now, there are 3 roles in Scrum. First of all, you have the person with the bright ideas who is the product owner. Next, you have the Scrum Master who is the one basically implementing Agile and preparing the team to follow the Agile approach and making them more efficient. And finally, you have the team. Mostly, the team consists of developers, testers, writers. It can be anything. Each of them can be replaceable by either one of them. So on certain days, you might find that developers are testing, testers are writing, so on and so forth. The main objective here is to create the product in the best possible way. There are a lot of reversible roles that are being played in the team. Now, to make you understand the approach of the Scrum Master or the Agile approach, let me take a problem statement. So take, for example, there are a number of people in the room and they have to queue up according to their respective heights, taking as less time as possible. So there are these many people in the room. Now, to this problem, there can be 2 solutions. First of all, we have the supervisor approach. Here, we have a traditional supervisor or a manager. And basically what they do is they arrange people one by one, taking up the time for each person to align themselves, which basically takes up a lot of time. And also, as a team, you learn nothing about organization. But then you have what you call the Agile approach. Here, let's bring about the same number of people, and we have a Scrum Master. Now, what the Scrum Master does is he allows the team to organize themselves, and in the end, he brings about whatever changes he deems necessary. And that, my friends, is the Agile approach. Now, the Agile approach, which is mostly used for software development, is an approach under which requirements and solutions evolve through the collaborative effort of self-organizing and cross-functional teams. So basically, people here are self-organizing, which consumes less time under the continuous guidance of their Scrum Master. So what it is that it's a set of practices that promotes continuous iteration of development and testing throughout the development cycle of the project. As I had mentioned before, it promotes self-organizations and assists teams in responding to the unpredictability of the problem in hand. And the person that promotes such an approach is called the Scrum Master. He or she is a person which allows the team to self-organize and manages the process for how information is exchanged. Now, there are a few anti-patterns when it comes to the Scrum Master. First, the Scrum Master is not a supervisor. Now, this problem is quite common with people that are usually old project managers. Being a Scrum Master is completely a different role than a project manager, and therefore the way the individuals act must be completely different. Typical project managers tend to organize the work of the people instead of allowing them to self-organize. They tend to say how, by whom, and by when the work must be done, not giving the team much space to think on their own. The result of this is basically a team full of robots instead of people who have the mind to think on their own. A Scrum Master must be aware of his behavior to be able to correct it. It's not easy. Usually these people have worked for several years in a typical project management position, and simply deleting this behavior will take up some time. But being aware is the first step. let people grow, let people have their own breathing space, and do not try to be a supervisor. It is not a control situation here. Second, the Scrum Master is not just a secretary. Now, many people think this way. In such a situation, I get extremely worried because it means that people do not know what a Scrum Master should do. When people think the Scrum Master is just a guy booking meetings, felicitating dailies, and serving coffee to their colleagues, this is where things get very dark. And unfortunately, this is very common. The Scrum Master has dozens of different roles and hats, but this is way far away from the secretary job that most companies associate Scrum Masters with. Scrum Masters teach, recruit, and coach people to grow into true leaders and work cohesively as a team. And finally, self-organization does not mean the absence of management. Like I had mentioned before, a Scrum Master is there to constantly monitor the growth of the team. Letting a team self-organize does not mean that there is nobody to supervise them. With that, let's move on to the Scrum framework. Now, Scrum is a simple, lightweight framework. It is not a methodology. Scrum implements the scientific method of empiricism, which replaces a programmed algorithmic approach with a more heuristic or a self-learning one, with respect for people and self-organization to deal with unpredictability and solving complex problems. As you can see in the graphic in front of you, it starts with the inputs from stakeholders and then the product owner with the bright ideas, all the way till the finished product, which is then reviewed in the sprint retrospective. Now, most of you might wonder what empiricism is. Now, empiricism basically means you're working in a fact-based, experience-based, and evidence-based manner. Scrum implements an empirical process where progress is based on observations of reality and not fictitious plans. Scrum also places great emphasis on the mindset and cultural shift to achieve business and organizational agility. So basically, there are three pillars to empiricism. First of all, you have transparency. Now, this means that you are presenting facts as is. All people involved, the customer, the CEO, the individual contributors, are transparent in their day-to-day dealings with others. They all trust each other and they have the courage to keep each other abreast of good news as well as bad news. Everyone strives and collectively collaborates for the common organizational objective, and no one has any hidden agenda. The next pillar of empiricism is inspection. Now, inspection in this context is not an inspection by the inspector or auditor or supervisor, but it is an inspection by everyone on the Scrum team. The inspection can be done for the product processes, the people's aspects, practices, and continuous improvements. For example, the team openly and transparently shows the product at the end of each sprint to the customer in order to gather value feedback. If the customer changes the requirements during inspection, the team does not complain, but rather adapts by using this as an opportunity to collaborate with the customer to clarify the requirements and test out the new hypotheses. And finally, as I had just mentioned, adaptation is the third and final pillar of empiricism. Adaptation is the context which is about continuous improvement, the ability to adapt based on results of the inspection. Everyone in the organization must ask this question regularly. Are we better off than yesterday? For profit-based organizations, the value is represented in terms of profit. The adaptation should eventually relay back to one of the reasons for adapting Agile. For example, faster time to the market, increased return on investment through value, value-based delivery, reduced total cost of ownership through enhanced software quality, and improved customer and employee satisfaction. So these were the three pillars of empiricism. Now let's go ahead and look at the Scrum life cycle. Now this slide is a graphical representation of an agile project using Scrum. Starting on the extreme left, you can see the product owner owning the backlog and developing user stories with the team or requirements for the project or the product. The product backlog is prioritized with the higher priority items on the top of the backlog. The team with the product owner then decides to group the user stories into releases based on the product roadmap. Once the release plans have been completed, the user stories are then selected for a sprint. The sprint can be from 2 to 4 weeks or sometimes 1 to 3 weeks. The team then disaggregates each user story into tasks. And then in each sprint, the product is developed. And as the code is written, it is integrated into the system. And daily scrums are held. At the end of a sprint, there is a sprint review where the working software is demonstrated and presented. Then it is presented to the customer for acceptance. The team then conducts a sprint retrospective to ask themselves the question, what could be done better? The stats on the team are then updated, as are the information radiators, which transparently displays the status of the team, which again make their way back to the user stories, and then the whole cycle begins again. Next, let's discuss what is a sprint. Now, as I had mentioned earlier, sprint is basically an iteration of planning, building, testing, and reviewing. A sprint has consistent durations throughout the development phase, and this is mostly between 2 to 4 weeks. It cannot be more than 4 weeks long. As described in the Scrum guide, a sprint is an iteration, as I had mentioned before. It has a time box of 2 to 4 weeks, during which a product is done, usable, or potentially releasable. And by product, I mean an increment of a product, like a version of a product. Now, sprints have consistent durations, which are usually limited to 1 calendar month. Now, during the sprint, no changes are made that would endanger the sprint goal. The quality of goals do not decrease, and the scope may have to be clarified. Now, each sprint may be considered a project with no more than a month's horizon, in which you have to accomplish something. Each sprint has its own goal, a design, and a flexible plan that would guide in building it with the resultant product increment. Now, the thing with a sprint is, if the sprint's time box is too long, then the definition of what is being built may change. Complexities may arise, and the risks may increase. Hence, sprints enable predictability by ensuring inspection and adaptation of the progress towards a sprint goal at least every calendar month. Now, there are a few factors which affect the duration of the sprint. First of all, the stability of backlog. Now, obviously, if backlogs keep increasing, that may push the date of the sprint. And secondly, you have overhead costs. Now, sprints also limit risk to 1 calendar month of cost. If the cost increases, then it may affect the duration of a sprint. Now, overhead costs. Now, each sprint is going to have a sprint meeting, the testing phase, a review, and a retrospective. Now, these are overhead costs. Now, if the overhead costs can be reduced by planning and automation, integration, etc., these costs can be absorbed. Now, by reducing these costs, overhead costs, you can reduce the duration of the sprint. Now, it is the Scrum Master's job to make sure that the development of the product goes according to the sprint planning. Now, there are a few other sprint terminology which I want to make you aware of. First of all, you have your sprint goal. Now, as the name suggests, what you want to achieve at the end of the sprint, your product with the feature sets that you have decided with your product owner and your customer is your sprint goal. Then you have your sprint cancellation. Now, once the sprint duration has been determined and the user stories are selected, neither the duration of the sprint nor any user story can be altered. However, a sprint cancellation occurs if there is a significant change in priorities or mid-course correction in between a sprint. Considering we are only talking about 2 to 4 weeks of work, the cancellation of a sprint is highly unlikely to occur. Next, let's discuss the Scrum artifacts. Now, Scrum has three artifacts: product backlog, sprint backlog, and product increment. Firstly, you have product backlog. Now, product backlog, as it is described in the Scrum guide, is an ordered list of everything that is known to be needed in a product. It is the single source of requirements for any changes to be made in the product, and the owner is responsible for the product backlog, including its content, availability, and ordering. Now, a product backlog is never complete. The earliest development of it lays out the initial known and best understood requirements. The product backlog evolves as the product and the environment in which you're going to use it evolve continuously. It is dynamic and constantly changes to identify what the product needs to be appropriate. It is competitive and useful. If a product exists, the product backlog also exists. Now, product backlog refinement is the act of adding detail, estimates, and order to items in the backlog. This is an ongoing process in which the product owner and the development team collaborate on the details of the product backlog items. During this product backlog refinement, items are reviewed and revised. Multiple Scrum teams often work together on the same product. One product backlog is used to describe the upcoming work on this particular product. Next, you have something known as a sprint backlog. Now, the sprint backlog is a set of product backlog items that are selected for the sprint, plus a plan for delivering the product increment and realizing the sprint goal. The sprint backlog is a forecast by the development team about what functionality will be in the next increment and the work needed to deliver the functionality into a complete increment. Now, the sprint backlog makes visible all the work that the development team identifies as necessary to meet the sprint goal. To ensure continuous improvement, it includes at least one high priority process improvement identified in the previous retrospective meeting. The sprint backlog is a plan with enough detail that changes in progress can be understood in the daily Scrum. The development team modifies the sprint backlog throughout the sprint. Only the development team can change its sprint backlog during a sprint. The sprint backlog is a highly visible, real-time picture of the work that the development team plans to accomplish during a sprint. Next, you have the increment. Now, the increment is the sum of all product backlog items completed during a sprint and the value of the increments of all previous sprints. At the end of a sprint, the new increment must be done. And done in Scrum has a different meaning. Done in Scrum or Agile basically means that the product must be in a usable condition and meet the Scrum team's definition of done. Now, you might think your product is done, but if that differs from my definition of done and we both are in the same Scrum team, then your product is not considered done. An increment is a body of inspectable done work that supports empiricism at the end of the sprint. Now, the increment is a step towards a vision or a goal, and it must be in usable condition regardless whether the product owner decides or not to release it. With that, let's move on to the ceremonies or events in Scrum. Now, Scrum has 4 ceremonies. First, you have sprint planning, then you have the daily Scrum, then you have sprint review, and finally, you have sprint retrospective. Now, I'm going to touch up on each of these one by one. First, you have sprint planning. Now, sprint planning is basically the plan of work to be performed during the sprint. It is time-boxed to a maximum of 8 hours for 1 month or 2 hours a week. For shorter sprints, the event is usually shorter, and the Scrum Master ensures that the event takes place and attendants understand its purpose. The Scrum Master teaches the Scrum team to keep it within the time box. Now, sprint planning answers 3 major questions. First, what can be delivered in the increment resulting from the upcoming sprint? This basically discusses the advanced feature set that you are going to deliver in your upcoming version of your product. Next, how will the work needed to deliver the increment be achieved? This is where you plan what you do in the week and the week next to it. It is the Scrum Master that teaches the Scrum team to keep their work within the time box. And 3, when is your work considered done? As we discussed, the definition of done is very important to the entire Scrum team. Everybody has to agree upon a checklist on completing which your work should be considered as done. Next, we have the daily Scrum. Now, the daily Scrum is an internal meeting for the development team. It is a 15-minute time-boxed event to synchronize your activities and create a plan for the next 24 hours. It is held every day of the sprint, and the development team plans work for today and tomorrow. This optimizes team collaboration and performance by inspecting the work since the last daily Scrum and forecasting upcoming sprint work. The daily Scrum is held at the same time and place each day to reduce complexity and answers fundamentally 3 questions. What did I do yesterday? What am I going to do today? And what are my impediments? By impediments, I mean challenges and requirements that you have while completing your work. It is very important that your Scrum Master know the challenges that you're facing and why you couldn't complete your work yesterday or why it might be difficult to complete your work today. The Scrum Master ensures that the development team has the meeting, but the development team is responsible for conducting the daily Scrum. The Scrum Master teaches the team to keep the daily Scrum within the 15-minute time box, and he or she also ensures that if there are others present, they do not disrupt the meeting. Next, we have the sprint review. Now, sprint review is an event to inspect the increment and adapt the product backlog if needed. There could have been a single deployment or many deployments during a sprint which lead up to that increment to be inspected. During a review, the Scrum team and the stakeholders collaborate about what was done in the sprint, and based on that, any changes to the product backlog during the sprint. Attendees collaborate on the next things that could be done to optimize the value, and this comes in the form of an informal meeting and not a status meeting. The presentation of the increment is intended to elicit feedback and foster collaboration. It is time-boxed at 1 hour a week, and the sprint review includes, first, the product owner explaining what product backlog items have been done and what has not, and 2, the development team demonstrating the work that it has done. And finally, the entire group collaborates on what to do next. This is at most a 4-hour meeting for 1-month sprints, and for shorter sprints, as I mentioned, it is 1 hour a week. Finally, the aim here is so that a sprint review provides valuable input to subsequent sprint planning. The review of how the marketplace or the potential use of the product might have changed will obviously affect what is the most valuable thing to do next, and review of the timeline, budget, potential capabilities, and marketplace and competition for the next anticipated releases of the functionality and capability of the product is also discussed. The result of the sprint review is a revised product backlog that defines the probable product backlog items for the next sprint. Now, this backlog may also be adjusted overall to meet new opportunities. Finally, you have the sprint retrospective. Now, this is basically an opportunity for the Scrum team to inspect itself and create a plan for improvements to be enacted during the next sprint. This occurs after the sprint review process and prior to the next sprint planning. This is almost a 3-hour meeting for 1-month sprints, and it is time-boxed at 45 minutes a week. This is an opportunity for the Scrum team to improve, and all members should be in attendance. Now, each team member has to answer 3 questions. Firstly, what went well? This basically helps you tell your Scrum Master what went well in your previous sprint, and those practices should be enforced in your coming sprints as well. Next, what didn't work well? what were the impedances, difficulties, and requirements which weren't fulfilled in the previous sprint. And finally, what should be done differently. Here you introduce the changes that you want in your working process or in terms of software that you're using. And these are the differences that you need to commit to improve in the next sprint. The Scrum Master encourages the Scrum team to improve its development process and practices to make it more effective and enjoyable in the next sprint. During each sprint retrospective, the Scrum team plans ways to increase product quality by improving work processes or adapting to the definition of done, if appropriate or not, in conflict with the product or organizational standards. By the end of the retrospective, the Scrum team should have identified improvements that it will implement in the next sprint, and implementing these improvements in the next sprint is the adaptation to the inspection of the Scrum team itself. Although improvements may be implemented at any time, the sprint retrospective provides a formal opportunity to focus on inspection and adaptation. With that, we've come to the end of all the Scrum ceremonies that I had to discuss.
The future is not something that just happens. It's something we create. And with AI in our toolbox, we can create a future that's truly amazing. As we decode the secrets of AI, demystify machine learning, and get up close and personal with the tools that are redefining business intelligence. Business intelligence is a technology-driven process for analyzing data and presenting actionable information to help executives, managers, and other corporate end users. AI has been increasingly integrated into BI to enhance these processes. There are many possible reasons to start utilizing AI in business intelligence. Here are the few that I have sorted up for you. Automated data analysis. With AI, manual data analysis is becoming a thing of the past. AI-powered BI tools can automatically shift through enormous amounts of data and identify trends, patterns, and anomalies. This not only saves time but also improves accuracy. Predictive analysis. AI tools are adding a new dimension to BI, the ability to predict future trends. By using historical data and machine learning algorithms, these tools can forecast future outcomes, enabling businesses to make proactive data-driven decisions. Natural language processing. Many AI-powered BI tools now support NLP, which means you can interact with the tool using natural language. Instead of writing complex queries, you can simply ask questions like, what were our best-selling products last quarter? Isn't it amazing? Data visualization. AI is also enhancing data visualization in BI tools. These tools can now automatically generate suitable graphs and charts based on the data, making it easier for users to understand and interpret the data. Real-time analytics. AI-powered BI tools can process and analyze data in real time. This is particularly useful for monitoring operational data. You can get immediate insights as soon as the data comes in. Now, as we have already mentioned the reasons for revolutionizing the business with the help of AI tools, before doing any delay, let's start with the top 5 AI tools for the business according to the recent surveys and data. From the eagle-eyed Microsoft Power BI, the artful analyst Tableau, to the super smart Sisense, and beyond, AI tools are revolutionizing business intelligence. They are helping us visualize data like never before, recognize patterns, and unearth insights that were once buried in spreadsheets. So first we will start with the toppers in the table. We are all familiar with the Power BI tool. Imagine holding a crystal ball, one that doesn't just reveal the present but also the future. That's Microsoft Power BI for you. It's a tool that transforms raw data into goldmine of actionable insights. Power BI brings your data to life, fueling informed decisions and igniting the way towards innovation and growth. It operates as a suite of business analytics tools that allows you to analyze data and share insights in an accessible and user-friendly manner. Here's the magical process. First, Power BI connects to a wide variety of data sources, from Excel spreadsheets, cloud services like Azure SQL, streaming data, and even on-premises SQL Server. Essentially, if data resides there, Power BI can likely pull up from it. I hope you are familiar with the tool now as we move forward to the second AI tool in our video, which is Sisense. This business intelligence tool is like your very own data superhero, coming in to help you pull insights from complex data. With its interface, 𝐶𝐼sense empowers you to visualize, explore, and make sense of your data. It's like adding a turbocharger to your decision-making process. And the best part is, it's all in real time. So with 𝐶𝐼sense, you are not just keeping up with the pace of business, you are leading the charge. First, 𝐶𝐼sense works by consolidating data from multiple sources, be it spreadsheets, databases, or cloud services. This function alone saves you from the laborious task of manual gathering data from different places. But it doesn't stop there. 𝐶𝐼sense then transforms this raw fragmented data into an organized, easy-to-analyze format. Now we need to proceed with the third AI tool, which has been a great help to the business, Looker, a bridge between raw, scattered data and meaningful, actionable insights. That's Looker. It's not just a business tool, but a platform that empowers every individual in your organization to navigate the vast ocean of data with ease and confidence. Looker is a beacon of clarity in the storm of information, illuminating your path towards data-driven decisions. Looker is a business platform that helps businesses explore, analyze, and share data. It provides a single view of data from a variety of resources, including cloud-based applications, on-premises systems, and social media. It also creates interactive dashboards and reports to visualize data and identify trends. It also offers a variety of analytic tools such as predictive analytics and machine learning to help users make better decisions. I hope you got the idea of what Looker is. Now let's move on to the next AI tool in our video, which is IBM Cognos Analytics. IBM Cognos Analytics is the master storyteller of your data journey. It brings together AI and BI, transforming raw data into profound insights with an eloquence that only AI can provide. Cognos offers a guided data discovery path, leading you to make confident, data-driven decisions. And it's not just about creating an interactive dialogue with your information and uncovering the narrative behind your numbers. The user-friendly interface of Cognos Analytics lets you drag and drop different data elements to create visualizations, making the data more understandable. It's like having a magnifying glass that not only allows you to closely examine your data but also provides a clear and concise summary of what all those numbers mean for your business or study. And I have saved this tool for the last, as one of the most popular BI tools, Tableau, which turns your data into insightful interactive visualizations in an instant, like an artist turning a black canvas into a captivating piece of art. It's a bridge connecting your questions to data-driven answers. It's not just about creating charts and graphs, it's about fostering a culture of accessible data and informed decisions. Tableau is a powerful data visualization tool used in the business industry. It simplifies raw data into an easily understandable format without any technical skill and coding knowledge. The data analyzed using Tableau can be understood by professionals at any level in the company. It even allows non-technical users to create customized dashboards. While the infusion of AI into BI is impressive, it's only the beginning. As AI continues to evolve and mature, we can expect even more innovative applications, further empowering businesses to leverage data in novel ways. The synergy of AI and BI is indeed transforming the way business operate, leading them into a future where data-driven decision-making is not just an advantage.
Now, why should you choose Power BI? Before I answer this question, I would like to answer something a little more fundamental. Let's start by addressing the most essential and fundamental question: what exactly is business intelligence? Now, in an age where business intelligence has become a bigger domain than most trending technologies, if you ask 20 different people what the term means, you're likely to get at least 10 different answers. So let me try and put it in the simplest of terms without having to lose the technicality of it. Business intelligence is a set of techniques and tools for the transformation of your raw data, meaning your data sets, into meaningful and useful information to take important business decisions. To put it simply, business intelligence is the technology which gets the right data to the right people at the right time so that they can take more effective business decisions. Over the years, the process of business intelligence has grown and adapted to help solve almost all the challenges while dealing with data by involving newer tools and techniques. The change that business intelligence has seen over years can be divided into 3 waves. So let us continue with our tutorial and take a look at the first wave, IT to end user, or the technical wave.
During the first wave of business intelligence, the end user had to be dependent on the IT department for data insights. This is because it was not possible for end users to create visualizations or reports on their own, as tools available required some technical or coding knowledge. This dependence on the IT department for insights resulted in more efforts and time consumption to get the updates done. Now the second wave, which is analyst to end user, or the self-service wave. Now the second wave gave analysts access to BI. Now people with some knowledge of analytics could use BI tools. This meant more teams had the access to BI and more people could have better data insights. This eased the role of the IT teams. And finally, the third wave, which meant everyone, which means the power lied in the hands of the end user. The third wave made it easier to access data and create reports and visuals to get better business insights. The introduction of tools like Power BI, Tableau, ClickView, and Spotfire made this transition easy. Now, anybody who had a basic understanding of data could create reports to build intuitive and shareable dashboards. This was about the three waves of BI. And in the third view came a very important aspect, data visualization. Now, data visualization is nothing but the pictorial or graphical representation of information or data. It provides insights into complex data sets by communicating the key aspects in a more intuitive and meaningful way. Data visualization lies at the intersection of design, communication, and information service. Even though your data visualization has been termed as the key skill for research in the 21st century, it goes way, way back. It existed in the late 18th century and can be traced back to when William Playfair invented the geometrical charts. His bar charts were used to represent Scotland's imports and exports of 17 countries in 1781. These bar charts constituted a pure solution to the problem of discrete quantitative comparison. Now, obviously, we have grown to learn about more and more charts as the years pass by. We also have a few hybrid charts to make our jobs easier and our calculations more granular. The way our human brain processes the information is easier to use images, charts, and graphs to understand and visualize large amounts of complex data than going through tons and tons of spreadsheets on reports. Take the quote, "An image is worth 1,000 words," for example. This is completely true because as a human mind, images aren't just a mere collection of pixels. They hold a lot of information. This information in visual form is easy to understand than reading the same facts in text or number form. So let me give you an example. Suppose there's a company which deals with a lot of products, like Amazon, and it's widespread over the world and has many vendors that sell through this platform. So obviously, there's a lot of data being generated in a lot of different formats. People use Excel, Access, different databases, SQL Server, so on and so forth. Some people even make all these spreadsheets and upload it to the web. So obviously, all that has to be brought to a single platform to analyze. And then these are the reports that go to the CEOs, CFOs, and the CXO position, all the big people in Amazon. Now, you can't just take 1 million or 10 million rows of data to a person to look at and infer something, right? You need them to know what's going on. What is going on inside the company? How is the market outside of the company? And this cannot be done with hundreds and thousands of numbers. This is where data visualization comes into picture. It's about giving them an idea of what's going on inside their company in different departments without having to look at tons and tons of numbers. Well-designed graphics have the power to put this complicated data into simple pictures. And this is where modern BI wins. Data visualization is a quick and easy way to convey concepts or information in a universal manner. It can help to 1. Identify key areas and hidden patterns, 2. Get factors that give better customer insights, 3. Analyze and associate data and products properly, and finally, make proper predictions. And obviously, presentation has a big role to play in this. So pardon me for my analogy, but if this was a beauty contest, let's go ahead and look at our winner. Now let's see why we need Power BI. Now there are a few points that make Power BI one of the most prominent tools for data visualization. Now this tutorial would be incomplete without understanding these points. Firstly, Power BI can spot trends in real time. Traditional BI tools like Tableau or ClickView restrict you to historical analysis. By using Power BI, you can access real-time information so you can identify trends early. By doing so, you can identify issues and improve performance. Secondly, Power BI can automatically search hidden insights. With Power BI, you can auto-search datasets for hidden insights in seconds. With Quick Insights, users can simply ask questions and Power BI Q&A will answer their questions with an immediate effect. Third, advanced analytics and custom visualizations. With custom visuals, Power BI allows you to visualize data in almost every way possible. As long as you can imagine it, you can put it on your dashboard. Thus, you're not limited to something that lies in a box. Finally, Power BI is enterprise ready. With Power BI and Power BI Desktop, you can securely connect to your own on-premises data sources. With the on-premises data gateway, you can connect live to your SQL server and other data sources. It gives you a secure, scalable, and reliable enterprise-grade information technology. And these mentioned reasons make Power BI very important in context of data visualization. So who can use Power BI? IT professionals, developers, companies big and small, subject matter experts, and plain analytics enthusiasts. As long as you want to, you can all use Power BI. Now let's continue to understand this by knowing what is Power BI. Now Power BI as a name has been in the BI market for quite a long time. The Microsoft team has worked for a long time to build a big umbrella called Power BI. And this umbrella is a combination of strong visualization, data analysis, data sharing, aggregating, and cloud integration. To define it, Power BI is a business analytics service provided by Microsoft. It provides interactive visualization with self-service business intelligence capabilities where end users can create reports and dashboards by themselves without having to depend on information technology staff or database administrators. It also gives you cloud-based BI services known as Power BI services, along with a desktop-based inference called Power BI Desktop. It offers data warehouse capabilities using data prep, data discovery, and interactive dashboards. In March of 2016, Microsoft released an additional service called Power BI Embedded on its Azure cloud platform, which enables the user to analyze data easily and perform various ETL operations and deliver reports with Power BI. The Power BI gateways let you connect with Access, Excel, SQL Server databases, analytics services, and many other sources to your dashboard in Power BI. And reporting portals embed Power BI reports and dashboards to give you a unified experience. What you see on your screens right now shows Power BI's general workflow. You have thousands of data sources which are being connected to Power BI Desktop, which then can be published into the service and gives you an option of connecting your organizational data live through your Power BI gateways. In the end, this can all be accessed through your tablets, laptops, and cell phones with you, your colleagues, and everybody involved in your business decision. Now that you understand what Power BI is, let's go ahead and look at a few of its benefits and why are we using this. Firstly, it has pre-built dashboards and reports for popular software-as-a-service solutions. Power BI helps you create powerful visualizations in the form of dashboards and reports, and you can do them without any technical knowledge at all. All you need to do is have a little bit of analytical sense, and you can use this service to your advantage. Next, it has real-time dashboard updates. As I had mentioned before, Power BI works real time and it can forecast trends in the coming few years as well. Third, secure live connection to your data sources on premises and in the cloud. Through the Power BI Gateway, you can establish connections that are secure and your organizational data can be connected to live every time that you want to. The best part about this is it is scalable and very, very secure. Fourth, Power BI also provides you intuitive data exploration using natural language query. You do not have to know the query language to explore your data in Power BI. Just using your everyday English or your natural language, data exploration can be made possible. Fifth, integration with familiar Microsoft products to utilize commitment for scale. Power BI can integrate with a number of sources and a number of Microsoft products, which makes it highly scalable compared to other BI tools. And finally, immediate deployment. Power BI is known for its quick deployment, which makes your job quick as well as easy when you have to take critical business decisions. And that was all about Power BI. In the section ahead, we are going to discuss a few components of Power BI. Now, Power BI has a few components. You have Power Query, Power Pivot, Power View, Power Map, Data Catalog, Data Management Gateway, Power BI Q&A, and Service. Starting up, we have Power Query. Now, this is a component which can be used to search and access and transform public and internal data sources. It is the Microsoft's data connectivity and data preparation technology, which enables business users to seamlessly access data stored in hundreds of data sources and reshape it to fit their needs with an easy-to-use, engaging, and no-code user experience. Next, we have Power Pivot. Now, you can use this for data modeling, for in-memory analytics. It extends a local instance of Microsoft Analysis Services Tabular that is embedded directly into your workbook. It enables you to import millions of rows of data from multiple data sources into a single Power BI workbook. It helps you create relationships between heterogeneous data, create calculated columns and measures using formulas, and build pivot tables and pivot charts and further analyze the data. Then you have Power View, which is a data visualization technology that lets you create interactive charts, graphs, maps, and other visuals that bring your data to life. Now, Power View is available in Power BI, Excel, and other analysis services from Microsoft. Then you have Power Map, which is also another feature in Excel. It is for exploring map and time-based data. It lets you plot geographic and temporal data, visually analyze that data in 3D, and create cinematic tours to share with others. Next, you have Power BI Services. So this is a collection of apps, dashboards, and reports built to deliver key metrics for your organization. These apps are interactive with each other and helps customers work with their own content. Then we have Power BI Q&A. It's basically a feature which helps you ask questions and get immediate answers. Sometimes the fastest way to get an answer from your data is to ask the question using natural language. So you can use Q&A to explore your data using intuitive natural language capabilities and receive answers in the form of charts and graphs. Next, you have the Data Management Gateway. So basically what this does is it connects your on-premise servers with your Power BI in the cloud. If you want to refresh your data in the cloud with the data that is on the premise, you will need to have the Data Management Gateway configured and available to your tenant. And that is how this works. And finally, we have our Power BI Data Catalog. Now this contains the metadata for felicitated search functionality in Power BI. Now your metadata gets stored in Power BI Data Catalog in the cloud for a shared query. It gives you a search access list for the query to determine which users and security groups can find and use this shared query. Now that we've seen how the components work, let's continue with this tutorial and understand the architecture of Power BI. Now, broadly describing, Power BI's architecture has three phases. The first two phases partially use ETL to handle data, and then you have the presentation of your data. So let's take a look at these phases one by one. First, you have data integration. An organization can be required to deal with data that comes in from different sources, as I had earlier explained in my Amazon example. Now, this data comes from different sources and can be in different file formats. Now, the data is first extracted from these sources, which can be your different servers or databases, so on and so forth, from wherever you can pull in data. This data is then integrated in a standard format and then stored at a common area called as a staging area. Then we go to our second step, data processing. Now, the integrated data is still not ready for visualization because the data needs processing before it can be presented. Now, this data is pre-processed or cleaned, as we can call it. This is also known as transformation of data. For example, missing values or redundant values are removed from the data set. After the data set is cleaned, business rules are applied to the data and it is transformed into presentable data. Now, this data is then loaded into a data warehouse. And now that you have extracted, transformed, and loaded data, your ETL is complete. Finally, you have data presentation. So once all this data is loaded and transformed, it can be visualized much better with use of various visualizations that Power BI has to offer. You use reports, dashboards, and help one represent data in a more intuitive manner. These visuals, reports, help business end users take important business decisions based on these insights. With that, let's move on to the building blocks of Power BI, where we can talk a little more about these insights. Now, everything you do in Power BI can be broken down into the following building blocks. A good understanding of these building blocks would help you understand concepts and will let you create detailed and complex reports. So the basic building blocks of Power BI are the following. You have visualizations, data sets, reports, dashboards, and tiles. First up, you have a visualization. A visual representation in the form of graphs and charts and maps of a data is called visualization. For example, a chart or a graph can be used to represent data visually. Power BI gives you different visualization types which keep getting updated with time. Now, some of the commonly used visualizations are map representation, card visualization, stacked area chart, tree map, and pie chart. Now, these visualizations can be simple or complex. However, visualizations aim at presenting data in such a way that it gives you more insight in the context, which is otherwise difficult to discern from simple data files. Next, we have datasets. Now, we know that a dataset is nothing but a collection of data or information in the form of spreadsheets. Now, Power BI can harness this data to create visualizations. It can be a simple dataset or a combination of many different sources which can be filtered and combined to provide a different dataset altogether. For example, you can pull together data from many different sources like different database fields, an Excel table, and online results of some email campaign to create your dataset. Having said that, you may want to filter your data before you bring it into Power BI. Filtering lets you focus on the data that actually matters. With your dataset ready, you are now free to create visualizations and display different portions of the data that's set in different ways. And with this, you gain insights. Next, you have reports. Now, a collection of visualizations that appear together on one or more pages is a report in Power BI. In a collection of items, these reports combine to form a workbook and are all related to each other. You can create visualizations on multiple different pages if necessary and arrange them in a way that best suits your interest. What you see on your screen is the image of a sample report. Next, you have dashboards. Now, Power BI dashboard is a single page interface. It is often called a canvas that uses visualizations to tell a story. Now, a lot of you might be confused within the difference between a report and a dashboard. Now, this is because it is limited to one page, A well-designed dashboard contains only the most important elements of your story or your report. The visualizations you see on your dashboard are called tiles and are pinned to the dashboard from the reports. So in a way, you can say that your dashboard is a compressed version of large reports that you are going to present. Now, because this is limited to just one page, a well-designed dashboard contains only the most important elements of that story. The visualizations you see on the dashboard are called tiles and are pinned to the dashboard from reports. In Power BI, a tile is a single visualization found in your report or on a dashboard. It's the rectangular box that contains each individual visual. Now, Power BI gives you the freedom to move or arrange tiles so you can present the data the way you want to. Even while you're creating a report or dashboard, you can make the tiles bigger, change their height or width, and snug them up to other tiles any way you want. So this was all about Power BI's building blocks. Now I'm going to take this Power BI tutorial a step further with a demonstration of creating a simple report using Power BI. Microsoft Power BI is a suite of business analytics tools that helps you create and share actionable, intuitive reports for business insights. And now I'm going to show you how you can put your data to work with Power BI. We'll go through the basics of data visualizations and dashboards, and we'll go through how to create and modify data visualizations. We'll also look at how to join data from multiple sources and build a dashboard report to share with our colleagues. So, what we're going to cover today, in part 1, we'll be getting started. Using it, part 2 will talk about joining data from multiple sources, and part 3 will talk about building and sharing a dashboard. And at the end of this, we'll have a demo. So part 1, getting started. In this section, we'll learn how to install the application. We'll talk about importing data from Excel to Power BI. We'll create and modify simple visualization, and we will save our report and publish to Power BI service. Now let's talk about installing the laptop application. First, what you want to do is go to http://app.powerbi.com. Here you'll sign in with your credentials. You'll run a simple wizard to install the application. Then you'll look for the download icon. It is here. It's an arrow pointing down with a line underneath it. So run that wizard. And the Power BI will be ready to launch, and it will automatically launch the first time that you run it. When you run it, you'll get this start screen. It is black and yellow, and you'll have access to forums, the Power BI blog, various tutorials, as well as some videos that you can watch and learn. But you don't need any of that videos because you have this one video. So let's go ahead. You can also access the Get Data functionality here from this screen. If you decide that you never want to see it again, you'll notice a checkbox in the lower yellow part of the screen that says Show this page on startup. Simply uncheck that box and you won't ever see it again when you run the application. So next up, you'll want to install some data. After you've installed the application, you're going to go to the Get Data button, and you'll be able to pull in data depending on what you're using. You may be using data from Excel like I'll be doing further in this demo, or you may be using data from an example, a SQL Server database, or an Access database. The options you have for pulling in data are a plethora. So there's a lot of available data sets, and we'll be sticking with the Excel for my demo, but keep in mind that you can pull data from a lot of different places. So after you have selected what data you're going to be using, you'll be given the option. Then in the navigation window, to select the exact data set what you want to pull, you'll check mark a box. For example, right here we have this box checked. And then you'll have the option to load the data or edit the data in the query editor. You'll probably want to edit the data in the query editor just to make sure that you'll pull in exactly what you want. Once you have pulled in the data that you want, you'll see that the data up here as a fields list on the right hand side of the application. As you can see here in the sample data, we have a budget business team delivery day, but whatever you've pulled in will appear in the fields list. And you'll be able to use that data in the fields list to create your visualizations. So let's start here by creating a simple visualization. This is a very simple visual. It's simply a column chart with one number. So it's one column right here. It's the budget field that we pulled in. Drag whatever field that you want from your data. There is no strict rule to it, and make a visualization. You'll end up with a column chart like this. You can also see that there are a variety of charts available there. And then in the visualization box, you will be able to make modifications to it. And like I said, this right here is a bar chart, but you'll be able to make pie charts, column charts, line charts, and a variety of other visualizations in Power BI. A variety of modifications are available for visualizations too right here. We've highlighted where you can click on the lower right-hand corner of the visualization and drag it up to make the visualization bigger or smaller. For example, you might want to make it smaller because maybe you want to put more than one visualization on the canvas there, or you may be wanting to make it large so that it can take up the entire canvas. So you can drag around the corners of your visualization to make it the size that you want. The format that Power BI saves reports says .pbix file. This is not the best way to share a report, but it's definitely the best way to save your work. If you're in the middle of something, you can go ahead and save your report as a .pbix on your machine or your OneDrive. Maybe even your OneDrive for Business or a SharePoint online set, wherever you're saving it. And so that way you'll be able to pick up later. If you're in the middle of building a Power BI report now, if you want to share your results of someone, the best way to do that is to publish the Power BI service. And you'll be able to do that using the Publish button, that is the ribbon, and that button is on the Home tab on the furthest right. We have highlighted it on the slide there. And then when the publishing is complete, you'll be given a link that you can click on in order to go see your workbook or your report. This will be there on your Power BI website, and you'll probably want to do that just to make sure it looks as good as you wanted it to in your tool. So this is the powerbi.com interface. The powerbi.com interface gets changed from time to time. That is also the reason for this particular tutorial, because it got updated in 2019 recently. It is a cloud service, and when new features come, you may see things in a slightly different place. For example, the search bar here, I believe, is slightly different now, but the gist of it is what we want. And you'll be able to use that search bar once you've published a lot of reports and have a lot of data sets available on your workspace. You'll be able to find them easily using the search bar. Or you can use the functionality of define your recent reports, as well as when you'll be able to manipulate and share them using powerbi.com interface. We're now going to go into part 2, which is using multiple data sets. So now we are going to be using multiple data sets and joining together in this section. We'll talk about adding data from other sources, joining the data from multiple sources, creating more interactive visualizations, as well as updating that published data on the powerbi.com web service. So here we go with getting additional data. Now to get additional data, you do the same thing that you did before. You got your first data set, and it's really not very different from how you did it. You just are having some data you're working with. You'll go to the Get Data button, you'll push it, and our demo will be using Excel, but remember you can pull in data from a variety of sources. It is also good to keep in mind that they don't all have to be the same source. You could be using some data from an Excel spreadsheet, some data from, example, a SQL Server query, or from another database query. You can pull them all together in Power BI, create relationships, and manipulate that data, and create some great visualizations right here, just as you did before. You'll select the data that you want to load, and you'll probably want to edit your query before loading it, just like you did before. So whenever you're loading queries, you want to make sure that you have the data that you want and your data is in the form that you want it in. Before you pull it in, Power BI will load the data that you have selected, and there may be relationships in that data. For example, here we have some actuals and some budget information that we are loading in sample data. But you may have two different tables that you are pulling in and they both have a month column. For example, in Power BI, the tool is actually smart enough to detect the relationship and join the data together. If it did not auto-detect your relationship, you'll be able to manually create it. But for most times, in my experience, it does it on its own. So I want to introduce here the Modeling tab. It's right next to the Home tab, and with the Modeling tab, what you can do is change some things with the format of your data. You might want to, for example, sort in a different way that then Power BI has already sorted your data. And you might want to change the format if there's a number you want to change to a currency, or maybe you've accidentally formatted some numbers as text, and then it's important that you notice that you can't do any math because of course you can't do math with text, and your problem then is that it's formatted as text. You can easily go into the Modeling tab and change the format of the data over to the number format. So now you have pulled in data from multiple sources and you want to create some new visualizations. Well, keep in mind that the canvas view here, that's what we've highlighted. On the slide, that is the top of the three icons. You see there on the top, you've got the canvas view. Below that is the Modeling tab that we just talked about. And then there's also the relationship view, and we'll be talking about this as well. And in the demo, you'll be able to create visualizations using all of the sources of your data. And whatever you are using, you'll be able to create visualizations with all of your data combined. And that's one of the really powerful aspects of Power BI. As you create visualizations with your multiple data sources, you'll be able to modify those just like you did before. You can use the handlebars on the visualizations to drag and drop the corners around. Make the larger, smaller fit how you want to. Also keep in mind that you can have more than one canvas page. You certainly don't need to cram all of your visualizations onto one page. If you've used Excel before, it's kind of like making a new sheet. You'll see the bottom of the page and there's a little plus sign and you'll be able to create a second, a third, a fourth canvas page and add more visualizations into the same report using multiple canvas pages. And made a couple of visualizations with Power BI. And right here, what I want is to highlight the fact that you can change the colors on your report to highlight certain things, for example. Right here, we've added some black to the columns, and Power BI actually gives you really strong granular control over, what your charts look like. For example, in a pie chart, you'd even have the granular control to change the color of one slice of the pie. So you really have a strong control on how your visualizations look right here. Now that you're done pulling in data from multiple sources, you're probably ready to publish. Now, whether you're publishing just for the first time or publishing again, it's just as easy. You simply go to the Publish button that's on the Home tab. Now, if this is your first time publishing, simply just publish it and then click on the link to go take a look at it. If it's your second time publishing, you'll be either given a choice to say overwrite a previous publication, or you're going to rename it and publish it again as something else. You'll get this wizard opening up, giving you the option to go to your published report. You'll go into powerbi.com's interface and view it. With that, we're moving into part 3. Now, this is the creation and sharing of dashboards. In this section, we'll talk about creating a dashboard, and we'll talk about pinning visualizations to that dashboard. We'll talk about modifying a dashboard, and we'll talk about sharing that dashboard with your colleagues or customers or business partners. So you obviously might be asking a logical question, what exactly is it? Well, most of you probably kind of know what a dashboard is, but what is it exactly? And at this point, it might be useful to make a distinguishing characteristic between data sources, reports, and dashboards. Now, we all know what our data sources are. Those are our Excel spreadsheets, SQL Server queries, or other data-based queries. When we've pulled in numbers and texts and other types of data, then we've built a report on top of it using Power BI. Now, once we have created visualizations on that data, a dashboard is a really important aspect. It really is just a type of report, and what it is that visualizations from other Power BI reports are all pinned to one specific place that can be updated in real time so that your business partners and your business decision makers, your customers and your colleagues can look at the dashboard and instantly have the information they need to make those important business decisions. Basically, if you bring all your Power BI reports regarding that particular decision and put them into one canvas, that is when you have a dashboard. It is a compact form of your complete report. So now, how do you create a dashboard? The easiest way to create a dashboard is to simply click on the pin icon, which you'll see on your visualization, and we'll then give you the option to create a dashboard. You'll also see, as we show you on the screen here, there's a plus sign next to the word dashboards in the Power BI interface. You'll create a new dashboard there too. Once you've created that dashboard, you can continue to pin visualizations to it. Here we go. There's that pin icon there, and you'll be able to click that and attach visualizations to your dashboard. And once you've done that, you'll be able to move them around and make it look like how you want it to look like. Eventually, of course, you'll have to share that dashboard with whoever needs to see it. The pin icon will ask you which dashboard you want to pin it to. Do you want to pin it to an existing dashboard or a new dashboard? If you need a new one, go ahead and select that. But you're building one dashboard at a time, and you're probably going to be sticking with your existing dashboard for a few visualizations at least. You can view your new dashboard with your visualizations, of course, and you want to look at it before you share it. Just to make sure that it looks how you want it to, go ahead and click and share and send it to some of your colleagues. You can modify your dashboard anytime, and you'll be able to click on the corners of your visualizations to make them larger or smaller, just like you would want it. Now, you won't have quite the degree of freedom you did with the canvas though. There are certain size settings for these visualizations. They can be so big, but you can't choose exactly how big you want them, like you could in the canvas. When you're in the web view, the predefined sizes is what they are called. When you're finally ready to share your dashboard, go ahead and click the sharing icon. So you'll type in the names or email addresses of the people you want to share it with. If you're dealing with a circumstance where you've got an internal and the global address list, you'll be able to simply type names from that. Or if you're sharing externally, you may need to use email addresses, and you'll type those in and go ahead and click share. You'll notice you have some options here, and you can allow the recipients also to share your dashboard. And generally, you do want to send an email notification when you share something with them. So then they'll know that it's shared with them and they'll be able to go access it. There's an option you can check as well. You can also share your dashboard once again by simply copying and pasting the URL. Once you've clicked that share button and added the person's email address or their name and shared it with them, even if they lose the link or they forget about it, they will never have to go through that process again. You'll actually just be able to copy that URL and paste it, and they can view your dashboard. Apart from that, there is also a QR code generated for every report for the very same purpose. Okay, so now we'll be going on to the demo, and every step that I had just explained to you, I am going to do it on Power BI and show it to you. So now we're going to start out by showing you how to download the application. You could either go to app.powerbi.com, and this will take you to the organization site. You have to sign in, and you'll sign in using your own organizational credentials, or you can do the same by going to powerbi.microsoft.com/downloads. Here you are going to select sign up for free and use your organizational credentials to sign up here. Then you're going to go to products, Power BI desktop, click on it, and then it'll open the Microsoft Store. and you can download it from there, or you have the download option right here at the bottom of your page. You're going to click on it and it will open the Microsoft Store. You'll see a button like this, an arrow and a line below it. You can click on that. You can get it for free. And then once the product is installed, you can go ahead and launch it. Then you have to click a couple of nexts, and that is how you will download Power BI Desktop. I actually wouldn't go through it and install it on this machine, as I've already got it. As you can see, it says the product is installed. But what you want to do is click Run, and a simple wizard will open up, and what you basically do is just click Next several times and you'll be able to install the application on your machine. Okay, so I'll just go ahead and close this. And I'm going to open the Power BI Desktop. And this is the Power BI Desktop opened up. And when you start, you're going to get this bumblebee colored theme, yellow and black start screen. Here on your left, you have your Get Data button, your recent sources, and open other reports. Here you have a couple of tutorials which will help you guide you through how to use your desktop app. You can go to forums, read a couple of blogs, look at what other people are doing with Microsoft Power BI. And as I had mentioned before, if you do not want the screen on your startup, go down. I will uncheck this box and then you can close it. And now your startup screen will no longer show when you open up the application. So we'll go ahead and move on. So this is your Power BI desktop application, and I'm going to start by pulling in some data because this is Power BI and data visualization, and it's kind of very useless if you have no data. So we'll go ahead and pull some in. So I'm going to pull in a few Excel sheets. I'll go to Get Data here. And here you see the most common options are here. You have Excel, you have Power BI datasets, data flows, SQL Server, analysis services, CSV, web, so on and so forth. So I'm just going to go down here and click on More, just to show you the full list of options that you have to start out with this particular tool. Of course, you have your Excel, you have your text files, your CSV files, maybe XML, you have SQL Server, you have Access, you have a wide variety of databases. Here you can select Azure, you have Azure SQL Database, a bunch of other options. You have online services, you have Dynamics 365, you've got Facebook, Google Analytics. So now this is how your Power BI Desktop's interface looks. This area over here on your left panel, if you can see where I am highlighting, shows the report, the data, and the relationship workspaces. By default, the report workspace will be open, which is this canvas looking thing right here. Below the report workspace is the data workspace, which is used to see your imported data set. And the last tab is the relations tab, which gives you the relationship between different variables in a data set. That is just in case you import more than one data set. On the right hand side, you will see your visualizations pane and your fields pane. So we are going to start out by importing data. So let us import a sheet. Here you will get the options for your most commonly used formats of spreadsheets. You have your Excel, Power BI datasets, data flows, SQL Server. But I just go down and click on More so you can see all the different options available to you. You have your basic Excel, CSV, XML, and JSON files. If you go to file types, these are the ones which you import from your system. Then you have databases, you have your SQL Server database, Access, MySQL, PostGRE, so on and so forth. Then you have Power BI's sample datasets and data flows. You can also connect to Azure. Here's a wide option of databases. You have your Azure SQL database, data warehouse, services database, so on and so forth. Then you can connect to online services. You have your Dynamics. You can even pull in data from Facebook. And here are a few formats of data which are still there in their beta phases, like Twilio, tyGraph, Web Trends, so on and so forth. And then you have your other data types. Apart from that, you can also connect to Spark, R, and your Python scripts and pull in data from there. So I'm going to go up and select Excel because my data type is Excel, but you can go ahead and connect to any data type that you want. Just going to go connect, and I have a financial sample. So I'm going to go ahead and add the finance data set. And it's going to lead you to something like this. It's going to show you a preview of what your data looks like. Then it gives you these options in the bottom. You can either choose to edit or load the data. I am going to load the data. It'll take some time to load the data onto your model. And with that, you are done. This dataset won't be needing any editing, but just in case it did, you could go right here to your data view and you can make edits to this dataset. It's always a good practice to name your columns according to what is contained in them. If you take a look at this data, you would understand it. It's a simple dataset about a few countries and their sales in general. On the right, you can see all the fields that there are in this particular dataset. So now what I'm going to do is I am going to go to my workspace and create a simple report. So the first step is to select a visualization. I'd be using a clustered column chart visualization. So it is this one right here. You can make it as large or as tiny as you want it to. I'm just pulling up the size so that it's easily visible to all of you. So now that we have selected a visualization, I am going to visualize sales and profit on the y-axis and the date on the x-axis. So I'm going to bring down the date to axis, which is my x-axis, and I'm going to bring my sales to the values field. Now you can even drag and drop these fields. Suppose I pick profit, I can just drag and drop it and it'll form a graph of its own. But that is a story for a different day. Now you can resize this visualization just how you want it. This is how I want it, so I'm going to keep it like this. Now I'm going to be making use of the clustered type, and I'm going to bring in something else for the y-axis. So I'm going to bring in profit. So you can see that the black ones are the profit columns and the green ones are your sales columns, right? So you can also change the graphics based on the timelines just by clicking. I am going to be changing the yearly representation of data to the monthly representation just by crossing out the rest of the options. I'm going to keep it as month, and I'm going to extend this graph so that you have better visibility. Also below the visualizations panel, you have this paint roller sort of icon, which is your formats tab. You can use different color schemes to make your visualization more appealing and insightful. I'm just going to go to data colors and change this green to, let's say, yellow to match the Power BI color scheme. I'm going to keep it that way. And this image shows how you can basically change the color of the fields used in the visualization. Apart from that, if we went back to this particular fields tab, you can perform statistical operations like calculating mean, median, sum, and even filter the data by various parameters using this tab. You can go down to filters. You have your visual level filters, page level filters, report level filters, and drill through. It will help you aggregate your data before you use it in any visualization. And with that, we have successfully created a visualization. Now, creating visualizations in Power BI is as simple as this. You could either drag and drop. Because this is a smart tool, it will 9 out of 10 times get what you want it to. But for the remaining one time, you can always use the Fields tab. So I hope by now you might get comfortable with the idea enough to create visualizations on your own. I'm going to show a few other visualizations, so it will help you get comfortable with it. Now we have this. I'm just going to move this down here and show you some other fun stuff. So let me put in a pie chart over here. Let's see what we can do. I'm going to put in the different countries and let me put in the sales values. And it will show me Mexico, Germany, France, Canada, and the United States, and how much sales have they gotten through the years. I can also click on each of this pie and see the value of the country's sales being reflected on this other graph. And this is called cross-highlighting. Now let's see what else. Now you can also use a tree map, so I'm going to go ahead and do that. And get your country and sales. Your tree map is basically like your pie chart, but it's much easier to visualize as it is more organized. And this is just about 5 countries, but if you had more countries, a pie chart wouldn't be of much help. In such case, you are going to be using a tree map. So you can choose the visuals that suit your requirement and experiment accordingly. There are a lot of visualizations to try and experiment. Also, when it comes to visualizations, no two individuals visualize data in the same way. So your reports may turn out differently than mine. But Power BI helps you create and edit reports according to your comfort and ease. Now here's a few tips before you get into visualization. For that, I'll have to go to this data view. First thing, you have to name the columns because you're building dashboards for a user. And all the naming conventions and data types are going to appear at the surface to your user, and you want it to be as interactive as possible. So if there's a column which has names of countries, name it country. If a column which has names of products, name it products. Units sold, manufacturing price, sales price, every column name should give you an idea of what is there in that particular field or column. Second thing, anything that's not absolutely necessary in the model, delete it. As you can see, I'm going to be using every possible detail that is there in this data set. If I had blank values or null values or a column which I was not going to be using, I would have deleted it by now. Because that's going to contribute to the size of the model and take up way more system resources while processing. Here I have nothing to delete, but I think if you do have columns to delete, go ahead and delete them. This practice might not seem that useful, but trust me, it is one of the best practices to own. Another thing I'll be doing is data types. Numbers have to be numbers and geographical data has to be geographical data. So go up to modeling and select the column country and change the data category from uncategorized to country. That way, Power BI knows what kind of data it's actually dealing with. So this looks good. And once you're done with all these transformations, you're pretty much good to go. Another good practice is changing the name of the page. Again, the same theory of renaming columns is renaming your sheet names. So I'm going to name this Introduction because that is what it was. It was your introduction to using Power BI Desktop. Let us now move ahead and take a look at one last topic before I conclude the session. So we are going to take a look at this use case and understand how Wirepass used Power BI to visualize a massive amount of sensor collected data quickly, easily, and effectively. Now, Wirepass focuses on providing the most reliable, optimized, and scalable device connectivity to its customers. With Wirepass, customers can digitalize their current business processes and innovate for new disruptive models. It also has its headquarters in Tampere, Finland, and offices in France, Germany, South Korea, and the United States. It was established in 2010 in Tampere. Now, it's a big company. What challenges did it face? Now, Wirepass technology collects a wide variety of data through its connectivity service. Every wireless device built on Wirepass software technology can collect and send a huge amount of data. Now, this data is collected in several ways and then stored in a database. Visualizing this data is key to getting an overview of the current state of things tracked by the technology WirePass. Now, there were a few obstacles to overcome. The data was collected from millions of sources and in different formats. There was difficulty in displaying the large sensor data collected for a parcel tracking service, finding which parcel was at what location and when. And finally, what was the parcel status and how could end users understand the collected IoT data? WirePass used Power BI to overcome all the above mentioned challenges. So let's go ahead and look at their approach. First, they acquired the data. The data that was imported from different sources in different forms was cleaned up using Power BI and Query Editor. Second, they designed the report using Power BI Desktop. Now, after importing and cleaning up the data from 1 million sensors, Power BI was used to design a dashboard that enabled the customers to get overviews of all the data and enable them to drill down to one single parcel and the parcel history. Third, they created a Power BI workspace. Now, to create the Power BI workspace in Azure, the Power BI CLI was used. Back then, there was no UI available to create workspaces for Power BI in Azure. Therefore, they used the Power BI command line tool for managing Power BI embedded workspace collections. And finally, what they did was they embedded Power BI in a web app. Power BI Embedded enabled developers to embed reports in almost every kind of app. This was the easiest way to embed the report into a website. And the architecture you see right now was used to overcome the overall problem. So first, they acquired data from .csv files for online customers. Second, they acquired data from SQL Server on-premises of the customer not public. Third, they performed ETL on the data they had. Fourth, they designed reports on top of the data they had. Fifth, they created a Power BI workspace. Sixth, they uploaded the .pbix file. And finally, they used the Azure App Service and embedded Power BI to host the report. In conclusion, I would like to say that this was a smart way for WirePass to bring their IP to the cloud in an easy and fast implementation. The whole project needed limited calling time, consultation, and implementation. For a Bosch-connected world, this was an easy demonstration of the complex data based on Azure and Power BI embedded. Since the workshop, WirePass has won several new customers who are using its products and dashboards powered by Power BI embedded. If you need a detailed understanding of this use case, you can refer to a link which I will leave in the description box below, which will direct you to a page where you can actually see the use case study. Now that we've come to the end of our demonstration, let's take a little look at the Power BI experience with Edureka. Now, as most of you might know, the job vacancy trend of Power BI is on the rise. Microsoft is recognized as a leader in the Gartner's Magic Quadrant for Analytics and Business again this year. Cognizant, Dell, KPMG, Hitachi, and over 45,000 MNCs across 185 countries use Power BI. And not just that, these professionals earn up to a lucrative $114,000 per year according to PayScale. Now, the Microsoft Power BI training at Edureka helps you achieve expertise in business analytics. At the end of this course, you'll master concepts like Power BI Desktop, Power BI DAX, Q&A, content packs, custom visuals, as well as Power BI integrations with the Azure Machine Learning and SQL services. This training introduces you to Power Pivot for data modeling, and this course helps you explore and visualize enterprise data using natural language. Not just that, here you learn at your own pace in your own time from a location at your choice. It helps you get completely industry ready by the end of your training.
What is Power BI Dashboard? A Power BI dashboard is quite simple to understand. It's a single page story that is connecting multiple data sets, making it visually and conceptually meaningful. This one-page visualization in a dashboard is also known as a canvas. Dashboards gather data from multiple sources and systems, then combine them into a single interface for a detailed overview of the business. So to simplify, a single page visualization with multiple charts and graphs to tell a story is called a Power BI dashboard. Let's take an example to understand it more clearly. Suppose a business organization wants to gain profit more, so it can use customer segmentation dashboard. These types of dashboard will give the business organization a view of their customer details like most customer gender or age range to target in such an intelligent way that helps them to take beneficial decisions right away. They can share the dashboard with other departments like finance in a customized way that can ensure organization most precious asset, that is data security. Why are dashboards powerful? Number 1, data transparency. Data is any company's most important asset. However, it's of no use if no one can understand or access it. A well-designed dashboard provides on-demand access of important metrics. Number 2, access to data. A dashboard gathers multiple data sources, including Excel, into a single interface, meaning to see a detailed overview of your business in one quick glance. It reduces time to compile reports, so overall saving your time. Number 3, interactivity. Some of the best dashboards provide a dynamic experience rather than a static, boring information. You can filter data, interact with charts to see changes over time. This means that you can get as much or as little detail on specific metric. Better decision making. Dashboards provide an unbiased view of each department. So each department can have access to the dashboard and can provide a foundation for further dialogue and great decision making. For example, the sales and marketing department can align their data and experiences to increase customer acquisition and improve demand generation. Hands-on on creating a Power BI dashboard. Now here we are going to create a Power BI dashboard, but number one thing to be remember is we cannot create a dashboard in Power BI desktop. We can create a report there. So first step to do is to create a report. We have this following things going on in the Power BI desktop. Here is where we create the visuals. Here is where we can see the data. And in this segmentation, we can see the data relation. So the lookup table, the center table and everything. So that helps to understand the data. And here we can see the data in an Excel format, so you can see and analyze data, and here is where we are creating the visualization. So first you need to get the data. So here you can see there are many data sources. Although I'm going to be using Excel, but I want to show you there are so many data sources you can connect to. So data sources, there can be a lot of data sources like Azure, database, Power Platform, online services, and lots more. So you can connect to them and then create your visualization. I have my database already, you can see. So first I'm going to choose my chart that I want. So I want KPI and I'm going to take sales, and for the trend axis I'm going to take date. So as you can see from this visualization that the area chart in the background represents trend of sales over time. So the back of there you can see this is the trend of sales with time, and the figure that is 12 million is the sales for the last month. So you can resize your visual according to your theme and your choice. Also what you can do is you can take advantage of format your visual and you can change the call out value for the 12 million. So I'm going to change it to purple color. You can see I've changed it. It's just for the theme for your report and just to keep it aesthetically pleasing. So right now after creating one chart, I'm going to show you how I create even more. So right now I'm gonna go back to build visual and going to choose pie chart. And for the pie chart, I'm going to take discount by month name. So okay, so this was actually sales with date. I can just go back, let it be KPI format only. So if you click the visual, then if you choose any visualization, you can change it. Definitely you have to click back and then choose another chart. So I'm going to choose pie chart and then take discounts by month name. And here is my discount by month name. I can resize it, I can change the font color or anything. And now let's create even more visualizations. So let's take the scatter chart. And for this, you can see the x-axis, y-axis legend. I'm going to choose profit for x-axis. For y-axis, I'll choose discounts. For the legend, I'm going to choose product. And for the size, I'm going to choose gross sales. So here you can see I have created this bubble chart, or you can say scatter chart. Going to resize it, and then that's how we are creating our visuals. You can create even more. Let's take line and stacked column chart and select country and gross sales. So we have our scatter chart. You can change the colors of it according to your theme. So suppose if you have yellow and black theme going on, then you might want to stay in a yellow and black theme. Although I have a colorful theme, so I would keep like that. It's just for aesthetics, and it's great if you have good aesthetics to your dashboard and reports. Now, after creating that, what we are going to do is we want to publish this report. So after you are done importing your data set, then choosing visualization, x-axis, y-axis, and then we are creating so many visuals. And then I'm going to show you a cool feature that we can do here is if you click on any single segment on this, every other segments of the other charts are going to correlate with that. And this process is called filter. This filter can only be done on reports. We cannot do it on a dashboard. So if you click on any segment, you can see how it's correlating with other data. So you can play around with the data, understand the data even more. It's quite interesting to do, and it's visual, so definitely it's easy to do. Very easily you can understand the data and how it's going on and the modeling aspect of it as well. Now after this process, what we want to do is just double click on any chart, then you'll be back to your default. And after creating our visual, we want to publish our report. So all you have to do is click on the publish in the home button, and then you have to click on save, and then just give a name to your report. So I'm going to give it new report and then save it. After saving, you have to choose your workspace where you want to publish it. So I'm going to choose my workspace, and then it's going to publish it. So what's happening here is the online Power BI service is uploading my report in the cloud. So I'll be able to use it. So here you can see a link, right? If you click this link, then you'll be directed to the online Power BI service, and you'll be able to open your report there. But one thing to remember is you need to already log in into your account. If you don't do that, you won't be able to access the report. This is just for the security aspect. Now, just because we are talking about this, I also want to mention the fact that why we are using dashboard, why not report? Because as you can see, our report has almost same aesthetics and look, meaning like dashboard. Then why are we using dashboard? So you may want to share your file to your colleague, but if we share our report, they have access to the data and then can make changes. So in other words, there is no security. So the best way to share your report is via the PBI service, that is the Power BI service. And to do this, we need to be logged in into our Power BI account in Power BI desktop. Then on the home button, we have to click publish and then select workspace. So what happens in this process is Power BI is uploading the data up to the cloud in Power BI online service, and you have to click on the link to open it. and you will be able to see your report in Power BI browser. And here we are. So I'm not going to click the link because it will take me to a browser where I'm not logged in. As you can see, it will take me to app.powerbi.com, which is the correct website for the online Power BI. But since I'm not logged in here, so I won't be able to access my report. See, I won't be able to access my report. So what I'll do is I'll just go to my browser where I'm logged in, and I'm going to show you where is my report now. So this is my account. I'm logged in here. It's very important you to have an account here. And then when I click my space where I actually published it, you can see new report. This is my report which I created. And if you look at the report, you can see it's as it is as what I created on my desktop, right? There is no changes. So this is my report, but I am in the online Power BI service website. And right now I'm going to show you how I'm creating dashboard with this report. So I hope you understood how we are publishing the report and how our report is getting directly accessed in the Power BI service directly by using a link. Now after this point, we are going to talk about creating a dashboard. So to create a dashboard, all you need to do is you can just click on edit on your report, and then you can change the visualization for any chart according to your choice. But if you don't want to change any visualization, you can let it stay like that. You can do a lot of things here as well. So after this point, what we want to do is we want to pin the chart. So here you'll see an option, right? This pin visual. So I'm going to click this and I'm going to create a new dashboard. If you already have any existing, you can go ahead with existing. So I'm going to name it It's New. Okay, so this is my dashboard and I'm going to pin this. Again, I'm going to pin more visuals here. So I'm going to pin this one as well. I'm going to pin this one as well. And this 𝐂𝐲 visual as well. So after you're done pinning the visuals, you just go to your dashboard. You don't need to make any changes to your report. And you will be able to see your visuals, right? So here are your visuals. You can resize it according to your theme to make it more aesthetically pleasing. And it just helps you to make your dashboard more interesting. So here I'm going to resize it. And you can easily align it. There are so many advanced options to align it. And that's how I'm creating my dashboard. All right. So this is my dashboard. Now what I'm going to show you is some cool features that you can play around with your data on online Power BI service. So after creating the dashboard from the report, you might want to share your dashboard. So all you have to do is click on share, and then you have to enter the name or email address of the user, and then you can choose the options what you want to do with your dashboard. So allow recipients to share this dashboard. If you want them to share, you can check it or else uncheck it. So these are the options. And allow recipients to build content with the data associated with this dashboard. If you want the user to do this, you can let it be checked or else unchecked. But make sure that whomever you're sharing this dashboard with, they have online Power BI account, right? That's most important because there is some security aspect to it as well. So that's what the great thing about online Power BI service. So after sharing, I want to show you some cool features of online Power BI service. So first thing that is very good about it is the Q&A. Okay, so here you can see ask a question about your data. So this Q&A feature is very interesting. All you have to do is write a question. Probably I'm going to write total sales. So I want to know the total sales. So I'm going to enter that, and you can see there's a figure, right? So I don't have to understand the data model, the structure of the data and everything. I just have to write the question and I get the accurate direct answer to it. So that's pretty cool, and it definitely allows you to get quick answers to your questions without understanding the visualization or model structure. So definitely. Now another cool feature on the online Power BI service is that the quick insights. So for the quick insights, all you have to do is go to your workspace, and then whichever report you just created, You have to right click on that and you have an option called Quick Insights. You have to click on Quick Insights. So let me tell you what Quick Insights does. So it shows us unfamiliar data, undiscovered data. It runs a sophisticated algorithm against your data set. So definitely things that we might not able to see are important. Quick Insights does that for us. So why not? It's a very cool feature. You can see there are so many data that actually we didn't create on our visualization, but these are so important. So Quick Insights does that for our report. Now we are going to be talking about how workspaces separate insights of report for each group. So workspace is another tool which is very interesting, helps us to do a lot of cool things like specifying the group. So let me tell you what it is. So workspace are where you will place your reports based on who you want to see it. So in other words, they are a group of certain people who will see certain piece of analysis. So some insights might only be for specific group. Workspaces can separate these reports for each group. So what you have to do this is go to workspace, create a workspace, and then you have to upload a picture for your workspace. Then name your workspace, give a description for what we can do here, and then save it. So that's how you're creating a workspace. It's quite great tool because it's actually specifying the department. Suppose if I only want my dashboard to be seen by the accounts department because it's all related to accounts, then I'm going to do that. The workspace helps me to do that. Now we are going to talk about how to direct access a user on workspace. So yes, this is another important thing that we can do on the online Power BI service. All you have to do is go to your space. I'll go to my space, and whatever report I created, right click on that and then manage permission, go to direct access, add user, and then you can name or write the email address of the user who you want to give access to. And you can also check and uncheck these options according to your choice and then grant access. So this is yet another amazing feature on online Power BI. So these are the things that we can do definitely. And now I'm going to show you the PPT to summarize it to you, that what we did right now on the hands-on, so you get an idea what we need to do, but in a summarized way. So as I showed you on the hands-on, how to build a report. So on building a report, first is you have to import dataset in Power BI desktop. And to import dataset, all you have to do is select your dataset, choose your data source like Azure, Excel, etc. And then you can see the data modeling where we can see how data is related to other data like, the lookup tables. And then make changes to data. You can do some query, change, and etc. So yeah. And the next step is build visualization using dataset. So you have to choose visual. As we saw in the hands-on, we choose probably a KPI and then select x-axis and y-axis, or we can see the trend axis with that, like sales by date, and then apply visual. So we click on format visual. Here we have choices to change the font color, font size. We can do a lot of things there. Suppose we have a bar chart and we want to change the color of it to match with our theme. As I said, our visual has to be aesthetically pleasing. We can do that using format visual. Now the next is resize the visualization. So definitely this is very important in the process of building a report, because if you don't resize your visualization, it might look less pleasing aesthetically. So we need to follow the alignment, follow the theme, follow the order for that. And the last step to build a report is publish your report. So you have to select publish from the home tab and then select destination, the workspace where you want to publish. And then you get a link, right? And if you click the link and you already are logged in into your account, then you can open your report directly from there. But if you're not logged in, you have to log into your Power BI online service and then open the report, as I showed you in the hands-on example. So these are in a compressed way how to build a report. So it's what we discussed right now. And then we are going to talk about the difference between report and dashboard. So first is dashboards are one page, report are multiple pages. Dashboards has single or multiple data set, report has single data set. Dashboards can't be filtered, report can be filtered. As we saw in the hands-on, how we can click on one segment and other charts are also correlating with that each segment. So definitely it can't be done on the dashboard, but can be on the report. And the last is dashboard is not available in Power BI desktop, but report can be done in the Power BI desktop. So how to publish a Power BI report? These are the steps in a compressed way. We have to publish from the Home tab and then select our workspace, log into Power BI Online Service, and then from there we have to open our workspace in the online service and then open the report. Why share dashboard, not report? As we saw in the hands-on example, sharing a dashboard can be a risk to the data for a company. So for any organization, their data is their most precious asset. So these are some points as to why share dashboard but not report. Number one is everyone you share it with can see your dashboard and interact with your reports, but they cannot save changes to existing reports. Everyone can see the changes that you make because we have this tool called refresh. If you make any change to the dashboard and refresh it, the other person whom we shared the dashboard with can see the updated changes. And number 4 is no one can see or download the dataset, which is a great thing for any organization since for them their dataset is quite important. Now to summarize, suppose a business organization strategies for annual sales monthly wise. So first it's going to import Power BI report and then it's going to change visualizations as per choice. And then it's going to pin the tiles for the dashboard and then resize the tiles in their dashboard. So that's how they are building a dashboard and being able to strategy for annual sales monthly wise. Now these are some top features of Power BI service. As we discussed in the hands-on examples, the quick insights give us some unfamiliar and undiscovered data which are very important for an organization, and it's quite wonderful and cool tool to deal with in the Power BI service. And the next is raw level security. This is for the aspect where we want to share data to some aspect of the region and not to all. For example, if we want to share our dashboard with accounts department, so for those kind of customized security level, we use the raw level security. And number 3 is Q&A. Q&A is another cool feature where you'll be able to write your question and get direct answer to it. You don't have to understand the visualization or any model structure, but you will be able to get data from Q&A very easily. The next point is advantages of Power BI dashboard. So number 1 is it extracts insights and draw conclusion. So for the first advantage, as we saw in the hands-on example, business organization wants to check which month has the most sales. So it's going to look after the month-wise data and extract the exact month out of the data set and thus have a conclusion. Number 2 is visualization from multiple data sets. So how amazing it is to have an aesthetically pleasing visualized data from a bulk of boring data set and have a single page visually, smartly and aesthetically telling you a story. And third is easily connects to many data sources. We can connect to multiple data sources like Excel, Azure, databases, etc., which leads us to have visual representation of the data. Now we are going to be talking about some examples of Power BI dashboard, but before that we also need to know the disadvantages of it as well. So the 3 disadvantages we have is we cannot slice it, we cannot filter it, and we cannot make a dashboard in the Power BI desktop. However, we can create a report in the Power BI desktop. So these are the 3 disadvantages of the dashboard. Now here we are with the examples, which is very fun to look at. The first one is customer segmentation dashboard. So as we can see from the dashboard, we have profit, sales, total cost, order returns. So we can see the visual graph of sales by region, which gives us a brief idea about which region to target more. We have total orders by city and return. So these visuals helps the organization make vital business decisions. And the next one is sales analytics dashboard. So it evaluates profit, sales, performance, etc. Here on this dashboard, we have net profit, fulfillment, income, and expenses. This is the same example we had in our hands-on example, just the same, almost different terms. And the last one is the finance dashboard. We have cash balance, day pay outstanding. These all are finance related information and are amazing information benefiting to finance. That's why dashboards are very useful to any existing business organization. Why organizations use Power BI dashboard? So, marketing campaign insights dashboards are using dashboard to understand efficiency. Sales analysis dashboard are using it to understand the performance. Product sales dashboard are using dashboard to understand, visualize the profitability, and email engagement analytics dashboards are using dashboard to analyze the data.
In the Power BI desktop, a data set is basically defined by a single query that specifies what data to include and how to transform that data. Power Query is a data connection technology that enables you to discover, connect, combine, and refine data to meet your analysis needs. It basically helps you take your raw data source and convert it into something more usable, more workable, on which you can build your analytics and then draw insights from it. The query is made up of related steps that build on each other to produce the final data set. And once you've defined that particular data set, you can use it to create visualizations that you add to your reports, which then you can publish to the Power BI service. Now, at the heart of the query is the Power Query M formula language, which is based off of a language called F#. And just like it, it is a case-sensitive data mashup language which is available to many of the Microsoft softwares, such as the Power BI Desktop, Power Query in Excel, as well as the Get and Transform import feature in the Excel versions post-2016. As with many languages, Power Query statements are made up of individual language elements such as functions, variables, expressions, as well as values, both primitive and structured, that together define the logic necessary to shape the data. Now, each query in the Power BI desktop is a single Power Query let expression. It basically contains all the code elements that are necessary to define your data set. A let expression is made up of a let statement and an in statement, as you can see in the syntax before you. So the let statement includes one or more procedural steps that define the query. Each of these steps is essentially a variable assignment that consists of a name as well as an expression that provides the variable's value. Pretty simple, that is what a variable is in most cases. It's 5th grade math, right? Variable is a name to which you assign a value. Now, this expression defines the logic for adding, removing, or transforming the data in a specific way. This is where you will be doing the bulk of your work, as you are going to see in the examples I'm going to give you later in this module. Now, the variable can be of any supported Power Query type. Each variable within a let expression must have a unique name, but again, the Power Query is fairly flexible about what you call it. Just make sure it makes sense and it's easy to remember for you. Now, you can include spaces in the name, but you have to enclose it within double quotes and precede it with a hashtag. Now, that is a somewhat cumbersome naming convention and one that I particularly prefer to avoid. It's honestly a mystery to me, even now, why it is the way it is, but let's just move on. Now, the variable names are also the same names that are used to identify steps in the applied steps section in the query editor's right pane. So I think it would be wise to use names that make sense. Now, strictly speaking, you do not have to define your procedural steps in the same physical order as the logical order. As in, for example, you can reference a variable in the first step of your procedure and then define it at the last step of your procedure. Now, this is something which is unlike the regular coding. However, this approach can make the code very difficult to debug, as well as cause unnecessary confusion amongst the coders. The accepted convention when writing a let statement is hence to keep the physical and logical orders in sync. Now, we spoke a lot about the let statement and none about the in statement. So a little input here. The in statement is basically like a return function. It returns a variable value that defines the dataset's final shape. Now, in most cases, if not all, this is most likely to be your last variable that you defined in your let statement. You can specify a different variable from the let statement, but there's usually very little reason to do so. So if you simply need to see a variable's value at any specific point in time, you can select its related step again in the applied steps section in the query editor. If you are not familiar with what it looks like, I'm going to show you in just a while once we open the demo machine. Now, when you select a step, you're essentially viewing the contents of the associated variable. With that, let's move on to our problem statement. Now, this session is going to include a number of examples that demonstrate how to define the procedural steps necessary to build a query. All of the examples are going to be based off of a data set, the link to which I will leave in the description box below. Now, the data set I'm going to use is the Titanic data set, which lists the passengers on the infamous Titanic voyage. It basically shows who survived it and who did not. Now, if you plan to try these examples for yourself, you need to create a titanic.csv file from the dataset that I'm going to link in the description box below and save it to a folder that you can access from the Power BI desktop. On my system, I saved it to a local folder in my C drive. Now, understand what we are trying to do here is to make this particular dataset a little more usable for you to lay analytics on top of. Yes? So now let's move on to Power BI and see how to do that. So the first step into building your own Power Query script is to add a blank query to the Power Query desktop. Now, to do that, what we're going to do is we have this Get Data button on the home ribbon in the main window. So I'm going to click on that. All right. Then I am going to navigate to the other section. And towards the very end, I'm going to find this option called a blank query. So I'm going to double click on this, or you can even click on Connect. Now what it does is that it launches this query editor with a new query listed in the queries pane on the left. Now it's conveniently named query 1, or you might have a similarly numbered name with a different number depending on how many queries you've created. Now to rename this query, what we're going to do is we are going to right click and select rename and maybe give it a fitting name like survival log. Okay. And then we are going to press enter. As simple as that. On the right in properties, you see the name has changed, which earlier was query 1. Next, let's go to the view menu. It opens up this ribbon and then click on advanced editor. Then it opens the advanced editor. Now, as this editor opens, you can see that there is a new let expression here, which is already defined. The let statement includes a single procedural step in which the variable is named source and the expression is an empty string. As you can see, it is indicated by double quotes. Notice that the variable is also listed in the in statement, again, source. And if I move this advanced editor a little to the left, you can see that the variable is even listed as a step in the applied steps section. Now, this is the part I was talking about earlier when I talked about applied steps. Now, this is that section. Here you can see all the steps that have been applied to your query editor, and you can click on each step to see what that variable holds. Now, for this exercise, we'll be changing the variable name to get passengers. So the first procedural step that you'll add will retrieve the contents of the titanic.csv file and save them to get passengers variable. Now, to add the procedure, we are going to replace the current let expression with a different one. Notice that this get passengers variable is specified in the procedural step in the let statement as well as in the in statement. Now, in this way, the variable's value will be returned when the let statement runs. It's as simple as that, as I had earlier mentioned, that the in statement is basically like a return function. Now, this expression in the procedural step includes everything after the equal sign. The expression uses csv.document as a function to retrieve the file's contents as a table object. It supports several parameters, but only the first one is required to identify the source data. As a part of the first parameter, you must also use the file.contents function right here to return only the documents data. And here you can see the location of my dataset. As I had already mentioned, it is saved in my C drive in a local folder called data files, and my file name is titanic.csv. Now the second parameter can be specified as a record that contains optional settings. So in Power Query, a record is basically a set of fields which is made up of name value pairs enclosed in brackets. Now the record in this example includes a delimiter and encoding options for the values. Now the delimiter option specifies a comma, as you can see right here, as the delimiter in the CSV document, and the encoding option specifies the text encoding type 1252, as you can see right here. This is basically the Windows Western European code page. Yes? And that's all there is to know and all there is to setting up a basic let expression in your Power Query. After you've entered your code, click on Done and close the advanced editor. And as you can see, that has run the procedural step, and the data set appears in the query editor, and it should look similar to what you can see right now. It's got a couple columns, it's got the survived, it's got names, it's got sex, age, passenger class, so on and so forth. Notice that the first step in the applied step section is now named get passengers, which is the same as your variable name. The procedural steps expression is also displayed in the small window above the data set right here. Now you can edit the code directly in this window if you want to. Whenever you add, modify, or delete a step, you should apply and save your changes. A simple way to do that is to click on this little save icon at the top left corner of the menu bar. When prompted, if I click on this, I will be prompted to apply my changes. And here I am going to click on apply. And with that, my query is saved. Moving on, another important thing is removing a column from the data set. Now, the next procedural step that you are going to add to your let statement basically will remove your duplicate column or column 6 from your data set. Now, because your data set is saved as a table object, you can choose from a variety of Power Query table functions to update the data. For this step, you'll use something known as remove columns function to filter out that specific column. So again, I'm going to click on the advanced editor and I'm going to get back to the query. Now basically, to remove the column, I am going to add a comma, give a space, and on a new line, I'm going to define the next variable or expression pair. Now to remove the column, add a comma after the first procedural step, and then on a new line, define the next variable expression pair, as you can see on your screens. The table.remove function requires two parameters. The first parameter specifies the target table that you will be updating, which in this case is the get passengers variable from the previous step. Second argument specifies a single column or a list of columns to be removed. This example specifies only column 6 from get passengers table. The important takeaway here is how the second step builds on the first one and then returns a new result, which is assigned to the remove calls variable. The new variable contains the same data set as get passengers variable, just without the column 6 data. After you add this particular procedural step, replace the get passengers variable in the in statement with remove calls variable, and next click done to close the advanced editor. You can then save and apply your changes. Your data set now should look something like this with 5 columns only. As you can see, the remove call step has been added to the applied steps section as well. And column number 6 is no longer included in the data set. To add more procedural steps, we follow the same logic as here, continuing to build on our growing foundation. The next step is to promote the values of the first row of your data set to the header row. So these values become the column names. So to carry out this step, again, go to the advanced editor, Now to carry out this step, add a comma after the last step that you defined, and then on a new line you can put the expression in front of you. This expression uses the table.promoteHeaders function to promote the first row of the column headers. The function's first parameter is required and specifies the table to use as the source data. This is just like you saw in the previous example, in which the new step builds on the previous step. The second parameter, promote all scalars, is optional but a good one to know about. By default, Power Query promotes only text and number values. When promote all scalars parameter is included and set to true, Power Query promotes all the scalar values in the first row to headers. The expression results are assigned to the promote names variable. Be sure to update the in statement with this variable name. Again, I'm going to click on done. And as you can see, our entirety of first row has turned into this header row right now. The rename columns function requires two parameters as usual. The first is the target table, which is the promote names variable from the previous step, and the second is a list of old and new column names. This is a list of an ordered sequence of values separated by commas and enclosed in curly brackets, as you can see before you. It's this entire line. And in this example, you can see each value in the list is its own list containing two values, the column name and the new column name. So I'm going to click on done. And voila, you can see all the names have been changed. Now the next task is to filter out rows that contain not applicable in the age columns, and then filter out rows with age values 5 or less. Now because the age column was automatically typed in as text when imported, you will need to filter the data in 3 steps, starting with the non-applicable values. Now to filter out these values, you will need the select rows function. Now, this function returns a table that contains only the rows that match the defined condition, age not equal to NA. As you saw the previous examples, the function's first argument is the target table, which is rename columns from the preceding step. The second argument is in each expression specifying that the age value must not equal NA. The each keyword indicates that the expression should be applied to each row in the target table. As a result, the new table, which is assigned to the filter NA variable, will not include any rows with the age value of NA. Clear? Now, once you remove the NA values, you should convert the age column to the number data type so you can work with the data more effectively, such as being able to filter the data based on numerical age. While changing the type of the age column, you can also change the type of passenger ID column to an integer 64 type. This way, you're referencing to the IDs by integers rather than text, as you can see right here. Now, to convert to the new data types, you should use this particular expression. Now, this uses the transform column types function to change the data types. The first parameter is the name of the target table, which is filter NA, and the second parameter is the list of columns to be updated along with the new data types. Each value is its own list that includes the name of the column and type. Once the age column has been updated with the number type, you can filter out the ages based on numerical value. Your dataset should now include only the desired data as it exists in the filter kids variable. Now, another handy transformation you might need to do at all times is to replace one column value for another. For this example, you will be replacing the 0 value in the survived column with no and the 1 value with yes using the table replace value function. Now kindly refer to the syntax that is shown to you and try to transpose the following elements that I'm going to discuss with the syntax on your screen. Now the table replace value function requires 5 parameters in total. First, you have the table, which is the target table, in this case the variable from the preceding step. Second, you have the old value or the original value, which has to be replaced. Then you have the new value, which you will replace the old value with. Then you have a replacer that carries out the replacement operations, and finally you have columns to search. Now, the column or the columns whose values should be replaced. Now, most of the parameters should be self-explanatory except perhaps the replacer parameter. For this, you can choose from the several functions that work in conjunction with the replace value function to update the values. In this case, the replace text function is used because text values are being replaced. So first, what we're going to do is that we are going to replace the 0 values with no. And after you replace the 0 values, you can replace the 1 values with yes using the same construction. Here you have your old value, which is 1, your new value, which is yes, the table, which is the replace 0 table, the replacer, which carries out the replacement function in the column survived. And then finally, I'm going to change variable at in. As you can see, I have changed the variable for replace 0, and hence all the 0 values have become no. Now let's go ahead and do the same thing for 1. And there we are. Now another way you can modify your column values is to change how capitalized they are. For example, you will update the values in the gender column so that the first letter of each of the words is capitalized rather than all being in lowercase. To make these changes, again, let's go back to our advanced editor, add a comma. Now again, this expression uses the transform columns function to update the 2 values. The function requires 2 parameters. The first is the table to be updated as usual, and the second is the list of operations to carry out. At times, you might need to provide additional information, but that's not the case always. For this example, there is only one operation, so you need to specify that the gender column and the text.proper function are enclosed in curly braces. The function converts the first letter in each word in the gender column to uppercase. At this point, your let expression in its entirety should look similar to what you see on the screen right now. The let statement includes all those steps and makes up your query to this point. Now, with each step building on the preceding step, let's click on Done, and you see the gender column with capitalized first alphabets. And on the right, you see the applied steps. And notice that the applied step section includes one step for each variable defined in the let statement. And all of them are specified in the same order that they appear in your statement. If you select a step, let's say this, the data displayed in the main windows will reflect the contents of that particular related variable. If I click on this, you see, we are back to the step where the ones were not replaced with yeses. Now, up to this point, each procedural step in your let statement represents a discrete action that is built on the preceding step. In some cases, however, you might need to structure your steps in a way that is not quite so linear. For example, you might want to create a calculated column that shows the difference between, say, a passenger's age and the average age for that person's gender. So for that, we need to first calculate the average age of the female passengers and save it to a variable, then calculate the average age of male passengers and save it to another variable. Or you can do it vice versa as well. This is optional. Then you can add a column that uses the 2 variables to calculate the age differences and round the age differences to a more readable number of decimals. Now this step is purely optional. Now to carry out these steps, again, I'm going to put a comma, go to the next line, and add a couple of steps. Now, this suddenly might have caused a lot of confusion. So what I'm going to do is I'm going to walk you through these steps in smaller chunks so you can better understand how they work. Now, the first line, which is preceded by 2 slashes here, which says add calculated column based on average ages, indicates a single line comment. Anything after the slashes to the end of the line is purely informational and does not get processed. Power Query also supports a multi-line comment that begins with a slash and a star and ends with star and slash, just like the multi-line comments in the SQL server if you might be used to that. It's up to you whether you want to include comments or not. Whether or not you do, The next step is to calculate the average age of female passengers. So these are the two steps. The first step uses the select rows function to generate a table that includes only rows with a gender value of female. The function is being used here in the same way you saw earlier, except that different data is being filtered out and the results are being saved to female variable. Notice that the source table for the function is the change case variable from the preceding step. The second step uses the list average function to calculate the average for the age values in that particular table, which is the female table. The expression returns a scalar value which is then saved to the average female variable. The function requires only one parameter. The parameter includes a second function, which is the table.column, which passes the values from the age column to the list average function. All right, so let's run these two and see. Now you can see we have the average female age right here, which is 30.7, a lot of 2's and 1. Moving on to the next two lines. Now we're doing the same thing for the male passengers, and for this you can use the same construction with a few minor changes. Notice that you must again use the change case variable for the source table when calling the table.selectRows function. Even though it's no longer the step directly preceding the new one, you can in fact use any of the previous variables in your expressions as long as it makes sense to do so. With the average female and the average male variables in place, you can now also add a column using the add column function, which is this one. The table.addColumn function requires three parameters. The first is the target table, which is again change case, and the second is the name of the new column, of course, which is the age difference column or age diff. So let's run all of that and see. And now you can see the average male age is around 32 years old. Finally, let's run our add column variable. And if we go to the extreme right, we see our new column with age difference is right here. But then there is an issue, isn't there? Let's go back to the advanced editor. Now, as you can see, this particular argument, the third argument, is the expression used to generate the column's values. The expression starts with each keyword which iterates through each row of the target table. Now, this is followed by an if-then-else expression that calculates the row's value based on whether the passenger is male or female. If the gender value equals female, then the age difference value is set to the age value minus the average female value. Otherwise, it is set to the average male value. But as you saw, all the values are in negative and have way too many decimal values specified. So after defining the new column, the final procedural step rounds off the age difference values to 2 decimal points. The expression includes the transform columns function, which you saw earlier, but it uses the number round function to round off the values rather than changing their case. The number round function takes 2 parameters. The first value is an underscore, which represents the column's current value, and the second is the value 2, which indicates that the value should be rounded off to 2 decimal places. That completes the steps necessary to create the calculated column. Your let expression in its entirety, after you change this to round diff, your let expression in its entirety should look something along the lines of this. All right. It should look something like this. This code I will also leave in the description box below. I'm going to click on done, and here you can see the age difference in plus and minus, whether people go above the age average or below. Now notice that the applied steps section includes variables used to find the average ages, even though the add column step in the code builds on the change case variable. You can view the contents of these variables by selecting each step as I had done before. And if you select one of the variables used to store the actual average, the query editor will display it on its scalar value, as again I had shown it to you before, but again if I click on average male, it shows a scalar value. Now the query only shows the contents of the average male variable, a rather lengthy number, and now you can see why I included the final procedural step to round the values in the calculated column. Not surprisingly, there's much more to Power Query than what was covered in this particular module. But this should give you the foundation you need to start building your own queries in the Power Query desktop. It should also give you a better understanding of how these queries are constructed when using a point-and-click feature to import and transform your data. In this way, you can examine the code to better understand why you might not be getting the results that you expect. You can also start building your own query by using point-and-click operations and then use the advanced editor to fine-tune your datasets or to introduce logic not easily achieved through the interface version. To make the most out of Power Query in the Power BI desktop, you'll need to dig a lot deeper into the M language's various elements than what we've covered here, especially the built-in functions. Keep in mind though, the Power Query was built with Excel in mind, so you might run into elements that don't transfer easily to Power BI desktop environment. Even so, the basic principles that define the language and its syntax are fairly the same, and the better you understand them, the more powerful a tool you have for working with the data in the Power BI desktop.
What is data visualization? Now, data visualization is basically the graphical representation of information and data. There can be many visual elements like charts, graphs, and maps. Here, data visualization tools really provide an accessible way to see and understand different trends that can occur in this data, or outliers and patterns. Anything that could be in this data could be visualized and found using data visualization tools. Now, in the world of big data, data visualization tools and technologies are very essential to analyze really massive amounts of information and then make some data-driven business decisions to help their organization. Also, with the technological revolution that's occurring, data really went from being expensive, difficult to find, and collect to abundant, cheap, but incomprehensible. It is audacious to store, understand, and analyze increasingly large volumes of data with traditional softwares and tools. However, as individuals or even as an organization, all of this data is only as good as what we can make out of it. And this is where big data comes really into the picture. It is used for predictive analysis, analyzing user behavior, or any other data analytics processes to bring value to the data that is present. Yet the raw details about this can remain uncertain due to lack of knowledge and lack of skills. Data visualization really helps to tackle this particular issue that we are facing. It is basically the process of transforming data into visualizations like charts, images, graphs, and even videos that really explain the numbers and allow us to gain some insights from it. So in short, you can say that it makes information more coherent and really adds value to it, discovers new patterns, spot trends, etc. Now let me explain this with a really simple example. How do you explain the various rows and columns of data in an Excel spreadsheet to your boss or customers? You obviously will create a chart like, a line graph or scatter plot and even a bar chart of the same data. So what it really does is it gives meaning and purpose to the original raw data that was present initially, so that you have a visual representation of it and you can start analyzing it and integrating it with colors and giving more meaning to your data. This has really empowered many businesses and organizations by providing a much more clear and actionable insight to programs, as it can keep you ahead of the game. Let's move ahead and download our data set that we will be working on today. So for this, I'm just going to go to my Google search engine and I'm going to click on Kaggle. So Kaggle is a very big platform for people to work on various data sets, and people from all over the world upload their data sets that they work on. So you can download any of theirs and work on it in your own projects. So I just click the data option on the left hand side and I'm just going to scroll down. Today we'll be working on the COVID-19 data set. So we'll just download any of the data set that is available. Here you can see once I scroll down, so there's a separate option for COVID, and I'm just going to click the novel coronavirus 2019 data set. This has been uploaded by SRK, and I'm just going to scroll down and check out all of the available data sets. So you can see that there is one COVID-19 data set. There is also confirmed cases, confirmed US, deaths US, and finally the recovered cases. I'm happy with this data set, so I'm just going to download it. Because this is in a zip format, I'm just going to click on extract all, and I'm just going to click extract. So that's done. Okay, this is great. So I'm going to quickly move back to my Power BI desktop, and I'm going to click get data, and I'm just going to click text to CSV file. I'm going to click archive one, and I'm just going to upload the data set. The first data set is the COVID-19 data. Currently, this is a CSV file, and you can see that Power BI has prompted a window with all of the available data in the current data set. You have observation date, you have the state, you have the country or region, the last update, confirmed, deaths, and recovered. I'm happy with this data. I'm just going to load it into my Power BI. It'll just take some time to load all of the data. You can see in the field section, you have the data set COVID-19 data, you have the confirmed cases. So the various columns that were available, the confirmed cases, country, the deaths, the last update, the observation, the province, state, recovered, and the serial number for each of them. So this data set is what we'll be working on. We'll just build some visualizations, some really simple visualizations, and we'll create dashboards. So this is just one data set that we'll be working on. Okay, so what we're going to do is we will learn how to create a few charts and understand how you can analyze the data. So we'll be creating visualizations now. So on the first page, let's create and work on bar charts. Okay, so what I'm going to do here is I'm going to select a stacked bar chart. That's the first icon that's available. And I'm just going to click on country or region. And I want to plot or view the confirmed cases of different regions. So I'm just going to track the confirmed field, and I'm just going to drop it in the values add data fields here. Okay. And what it really gives me is it gives me an overview of all the countries with the confirmed cases. As you can see, US is on top. So this is 2019 data. So that is pretty old data. We are in 2021 right now. So as you can see, back then, US was on top, followed by India, Brazil, Russia, France, UK, and so on. So these are all the confirmed cases. You can also really add filters. You can just scroll down. You can add is less than some certain number. You can see that bar chart. On page 2, so this is stacked bar chart that we've just worked on. In the second one, we'll create visualizations using line charts. So again, I'm just going to click a line chart, and I'm going to click the country or region because that's important. So I'm just going to click on province or state here now, and we'll check out the number of deaths, and I'm just going to drag and drop that in the values field. And you can see the number of deaths that have occurred in England, and then Maharashtra, Cambodia, Rio de Janeiro, Texas, Florida, and all of that is given in your line chart. Again, you can just add some filters if you'd like to. I'm not going to add any filters as of now, and I'm going to create a new page. So if you click on the 3 dots that are available, you can export data. You can show this as a table too if you'd like to. So that's pretty nice. And you can also sort them accordingly, according to ascending order, according to descending order. All of that can be done. So that's great. So if I scroll down, you can see the number of death cases in each of the state that is present. Okay. And I'm just going to click back to report. So this will just take me back to the visualization. Okay. Now I've created a new page, that is page 3. And here what we're going to do is we are going to create a pie or donut chart. Okay. So pie charts are quite well known. However, when it comes to displaying a lot of data, it is not recommended that one uses a pie chart because it can be really difficult to identify tiny differences between each of these categories. So what we're going to do here is we are going to click a pie chart. You can see the icon that's right here. I want to check out the recovery. So I'm just going to drag and drop this values here. And I'm going to click on the province and state. Okay. So as we've already mentioned, there can be a lot of problems using pie chart because each of these tiny differences cannot be figured out in a pie chart. So what I'm going to do here is I'm just going to look for states in India. I'm just going to look for some major states: Maharashtra, Karnataka, Delhi, Tamil Nadu, Uttar Pradesh, Uttarakhand. I'm just going to mention all of the states that I can remember from India. You have Andhra Pradesh. We have just picked up a few states from India and I have represented them in this pie chart. Now you can see that it's much more simpler, and you can see that Maharashtra has the most number of recovered cases, followed by Karnataka, then Tamil Nadu, Delhi, Uttar Pradesh, and then finally Uttarakhand. So it's pretty nice to represent tiny data sets in pie charts. You can also use donut charts if you'd like to. So I'm just going to click a donut chart. A donut chart is also a very pretty visualization that you can use. Moving on, you can use KPIs, that are key performance indicators, which are really a measure of the company's performance and it evaluates its success. We can display this in Power BI using the card or gauge. You can use the gauge or you can also use the card panel. So what I'm going to do is I'm going to create another page. So I'm just going to click on the gauge option, and what I'm going to do is I am going to add the number of deaths. Okay. So you can see that this is given in a gauge format. If you want it in a card format, you can just pick the card option. So these are the KPIs that you can work on. And now if you want to delete a chart, you can simply click on it and just click delete on your keyboard. If you want to add a new page, as I've already mentioned, you can just click on the plus icon. So now we will learn how to create a dashboard. What you can do is you can just copy paste all the visualizations that we've created so far onto the same page. And this basically gives a dashboard. That's how easy it is. Okay, and I can move this. So I can just click on the visualization, copy, go back to page 1, and then paste it. I can also resize each of these visualizations as I'd like to. And that's it. That's how easy it is to create your own dashboard. This is your dashboard on page 1. And you can also obviously change colors if you'd like to. So if you even want to change colors in your visualizations, you can do that. You can just go to this format icon and you can just click data colors and you can switch colors. Okay, we'll switch to something light maybe. Okay, you also want to change the colors in your legends of your bar chart. You can do that. You can just go to, again, the format option, go to data colors. So just click on for show all. You can see that different countries can be chosen with different colors. So you can choose France of one color and you can represent UK in another color and Colombia in another color and so on. You can do that. And all of the changes will be reflected in your visualization immediately. Okay. So now what we're going to do is we're going to learn how to save. Okay. Just click on save, name your file as anything you'd like to. I'm just going to name this COVID-19. I'm going to save this file. And if you want to publish your work, you can do that too by clicking the file option. You can see the publish option and you can just publish to Power BI. Okay. Here you have to enter your email address, and then once that is done, you can just publish it. So let's move ahead and check out one more use case of Power BI. So as in the case of most modern technologies, Power BI is also likely to embrace the law enforcement agencies, which are benefiting immensely with the use of big data analytics and other technological innovations. Power BI dashboards can be used very effectively to get insights into aspects such as deployment of personnel at critical locations during specific periods of the year by plotting various parameters such as the types of crimes that occur, the incidences, the crime patterns, etc. Like many of the factors and parameters can be involved in really finding the crimes that take place in a certain area. This is really helping the police and the other forces into getting a better insight into where crime can occur over a certain area and how it can be also prevented. So this is just one use case. Power BI can be used for many instances and many use cases to find and make better decisions in our daily lives and in our organization too, if you are working in any.
In the prevailing world, every organization relies on taking data-driven decisions. But have you ever thought, how does data lead to decisions? In order to make a data-driven decision, data needs to be studied and analyzed to identify the factors that may influence your business on the run. And to make things easy for you, here comes Tableau. The renowned IT research firm Gartner has deemed Tableau to be one of the best BI tools for data visualization. But why is it so popular? What does it actually do? Imagine this. Your boss gives you a sheet with millions of rows and columns. He then asks you to find patterns from the data. It is going to be a hard time for you to even go through it. Forget finding patterns. Traditionally, you would be dumping this data in your database and would be writing SQL queries to refine your data to gain insights from it. And no doubt that you need to be really good at it. Then you would be plotting charts to make it look presentable. Now imagine doing all of this with just a simple drag and drop. And that's what Tableau does. With its simple drag and drop user interface, Tableau writes optimized SQL queries at the backend to fetch data from your data source in the desired way. Talk about visualizations. With its high-end graphics and color schemes, Tableau makes the charts look as apt as possible. You can plot bar charts, pie charts, bubble charts, heat maps, tree maps, and even scatter plot on a real geographical map. With Tableau, you can even drill down your data using filters and visualize your data at a granular level. That's the power of Tableau, and that's how easy it is to harness the power. Just clicks, drag and drop. From large-scale corporates to small-scale organizations, Tableau is used and preferred by everyone, everywhere. Tableau product suite includes tools for development like Tableau Desktop and Tableau Public, and sharing tools like Tableau Server, Tableau Reader, and Tableau on Cloud, which is Tableau Online. A company called allrecipes.com was successful to harness this power, which in turn helped them to improve their user experience and gain an even bigger consumer base. With Tableau, allrecipes.com can understand every stage of the customer journey, from analyzing web analytics to tracking content engagement. Visual analysis allowed them to spot and stay on top of emerging trends. By leveraging Tableau analysis, they were able to see an immediate improvement in their business and scaled up to 1.5 billion annual visits, making it a top media food brand worldwide. This is how every organization is using Tableau. Time to find out what you can do with this ever-rising tool. So what is Tableau? Well, Tableau is known to be a groundbreaking data visualization software created by Tableau Software. So with Tableau, you can easily visualize your data. Now, your data mostly lies in form of spreadsheets, in rows and columns, with numbers and text. So it is hard to just identify problems and come up with solutions just by viewing numbers and text on a spreadsheet. And that is why you need to visualize that data in order to understand how your business is going, what are the problems, and how can it be solved, and also identify the interdependencies as well. What Tableau does is that at the backend, it writes optimized SQL queries in order to fetch your data from the database and then present it to you in a visual form, which is very attractive and also very insightful. So in order to summarize, it's a data visualization software that makes our work very, very easy. And plus, it is also very easy to use. For example, Let me connect to the Superstore data in Tableau. So there are measures and dimensions in Tableau, which are nothing but different fields that you can use to create your visualizations. Measures are usually numeric entities or numbers, and dimensions are text. So let us see in our Superstore which is the customer segment that makes the huge or most purchases. So just drag and drop the segments to the columns, and we want sales in rows. And you can see here directly that the consumers or individual buyers are the ones who purchase most of the products as compared to corporate or home office customers. Now let us see what are the products that they purchase. And there you go. It has listed out different products they buy. So these are the items that are purchased on the Superstore with the bar chart indicating their number of sales. Well, you can also sort it according to your own convenience. And this is how you do it. Now, if you just hover on a bar, you can see the details as well. Now let's just find out which are the most profitable items. Just drag and drop the profit to colors. And the color legend over here indicates the darker the orange, the more is the loss, and darker the blue, the more is the profit. And here we have phones with the darkest blue, and if you see in this case, tables, which is one of the highest selling products, is under loss. Now these are the things that you can understand by visualizing, and Tableau is a very good tool for that. Moving on, Tableau is also a leader among all the BI tools. Now this is Tableau's 5th year to be on the leaders chart or in the leaders quadrant in the Gartner's Magic Quadrant. Now it is among the leaders, and it has beaten other BI tools like Microsoft Qlik, Salesforce, etc. Now let us take a look at the Tableau product family. Now the main development tool in this Tableau software suite is the Tableau Desktop. So with Tableau Desktop, you can connect to numerous amount of data sources. You can connect to your data in your local system. You can connect to cloud databases. You can connect to cloud applications. You can even connect to big data with Tableau Desktop. And this is a very good development tool. This is where you create all your visualizations and your dashboards that you want to share across your organization or with your friends. Then we have got Tableau Reader. This is again just for viewing purpose. If someone has created a dashboard or a workbook in Tableau Desktop, you can view it in the Tableau Reader. Now you can interact with the visualization with filters, but you cannot make any changes to it. Then we have got Tableau Public. Well, Tableau Public is also used for creating dashboards and worksheets. The only difference is that you cannot save your workbooks in your system. You have to publish it in the Tableau server where it will be available publicly. And it has also limitations to connect to data sources, unlike that of Tableau Desktop. Then we have got Tableau Server, which is an enterprise level sharing tool. So if you want to share all the dashboards across your enterprise or organization, you can use Tableau Server for that. It is secure and reliable. Then we've got Tableau Online. Now this is just Tableau hosted in cloud. So you can view your workbooks and your projects that you have created in Tableau Desktop in your Tableau Online. Moving on, let us understand the need of data visualization. So there is a very good example to make you understand why do we need to visualize this data, and this is the Anscombe's quadrant. Now these are the X and Y points that you can plot on a graph, and it is there for 4 different quadrants. Now if you take a look here, the numbers are almost the same. The sum, average, and standard deviation are completely equal. So you might be thinking that when we plot these points on a graph, the graph will look pretty much the same. But when you actually plot it, you can see it is completely different. The lines formed by these points are completely different from each other. And you wouldn't have known that unless you have plotted it and visualized it. And that is why you actually need to visualize your data in order to understand the differences in situations, and that is how you come up with different insights and solutions to your business problems. And that is how Tableau exactly helps you. Now let me show you a sample workbook, and I will let you know what ways you can make visualizations with Tableau. So here is a workbook on the world indicators. So before making the workbooks, First thing you need to do is connect to your data source. Now this is a world indicator dataset. In the first worksheet, we're going to find the relationship among the population and birth rate. You can create a new sheet from over here. You can click here and it will open a new worksheet for you. Now I have dragged and dropped latitude and longitude over here. These measures help you to plot an actual map in a Tableau worksheet. If your dataset contains any geographical location, Tableau detects it and it can plot a map just like this. For example, we have country here. Well, this is just a simple visualization, like a simple scatter plot with varying colors and sizes, but it gives you a lot of information. Here, bigger the circle means bigger the population, and the color legend description is over here. So if the birth rate is above 3%, it is red. If it's between 1.5 to 3%, it is gray. And similarly, the description is over here. So clearly we can find out here that even if China has a huge population, the birth rate is quite low because it's blue. You can see in countries in Africa that even though the size of the circle is quite small, it is red, which means birth rate is quite high over here. Here you can get an indication that the population is low even though the birth rate is high. And this could only lead to the fact that the mortality rate in these countries is very high. So you can identify threats just by visualizing the data. And you can conclude here that there might be fatal epidemics or famines spread in the countries because of which the population is less but birth rate is high. Similarly, if you want to view the infant mortality rate in different countries in Africa, you can visualize it like this. The color legends are over here. For birth rate, it is blue. For infant mortality rate, it's orange. For health, it is yellowish. And for life expectancy, it is purple. Similarly, you also want to see the care spends. So if you want to check which countries spend more than 14% of GDP on healthcare, you can edit this part, edit the text of the question here. You can even add filters to adjust the threshold value, which is 14% in this case. Let's drag it to 8%. You can see that the text also gets changed here because I have included the variable in the question. And it looks like every country spends at least 8%, just leaving the African countries, which explains the health situation. Now let's check the technology worksheet. You can use filters to drill down a single country view. This is for Argentina. Now you can make dashboards to combine all the worksheets together. Just drag and drop sheets to create your dashboard. Dashboards in Tableau are interactive as well. You can make changes directly in your dashboard, which will reflect in your worksheet too. Finally, you can also sum up everything in the form of a story, just the way we found out that there was an imbalance among birth rate and population in Africa. And the best part in Tableau is that in order to tell a story, you don't need a storyteller. You can view the story just by clicking ahead. And stories are also interactive. But let me tell you, even if you make any changes here, it will not reflect in your actual worksheets like that of dashboards. So these are the kind of things that you can do with Tableau.
What are Tableau products? So Tableau has a number of products like Tableau Desktop, Tableau Reader, Tableau Public, Tableau Server, and Tableau Online. Tableau Desktop is a paid desktop application where developers create charts, formulas, dashboards, actions, and other visualizations. The dashboards which are created here can be published to Tableau Server or Tableau Online or Tableau Public Server. It can also be opened in Tableau Reader. So that's about Tableau Desktop. Now, Tableau Reader is a free desktop app which can help us to view the Tableau dashboards created in Tableau Desktop or Tableau Public. So Tableau Reader is basically a reading tool for the existing workbooks. But the security level in Tableau Reader is pretty low, as anyone who gets the workbook has an access to it. Next, we have Tableau Public. So in Tableau Public, workbooks cannot be saved locally, and it gets saved in Tableau's public cloud, which can again be accessed and viewed by anyone. So it is specially built for the cost-effective users. So next, we talk about Tableau servers. So Tableau Server is basically designed to share workbooks and visualization that are firstly created in Tableau Desktop or Tableau Public. But Tableau Server is highly secured and only the licensed users can have access to it. The admin of the organization has the control over the server, and both hardware and software are operated by the organization itself. Next, we have Tableau Online, which is again similar to Tableau Server only. So Tableau Online is also a sharing tool, and the functionalities are similar to that of Tableau Server, but here the data is stored on the servers hosted in the cloud, which are maintained by the Tableau groups. So that's about the products of Tableau. Next up, let's discuss what is Tableau Server. So Tableau Server is basically a web-based platform where we can share our workbooks, reports, and dashboards made in Tableau Desktop. But these dashboards can be accessed only by the licensed users. So the data security is very high in Tableau Server. Now let's look into the difference between Tableau Server and Tableau Online. So when we create a dashboard on Tableau Public or Tableau Desktop and we want to share it across our colleagues, on the front end, there's absolutely no difference between Tableau Public and Tableau Server. So the main difference is where the data is being stored in the backend. So Tableau Server is hosted by the customers or the organization itself and their data engineers. So that way the data is accessible to only the users with licenses and only the admin will have the control over sharing the data. Whereas Tableau Online is hosted by Tableau itself and it's a software as a service. So the organization do not need to purchase and maintain a new hardware for Tableau Online. Whereas for Tableau Server, organizations need to manage everything on their own. Upgrades, facilities, hardware optimization, everything is managed by Tableau for Tableau Online, whereas Tableau Server is for organizations who focus on data security and complete control over the data workloads. So that way Tableau Online is a bit costlier than Tableau Server, as Tableau itself manages everything in Tableau Online. So next, let's look into the components of Tableau Server. So there are total 8 components. The first being Gateway. So Gateway is basically a kind of web server that helps clients to communicate to the server via HTTPS. So the server receives incoming client requests and directs them to the appropriate server for action. A gateway handles processes such as load balancing, traffic routing, URL rewriting, serving static files to clients, serving multi-thread processes, and things like that. Next, we have application server. So gateway interacts primarily with the application server, which is also known as work group server. The application server basically deals with login processes, domain authentication, data authorization, user or group permission management, content searches, etc. It basically works association with the server's repository and handles data access operations. Then we have repository. So the repository in Tableau Server stores server metadata related to user permissions, assignments, groups, and projects. So along with the metadata, it also stores visualizations in flat files and performance data for auditing. So whenever a server service or component demands for metadata, it is provided from the repository. Also, it cooperates with the Active Directory to provide useful information to the app server for login verification process. Next, we have 𝐷𝐶QL server. And it is a very important component of Tableau Server, as it is responsible for loading all the visualizations that you see and work on with Tableau. So basically, it has an inbuilt caching for performance improvement and editing tasks. Whenever a user requests a visualization or wishes to update an existing one, a request is received by the 𝐷𝐶QL, and then it is converted into SQL statement and sent down to the data sources via respective data source drivers. So that's the job of 𝐷𝐶QL server. And next we have data engine. So the data engine is another efficient component which handles processes related to Tableau data extract. It is invoked only when a query is short, which involves data from TDE. The data engine stores multiple TDEs and can run on multiple servers. Then we have backgrounder. Backgrounder is an essential multiprocess and a multiprocess element that manages schedules for information refreshing and ensures proper functioning of the Tableau server and data engine. Penultimately, we have data servers, so which helps in centralizing the metadata management, driver deployment, and extract management. And lastly, we have search and license. So these are two very important components again. The search component manages the search indexing for the data in the repository, whereas the license component is responsible for licensing and configuration of the Tableau server. So that's about all the components of Tableau server. Now let's look into the architecture. So let's see how all these components work together. That's about the architecture. So here we have multiple layers. We have 5 layers or sections in the Tableau server. Firstly, the customer data, next the data connectors, then main components, then gateway, and then clients. So in the customer data layer, we have all sorts of data sources available for a Tableau user, like the data warehouses, data marts, files, cubes, and relational databases. Then in the second layer, we have the data connectors. In this layer, we have data engine, SQL connector, MDX connector, and the repository. So the data engine processes the data requested by the user and assigns the data type, decides whether it is a measure or a dimension, and then create TDEs. So at the background of the data engine runs an SQL connector, which creates an SQL query for all the user requests and interacts to the data sources. The SQL connector primarily deals with the data marts and flat files. Similarly, the MDX connector deals with the multidimensional cubes. In the third layer, we have the main components that are the data server, 𝐷𝐶QL server, and application server. So the application server takes all the user requests coming from the Tableau desktop, mobile, and browser for accessing the visualization. While the 𝐷𝐶QL is a patented component of Tableau, which means visualization query language. It basically works behind the logic of Tableau visualization and creates the visualization as per your instructions on the dashboard. In the fourth layer, we have the gateway. So the gateway is the gatekeeper of the Tableau server, and any request or query sent by the client first hits the gateway or load balancer. So basically a gateway is nothing but a primary server which receives the queries and redirects it to an appropriate available secondary server. That is the worker server. So finally, the fifth layer consists of the clients, where we can visualize the dashboards in desktop, mobile, or browser. So that's about the Tableau server architecture. Next, we will see how to install the Tableau server. So the setting up a Tableau server is a fairly easy process. There are multiple ways to install it on your system, such as automated installation or jumpstart installation, or installing Tableau in an air-gapped environment, cloud installation, and Tableau online. However, in this slide, we will discuss how to install the Tableau server from the website. So firstly, you will have to open the Tableau website on your browser and click on the Tableau server from the products drop-down menu. As you can see in the slide here, from the products drop-down menu, you have the Tableau server. So once you select Tableau server, it will lead you to a page where you'll have this option of try it for free. So once you choose try it for free, you can download the setup as per your requirements. So here after this, you'll be led on to a page where you'll have multiple options. Here we will choose on-premises version. So once you select on-premises version, you'll get a pop-up where you'll have to put your business email address and download the setup file. So once the setup file is downloaded, you open it and select the location for the installed software files and leave the default. You open the setup file and select the location for the installed software files. And then you click on the next button. So after that, you will have an option of create new Tableau server installation. So you click on the checkbox for the authorization to run to activate the server. So then you click on the install button and wait for the installation to be finished. And finally, you can enter the product key that you've received in your mail and follow the registration process and complete the setup. So that's about installing the Tableau server from the Tableau website.
Tableau Online. Now the question is, why do we actually require this Tableau Online? So this Tableau Online, if I want to define it in a few sentences, I can say that this Tableau Online is a powerful way for the organization to build, share, and collaborate around the data analysis. Okay, so it will help the people of that organization to share and collaborate in the cloud, which means the people who are users of the Tableau, especially the Tableau Online, so they don't have to worry about setup in their personal computer. So it's an analytics problem, analytics product or a platform, and this analytics platform, which is Tableau Online, so it is fully hosted in the cloud. And by using this fully hosted on the cloud, So the users of the organization can publish dashboards, share their discoveries and the insights with anyone, especially in their own company, and they can invite colleagues or they can also invite the customers to explore more hidden opportunities by creating beautiful visualization with accurate data. And the best part is it's easy accessible from the browser, or the users can actually access the data or the visualization on the go with the help of mobile apps. So that's the benefit of using this Tableau online. So it's fully hosted on cloud, which means people do not have to worry about server setup or software setup. That's actually the second advantage or second reason as why we require this Tableau online. So by skipping this setup time and the hardware cost, so we can actually get up and running in minutes, and we can actually seamlessly add multiple users as per our need and as the organization grows. And by using this Tableau online, which is a fully hosted solution, so we never have to worry about configuring the server, managing the software upgrade, or even when I think about scaling, I don't have to worry about scaling my hardware capacity, because this Tableau Online is a fully hosted solution. And another reason why people or companies prefer to use this Tableau Online version is, more specifically, whenever we are working with this data source, so we can ask the question in a natural language. Now, when I talk about this natural language is the language that we humans speak. So currently, to converse with you or to explain what exactly is this Tableau Online, I'm speaking in English language. And I'm speaking in a way where we are comfortable with, where we are familiar with. Now, the best part about this Tableau Online is this Tableau Online supports natural language, which means I can empower my organization to ask the question from any published data source. So I can have any published data source. Data source is something where I have my data set present. Okay. So I can empower my complete organization to ask questions from any published data set using natural language. That means using the language which we are comfortable with. An example can be saying it as, hey, what's the average sales per day, or what's the average sales in the last week? So I can just type this question over here in this Tableau Online, and I can get the necessary output in the format of visualization. And I can also control as how the visualization should look like, whether I need a bar graph or whether I need a scatter plot, depending on the question that I'm asking over here for my data source. So here what happens is, with the help, we actually call this feature as a ask data. Okay, so with the ask data, so we can just type a question and we can get the answers in the form under the hood with the help of powerful visualization. But what happens in the backend is it actually makes use of powerful natural language algorithms to automatically profile, index, and also optimize the data sources. And along with these benefits, or along with these features, with the end-to-end web authoring capabilities, it's always easy to add additional data sources, or even if I want to create an interactive dashboard as well. So that's the feature about Ask Data. Okay. Now, the another important advantage or important feature when we talk about this Tableau Online is, so we can have the AI-driven explanations for the given data. Okay, so which means I can leverage the power of AI, which is the artificial intelligence, to explain the data points with a single click. Now here, on the basis of statistical model, I can explain the data, which in turn helps me to uncover the insights which I may not have found otherwise. And the another best part is, while working with Tableau or Tableau Online, so I can also embed the Python code with the help of TabPy add-on, and I can also make sure that during the execution, I'll be doing the statistic-based analysis as well. So which in turn helps me to explain the data in a much more efficient as well as meaningful. So it will help me to explain in much more efficient as well as in a more meaningful format. And the best part, especially when it comes to normal users, is so it will help the users to interact, edit, and author on the web page itself. So by doing like this, the users can spark new insights even on the go. That means they don't have to install anything. They can just log into their tabs or in their a company provided laptop, no matter where they are in, they can just spark insight even on the go when they're traveling. They can just create the visualization and try to get the insight that is present in a given data set. So which means here we are going to give the people the power to explore these interactive dashboards from anywhere. And by giving this ability, the users can drill down and they can also highlight, and obviously they can also do the filter the data on the fly. Now by doing like this, they'll be customizing the views with robust web editing, as well as by authoring the new workbooks from the published data set which they already have in their organization. So that's another advantage when it comes to Tableau Online. And not only this, so especially while working with the data, so the users can connect to any data anywhere. That means they can actually connect to databases like Amazon Redshift, Google's BigQuery. So they can connect to databases like these other databases, and from these databases they can actually refresh the data automatically, and while refreshing they can actually make use of web apps like Google Analytics and Salesforce. And while refreshing, they can also perform the like query on on-premise databases, or even we can actually schedule and extract the refreshes from the Tableau bridge. So the power is always in our hands as where exactly that we want to keep the data and from where I have to fetch the data. And when we talk about security, so security is one of the important thing whenever we are dealing with enterprise data, because that contains the day-to-day information, day-to-day transactions, and it contains the gold mine. Because as I mentioned at the start itself, some of the important asset of any company is data and its people. So here we are giving the power, that is the power of data, to the people, and it's very important that we keep it secure. And coming to Tableau, so Tableau has highest level of security standards, and by default it is present, and by design it is set to make sure that the product that they have built is very secure. So here we can actually empower the site admins to easily manage the authentication, and we can also set the permission for the users, content, as well as the data as well. And here, like when we talk about Tableau, so it's easy knowing that Tableau's online, it's worth noting that this Tableau's online infrastructure, it actually meets some of the suggested highest level of security practices. So last I've seen, it actually supports SOC 2 requirements when we talk about the security of Tableau product. And another best part of working with Tableau Online is we can effectively manage the data environment. So which means I can actually make use of Tableau data management, which will help me to better manage the data within my Tableau Online. And by doing like this, I'll be ensuring that the trusted data is always used to drive the decision. Now from data preparation with Prep Conductor, that's one more product from Tableau. So from data preparation with Prep Conductor to cataloging, search, and governance with Tableau Catalog, the data management add-on will actually build the confidence in the data that we are working with. Thus, it's going to accelerate the adoption of self-service analytics, because that's what we want to drive, isn't it? So we want to give this ability to do the analytics or to derive the insights from the data to the people that we already have. So by enabling the various products that are present with the Tableau, and which we can combine it with Tableau Online, so we'll be giving the power to the users itself directly. And not only that, so by doing like this, we'll be empowering the organization with insight. So as I mentioned, so it will help us to accelerate the adoption of self-service analytics. And not only that, so this Tableau Online has dashboard starters. So when I talk about this dashboard starter, so it's actually designed to help you hit the ground running with actionable data in a matter of few minutes. So with just few clicks, I'll be able to connect to popular web applications and create pre-built dashboards in a seamless manner. So that's another advantage of working with Tableau Online. So whenever we are empowering this organization with the data, so it actually helps me to enable everyone in my organization to see and understand the data with offerings for every user type. So the user type can be many things. So I can have an end user, I can have an business analyst, I can have a data scientist. So we can control what is the data and what is the depth of data that will be shown for each and every users. Now, as I mentioned, it could be end users like casual users who are just looking to make a data-driven decisions from a published dashboard. So these users, you can think of them as the end users. So who can be like a salespeople who just looks into the published dashboard, and on that basis they are going to decide, okay, which product should I sell to the next customer, which will help me to boost my sales. Or it could be data enthusiasts in the organization who actually want to use the web authoring to ask new questions from a published data source. Or it could be data geeks who actually want to create and share the wizards and the data sources with the rest of the organization. So this Tableau Online, it enables everyone in the organization by giving all this flexibility and all these features. Now here, whenever we are talking about this Tableau Online, so it's our data which will be powered by the cloud. So here under the data management, this Tableau Online centralize the access to the data in the cloud, and it will help us to publish the data models, and it actually makes it everyone like which is an easy to work with from a curated and a single source of truth. And if I'm using this Tableau Online, so this would make sure that the version that I'll be using, it's always up to date because it's a managed by Tableau and it's a complete end-to-end solution. So which means we don't have to worry about deployment, we don't have to worry about updation. So everything will be taken care by the Tableau automatically. And the best part is even when the latest version releases, so we'll not have any downtime during the upgrade as well. And this Tableau Online, it's a subscription based service. So it actually gives the power to the companies to subscribe anyone on our website and choose when people receives any update. And last but not the least, the reason that we would prefer this Tableau Online is, so when we talk about Tableau, the innovation comes as a part of the standard offering. So it has been noted that this Tableau, they actually invest more in R&D than any other businesses in that data visualization industry. So there's always some or the other updates which are coming around, and each update will actually is actually what we have seen is like each and every update that is being released by Tableau. So it is actually making the product a better and better one. So now that we have understood why do we actually require this Tableau Online, so let's understand what exactly is this Tableau Online. So as I mentioned already, it's a cloud hosted SaaS platform. So SaaS is nothing but software as a service, okay? So which will help us to perform the data visualization and business intelligence. So this will help us to build, share, and collaborate the data that we have in the organization and help us to derive the insights from it. Now that you have understood about the importance of Tableau and why do we actually require this Tableau Online, let's look at the structured learning when we look into learning this important topic that we have just seen, that is the Tableau. So I'll give you a demonstration as how does a structured learning path would look like if you're learning with us. Okay, so in case if you're planning to have your own self-paced learning journey, we recommend you to follow the same learning approach because this learning path is curated by the industry experts as well as the professors from NITW. So this learning path is actually curated by the experts and the industry leaders. So as a part of your module 1 of this Tableau certification training, so you'll be understanding how you can perform the data preparation using Tableau. And this is followed by an hands-on session, followed by a module 2 where you'll be learning how you can create a connection with Tableau. The reason because, as I mentioned already at the beginning, we'll be using the data, and this data can be present in various sources. It could be in my Redshift or it could be in Google BigQuery table. So it could be in multiple sources. It's very important that we understand as how we set up this connection. And this is followed by an hands-on activity. And as a part of your module 3, you'll be understanding about the basic visual analytics, where you'll be learning how to create a basic plots, which will help you to derive the insights in a matter of few clicks. This is followed by a hands-on session, which will reinforce the learning that you'll be learning as a part of your module. And this is followed by module 4. Here you learn how you can perform the calculations on the data, because not every data that you will be having can be directly used. So we'll have to do some kind of aggregation, some kind of mathematical operation to summarize the data that is given to us. Just to give you an example, suppose as a user, so or as a someone who is traveling to the Bangalore city after such a long time. So if I go to the Bangalore city, and if I drink, if I stay in Bangalore city for 1 month and I drink coffee in 30 different places, and if I list down the coffee prices that I paid in each time, so it will be just collection of numbers. So just to let you know, give you the intuition as what I'm trying to say. So let's say on day 1 I've drank a coffee, it costed 20 rupees, and day 2 I've drank 30 rupees, and day 3 I have paid 50 rupees. Likewise, I'll be having 30 different numbers which talks about my coffee prices that I have paid. Now, by simply looking into this column of numbers, it doesn't make sense. So what it would make sense is, if I try to find some average of this 30 data points, I'll be able to say, okay, on an average, I have spent, just to give an example, I've spent close to 40 rupees on a coffee. So calculation in Tableau is very important, which will help me to derive the insights from the data, which cannot be seen by simply looking into the tabular, or it could be in the tabular structure. So once you learn about these calculations in Tableau, you'll be performing an hands-on activity to practice the same. And as a part of module 5, so you'll be learning how you can create advanced visual analytics, and this is followed by a hands-on session. And as a part of your module 6, so you look into LOD expressions in Tableau, which is called as level of detail expressions, and this is followed by another hands-on session. Now, as you can clearly see, so each important topic is followed by the respective hands-on session, and all this will be demonstrated to you by the industry expert. And as a part of module 7, you'll be learning how you can create the geographic visualization in Tableau, and this is followed by an hands-on activity. And as a part of module 8, you'll see how you can perform advanced charts in Tableau, followed by an hands-on session. And module 9 is all about creating the dashboards and representing the data stories, followed by the hands-on session. And this is one of the very important module, guys, that is creation of dashboards and the stories. And at the end, as a part of module 10, so you'll be an industry ready Tableau specialist. And at the end, you'll also be given with a project which will help you to practice and recap on all the topics that you have learned. And that project will be on the same standard that we will be working with the enterprise data. So whether you're joining the course with us or whether you're taking your self-paced learning journey, we recommend you to follow this approach. Now, the benefit of joining with us is you'll have the expert support who will be with you throughout your learning step, who will make sure that you'll not only understand the topic, but you'll understand from his experience as how exactly that will be used in the industry. Now, let's see how we can create our first setup using this Tableau Online. Now, before we actually go ahead and create our first site using this Tableau Online, the step 1 is we have to first plan our site. So this planning plays an important role. The reason because as an organization, I might have the data with me. So while creating the app or while creating the site, it will be like a blank sheet. So I have to first plan it. How does my site would look like, and who are the actual end users, and for what purpose we'll be using those sites. So as a part of step 1, so planning the site is very important. So here you actually need to know where exactly the data will be hosted, because we will be having the data present in various scenarios. I can have in AWS, or I can be I can have my data in GCP, Azure, or it could be from the on-premise database. So it's very important that we understand where exactly the data will be hosted and how will I be setting up the connection, and what will be the latency of data. So what will be the speed in fetching the data, and how exactly the data will be utilized, which means who is going to use this data, and also how will they use it. Will it be used for day-to-day monitoring, or will it be used for real-time monitoring? So these are the important three things that we have to consider before we build any site using Tableau Online. Okay, now once this plan is complete, so we can actually decide, and it will actually give us many advantages. So here, when we are planning the site, so if I come back over here, I have mentioned that one thing that we need to understand is where exactly the data is hosted and who will be using it. So let me do one thing. I'll just open up my Tableau. Okay. Now this has various information. I have created some visualization. Some visualization is not visible, but when I post it to Tableau Online, you'll be able to see the complete visualization. I'll just open up this tourism. So we can clearly see that I have some collection of visualization which I have done with the help of the data source, which is called as word indicators. Now I'll do one thing. I'll come over here and click on my data source. Now the data source which I'm currently using is actually called as word indicators. Now here in this word indicators data source which I'm currently using, I have various columns. So I have the birth rate, I have the business tax rate, I have the carbon CO2 emissions, country, year, and ease of doing, ease of business, energy usage, GDP, health expectancy. So I have the information about various columns for each and every instance. So when I say instance, it actually refers to my individual row. You can clearly see this is the collection of data that I'm having. Now on top, if you look at the connection, so connection, I have two types. One is live connection and the another one is called as extract connection. So here, when I talk about live connection, so my data will be present in my source system. That means where exactly the data will be there. So the data will be fetched in real time, and using the data in real time, I'll be creating the visualization. And that's what happens when we talk about live connection. Now, as I mentioned already, whenever I have this connection set as live, so the speed in which I'll be creating the visualization, or the speed in which I'll be fetching those data, it depends on many things. It depends on what's the server speed, or what's the network speed which I have in my current server when I'm communicating with my third-party system. It could be my AWS Redshift or this Amazon Redshift database. So what's the speed in which I'm able to connect to that Amazon Redshift database? And if I'm fetching some data from there, so what's the data transfer rate that I have? So which means my network speed is going to play an important role over here. Now, along with that, if I have thousands of users who are interacting with my plot or interacting with my site, and if I'm using the live data, it means 1,000 times or 1,000 different users is interacting with the live database that I have, which I have set up. So this is going to cause performance issues when I have more number of users, and definitely not a recommended one if I have more number of users are using it. Now, unless and until we actually require the live data, so we normally prefer to use the batch data. To give you an example of live data, like suppose if I'm dealing with an bank related transaction, if I want to understand as how the transaction is taking place, so in such scenarios, live connection would actually make more sense. The reason because I want to monitor the transaction in real time. So if I'm doing some kind of activity where I don't require the live connection, I just need refresh at every intervals. It could be 1 hour, or it could be 1 day, or it could be few hours. So in such scenarios, we actually make use of the connection that is called as extract. Now here, extract is nothing but we'll create a snapshot of my current existing data and we'll store it somewhere, and we'll use that stored information in order to access the same. So that is called as creation of extract. Now by doing this approach, so one advantage is, so I'll not be worrying much about network connectivity between one server to another server. So because I'll be having the data stored somewhere. Okay, now with the data stored, so there will be very less latency when I'm accessing the data. So to give you an example where exactly that we can use this kind of connection of extract is like whenever we are working with report, just to give you an example. So if I'm worried about as what is the sales at the end of the day, so I'm okay if my data gets refreshed at the end of the day. So I can create the visualization maybe after that particular business day transaction is complete, and then I'll take a snapshot or I'll take an extract, and then I'll go ahead and try to find the insights on the same. So that's one of the example, and to help you differentiate between live connection and the extract method. So as I mentioned, if by using my extract, so I'll be able to work with very large data set with very less latency. And if I'm working with extracts, it will be very fast for me to create the visualization and derive the insight from the data. And obviously, it will help me to improve the performance. And not only that, it will actually provide the offline access to my data because I've already created a snapshot from the given data set with me. So that's the advantage of using my extracts instead of live connection. So once we plan the site, the next step will be building it out. So we'll just have to go ahead and build it. Now, I'll do one thing. I'll show you the steps as how you can create an account with Tableau Online. So in my scenario, I've already created an account with Tableau Online and I have logged in. I'll be showing you once I've logged in. So before that, let me just share you the steps as how you can actually create an account from your end as well. Now, in order to create a trial account, do note that you need to use the business account and you cannot use your personal account over there. So when I say business account, it could be the account email address that you have got from your company which you're working with. Or in case if you're associated with an academia, so if you have an email address from your education institution, you can also use the same. In order to access this Tableau, so I'll do one thing. I'll click on Tableau. I'll just search for Tableau Online, and from here I'll show you. Okay, I'll go to this URL online.tableau.com. Okay, currently it's asking me for login. I'll click on sign up button. All right, so using this link, you can actually create an account with Tableau. See, it says what are the reasons that you have to start with Tableau Online. So you can connect to data sources without leaving the web browser. You can build notebooks and the visualization with web authoring capabilities. You can share interactive dashboards, visualizations, as well as curated data sources with anyone in your organization or in your team. You can seamlessly integrate with Tableau Desktop. So Tableau Desktop is the desktop application which I currently have over here. And I'll show you in a bit as how you can share this visualization that you have created with Tableau Desktop to your Tableau Online. So we can seamlessly integrate the same and we can take the full advantage of the cloud architecture. The best part is it will be taken care by themselves. So they'll handle the hardware as well as the setup. And the best part is, as I mentioned, the data will be secure in the cloud and they have the highest level of security standards, and all the Tableau trial sites includes data management add-on functionality. Now what you can do is to create a free account, just click on start your free trial and fill up this form. Okay, and once you fill up this form, so you'll be getting the access. That means you'll be receiving an email using your email address. Once you click on request free trial, so you'll receive an email, and once you receive the email, just activate your Tableau account and you'll be required to enter your page name and you'll be required to enter your password. And once your account setup is complete, so you just have to use the same URL online.tableau.com and then just log in with your email address and the password. So you just have to specify your email address, click on sign in, and then you'll have to enter the password. And once you are logged in, so you'll be redirected to a home page of Tableau Online. So let me show you how does the home page of Tableau Online would look like. Okay, so this is the home page of the Tableau Online. So I've just created I think yesterday or a few hours back, I don't remember. So this I have logged into my account. So this is the home page that you'll be redirected once you logged in to your Tableau Online. Now here for that page, I have mentioned the page name as My Learning Tableau 666. Now you can mention your own name during the account creation. All right, now this is the home page, and in the home page, let me just give you a quick walk around on this home page of Tableau Online. So here it says, welcome to your Tableau site, and here using Tableau, you can actually harness the power of your data, unleash the potential of your people. So the main focus of Tableau is data and the people who are actually using it. Now you have the options to create new workbook, new project, new flow, new published data source, or you can also create the virtual connection. And if you have your own workbook, you can also upload the same over here using this button of upload workbook. And you have some other links as well. You can upload a workbook, you can manage projects which are already created, you can manage the users who are actually using your website or this Tableau site, and you can download the Tableau desktop if you require, and you can also download the Tableau prep builder. Okay, so this is about the home page. Now on top, you can click over here. Now once I click over here, it is going to display the personal space, my content, my account settings, and what is the start page that I have to use whenever I'm starting out, and I can sign out. So I can click on my content. So this is going to display the contents that are created by me or which have been made accessible to me. So for now, I'll click on home. Okay, now apart from that, here on the left hand side, I have something called as favorites. Now using this favorite, in case if I have set some workbook or something as favorite, so it will appear over here under the favorites, and I can access my recents. So whichever the sheets or data source which I've used earlier, so it would open over here. And in case if someone has shared some assets to me, it could be sheets or it could be data source, so it would appear over here. And if when I click on recommendation, it's going to display the recommendation. I can click over here on the personal space. So this personal space is nothing but the private space where I can create new content and I can explore by myself without sharing to any other users. And here we have something called as collections. So here we can create our own collection, and I can click on explore. And when I click on explore, it actually displays me the top level projects. So currently I have two top level projects. One is default and the another one is called as samples. And if I go inside one of the top level projects, I can see the various files. So this is the data source, this is actually a sheet, and so on. This is actually a flow. Okay, and if I have some external assets, so I can get to know about the external assets that I've currently used over here in my account. And by clicking on users, I can get to know about the other users who are created over here. I can create my user groups. So we'll come to the users and user groups very shortly. And then we have schedules. So in case if I have some setup, or if I want to refresh some data, or if I want to fetch the data, so I can set the schedule, I can see the jobs, okay, and I can look at the task, and I can look at the health of my site by looking into my site status, and I can click the settings over here in case if I want to set up my own settings over here. Okay, so this is about quick walkthrough on this Tableau online website. Okay, so now that we have understood as how we can log in and create an account, now let me do one thing. So here on my Tableau desktop, I have this workbook which I have already created. Now if I want to share this workbook to my Tableau online page, so it's very simple. I can just click on this share button. Now by clicking on the share button, so it is going to ask me what is the server that I want to use. So here I have two options. One is Tableau Online and the another one is Quick Connect. Now in case the Quick Connect is selected and not the Tableau Online, just you can do one thing, just click on this Tableau Online button. Okay, so this is going to set the Tableau Online, and it will ask you to sign in with your Tableau online account. So let me just do the sign in from my end. So I'll just specify the email address which I've got. So once I log into my Tableau online account, so it's going to give me a pop-up and it asks me as where exactly that I have to publish this particular workbook. Okay, so currently it's asking me to select a project. Let me do one thing. I'll select the project as samples this time. And for the name, I'll specify it as word indicators example demo. And I can specify the description. I can say this is a Tableau online demo for word indicators data source. Okay, so this is about the description. Now here I can add tags. Now tags will help me to identify my workbook, and which will actually help me to sort it, or if I want to do the filtering at a later point. Now when we are starting, at least when I'm adding this, I do not have much projects with me, but as I increase the number of users, so as more and more number of users start using our site and they start to create their own visualization to talk about the data stories, it will become very complex. And if I want to search for something, so it will be difficult to simply explore each and every notebook that we have. So the best practice that we follow is we are going to create the tags. So using the tags, we can actually access the required one. So I can create some tags. I'll just say it as GDP. I think that tag has been already, yeah, I can add a tag as GDP. I can add the tag as tourism. I'll add a tag as economy. So in this way, I can create the tags. And here I can mention how many number of sheets that I want to add. So by default, I have selected all the sheets. Now in case if I want to publish only selected sheets from the workbook, so I can do the same. So I can click on edit. So if I hover my mouse over here, you can clearly see that it actually gives me the visualization about each and every sheet. So which in turn helps me to save time. So I can just hover my mouse. Okay, I can understand. Okay, this is the sheet which I'm talking about. So let me add it. Or if I don't want, I can uncheck this. So in this way, we can actually select the sheets. And coming to the permission. So permission means I can mention, okay, which user has which access. So that's actually called as permission. Now by default, here the permission is set as same as project. So whatever the project has, this project has, the sample project has, the same permission will be given for the existing users as well for this new workbook which I'm trying to upload for my Tableau online. Now for the data source, so I'll be using the data source which is embedded in this current workbook. That means the word indicators data source which I've shown you earlier. So the same data source will be used over here while uploading or while sharing with my Tableau online. And here I have the more options where I can select whether I want to show the sheets as various tabs, whether I should show the selection, whether I should include my external files as well. So I can do all these selections. And once it's complete, I can click on this publish button. Okay, so this would take a while for publishing to complete. Now, once the publishing is complete, we can go to the Tableau online to validate whether whatever the worksheet that I have shared from my Tableau desktop, whether is it visible in my Tableau online. So normally what happens is once the publishing is complete, it would automatically launch my browser. So if you look at it, it has automatically launched my browser and it says publishing complete and the name is word indicators example demo. And here I can share this workbook with the other colleagues of mine in my organization, or I can preview different design layouts. For now, I'll just click on close button so that I can view my worksheets. You can clearly see I have various worksheets that I have just imported, and the owner is 𝐂𝐝𝐿 and I have just modified a minute ago. So I have modified at 8:51 p.m., which is just a minute ago. So I have various things I have views, I have data sources. So data source is the same data source which I've used earlier. Okay, and so I have various data sources. I like this. I have connected metrics. If I've connected something, or if I've built any custom views, it would show. If I have any subscription, it will show. And if there is any lineage in the data, so it would show over here under the lineage. Now under the views, so it displays each and every sheet that I had over there. So in this way, I can build my own page using this Tableau desktop itself. It's very simple. I can create my workbook using Tableau and Tableau desktop, and I can just share it with my Tableau online. Okay, now this is about building the site. Now the next thing is adding the user. So obviously while working out, so like it's not a one-man game, or it's not a few people using this Tableau software and creating the visualization. So the main purpose is to enable the data as well as the people to unleash their highest potential possible, which means we need to add multiple users of our organization. They could belong to multiple groups. When I say groups, they could belong to multiple departments, multiple job roles, and we'll be enabling everyone to use the enterprise data so that they can derive the insight from it, which will help them to take the action on the basis of data. So which means we'll be adding multiple users. Now to add the users, you can click over here, the users, and you can add the various users. Now if you want to add the user, you can click on add user, and there are various options to add the user. One is you can add the users by user using their email address, and the another way is you can import from the file. So while importing from the file, you can actually create a file which contains multiple users. So this will help you to create multiple users in a single go. Okay, so for the demonstration purpose, I'm going to add users by email. Now here I can set up the authentication, so whether I need multi-factor authentication or not, and so on. So I can just add the users whether it's Tableau with multi-factor authentication, and here I have to mention my email addresses of the various users. So I can specify something like this. I'll say demo1 at example.com. Okay, and here I can select the site role. Now when we are talking about this site role, so we have various roles that are available whenever we are working with Tableau. So if I click on site role, so under the creator, we have site administrator creator and a creator. So here when I talk about site administrator creator under the creator, so this is one of the highest level of access for Tableau online. So the person who is having the site administrator creator access, he'll have the unrestricted access to the content whenever we are working in this Tableau online. So uh, if I want to name a person who is above everything, so that person is actually called as server administrator. So this server administrator is actually present for Tableau server. So when I talk about Tableau server, it actually gives the highest license activated, and it allows the unrestricted access for the configuration settings of Tableau server, browser environment, all sites on the server, users and groups, and all the creative assets that we'll have. So for everyone, we'll have the server administrator as the highest access. So that means server administrator has all the access, and the similar access will be provided to my site administrator creator, and this is applicable for Tableau online. Okay, and we also have something called as creator. So here in this creator, so whenever the user has been assigned to this role of creator, it allows new features. That means this site role, it actually offers non-administrators the maximum level of content access. So if I want to name few actions, so they can connect to Tableau or external data in the browser, they can build and publish flows, they can access the data sources, and they can workbook along with that workbook, and they'll also have access to dashboard status as well. and use the interaction features on the published views. Not only that, when I talk about this creator, so they'll also connect to the data from Tableau Prep or Tableau Desktop, and they can publish, or like when I say publish, they can actually upload or save and download the flows, and they can also work with workbooks as well as the data sources. Now, this is about the roles under creator. So site administrator creator and the creator. And under the explorer, so we have something called as site administrator explorer. So under this, so it has the same access that as we have seen for site administrator creator. So one difference is they can't connect to the external data from the web editing environment. So that's the difference between Site Administrator Explorer and the Site Administrator Creator. And this Site Administrator Explorer can connect to Tableau, they can connect to Tableau published data sources to create new workbooks and edit and saving the existing workbooks. So likewise, we have something called as Explorer, and under the viewer, we have only one role that's called as viewer. So this viewer can see the published views which others have created and use most interaction features, and he can subscribe to views, and he can download the various views as images and whatever the summaries that has been created. So they can also download the same, but they cannot connect to the data, they cannot create the data, or they cannot even edit or publish a content. Okay, so it's a very limited role. So this is the kind of role that we'll be giving to the end users. Okay, so this is about various site roles that we can assign to my individual users. Now, whenever we are working with the organization, so as I mentioned, we'll have most number of users using the content or the data that we have. So which means my individual department has multiple employees. Just to give you an example, my account department has 10 employees and my data analyst group has 15 employees and so on. So each user, the permission or the access that I'll give for each and every user in the department will mostly be the same. Now, to help us in assigning the permissions, so what we can do is we can actually create the user groups and assign various users for the users, and I can create it as a group. And while giving the permission, I can give it at the group level itself, which will help me to manage my permission in an effective manner. So this is about creating the users, and then we can set the permission. So while setting up the permission, so it's always takes in this format. So we'll actually evaluate the permission. So first we'll see whether the capability which we are looking at, whether it is outside the scope of that site role. If it is yes, obviously it will be denied. If no, then I'll be evaluating the role specific or the user specific permission. So whether he's the admin or project leader, if yes, allowed, and so on. So in this way, we'll be evaluating the various permissions. And we can plug in the data. Now, when I talk about plugging in the data, it's about the data source. So we can plug in the data by creating cloud connection, dashboard starter, as well as Tableau bridge. And we'll also have the monitoring and looking at the performance. So monitoring means understanding how the various users are using and what are the sheets that are mostly used and which are the permissions which are actually not required but I have added to them. So those comes under the topic of monitoring the site. And under the step 7, we'll look into increasing the performance. So one thing is like cleaning the data that we have, and instead of using the live connection, wherever possible using the extracts, and pay attention to the site design to make sure that the data and the site that we are working with, it's clutter free. So by doing all these things, we'll be improving the performance, and once we have achieved an optimal performance, we can also look for tuning those performance as well. And coming to the authentication, so Tableau supports various ways of authentication. So we can make use of Tableau authentication, Google, or SSO based authentication.
So now let's go ahead and understand why do we need Tableau dashboards. So suppose our manager wants to see the profit performance of the company. So as an analyst, what can you do? You'll be provided with the raw data. Now you'll have to analyze the raw data and come up with visualizations, which you can show it to your team or your manager and get insights from them. So basically, we need a dashboard to have an overview of the company's data and performance. Now, dashboards can be used to help business managers make informed decisions that dramatically impact business performance. Now, let us understand what are Tableau dashboards. A dashboard is a collection of several views letting you compare a variety of data simultaneously. For example, if you have a set of views that you review every day, you can create a dashboard that displays all the views at once, rather than navigate to separate worksheets. But now if you're getting confused between dashboards and worksheets, like what are dashboards and what are worksheets, then let me break that for you. So let's quickly discuss the difference between Tableau worksheets and Tableau dashboards. So Tableau worksheet contains a single view along with shells, cards, legends, and the data and analytics panes in its sidebar. While a Tableau dashboard is a collection of views from multiple worksheets, and in its sidebar, you will find the dashboard and the layout. So worksheet is where you build views of your data by dragging and dropping fields onto shelves, while a dashboard is a combination of several views that can arrange for presentation or to monitor. Now coming to how to access worksheet and dashboard separately. So the steps have been clarified in these points. So like for creating a new worksheet, we have to go to worksheet, select new worksheet, or we can right click and open any tab in the workbook and select new worksheet from the menu. Or we can choose from the drop down menu of new worksheet and select new worksheet. Or the shortest way to make a new worksheet would be to press Ctrl M on your keyboard. While for creating a dashboard, you have to go to dashboard and select new dashboard. Or you can click the new dashboard button at the bottom of your workbook. Or you can also right click on any tab in your workbook and select new dashboard from the menu. And like creating a new worksheet, you can also click the drop down arrow from the new worksheet button and select new dashboard. So now let us quickly discuss a few tips before creating our first dashboard. So before we get started with our dashboard, you should know a few points. Like you should be creatively inspired, like you should have a mind like an artist and take inspiration from as many places as you can see and reflect that in your visualization. Next point would be to know your audience correctly. So it's very important to understand your audience and who you're making the dashboard for in order to get the right visualizations. Third point would be to get relevant data sets. So we might have to choose from a vast range of data and understand our data properly and analyze it in order to get it in our visualization. So for that, we need relevant data sets for making our dashboard more presentable. And lastly would be choose right analysis and right charts. So it is very important to choose the right analysis and right charts in your visualization for creating an impact in the data visualization. So next, let us discuss the steps to create a dashboard. So to begin with, the first step would be to import our data. So you have to select the data source from where you will import your data. Next, you will have to create a new worksheet where you will start your visualization with graphs and bars. Then you'll have to add more worksheets in order to make a dashboard out of it. Fourth point would be to add all these worksheets on the dashboard and add more interactions like filters, slicers, and actions in order to make the dashboard more interactive. And the next step would be to view the dashboard. And the final would be to share the dashboard across the stakeholders and the company's manager. So without any further delay, let's get started with our hands-on in Tableau. So this is how Tableau Public looks. To get started with, first we have to import our data. So we'll import a text file, Global Superstore Data, open it in Tableau. So now our data has been imported. As you can see, we have the column headers here where we have the order details, the customer details, the region details, and the product details. And we also have measures like profit, sales, quantity, shipping cost, and all of this. So now we go to worksheet. So here let's name our worksheet as region-wise profit. So here we get the labeled view. Now for region-wise profit, we'll have to drag region that we have in here to rows and profit in columns. So this is how our visualization looks. This is a horizontal bar chart which shows sum of profit on the x-axis while the name of the regions in the y-axis. So we can also add labels to these bars. For that we need to drag profit to label. Here we can see the labeled bars now. And we can also add color to this. If we drag profit to colors, then the color changes. So this is how our region-wise profit looks. Now the central region has the highest profit, so it's like dark brown, while the lightest shade of blue is indicating the lowest profit. So this is a region-wise profit where we have the region-wise values of profit in a horizontal bar chart. So if we want to see the state-wise profit, but in a geographical view. So for that we have to drag state to views, and we can drag profit from measures to the view. So this is how it looks like. The sizes of these circles tell us how much profit has been made. But for a better view, we can add colors to these. So for that, we'll have to drag profit to colors and profit to label. So from here, we can change it to colors. Now in this graph, the ones with orange shows loss, while the ones with blue shows profit. These colors also we can change by clicking color, then go to edit colors. Then from here, we can select red and green, where red will signify loss and green will signify growth. That is profit. So the countries which are red in color have loss, while the countries which are green in color have more profit. So this is a state-wise profit view in a geographical map. So on this visualization, if you select any state, it will show you the state-wise profit. So now we have the region-wise profit in a vertical bar chart, a state-wise profit in a geographical map. Now let us make another worksheet which will have the category-wise profit. So for this, we'll drag category from the tables to rows, and we'll add profit in columns. So this is a horizontal bar chart, but now if we want to make it to vertical bar chart, we can just swap and make it into a vertical bar chart. Now this shows us the category wise profit. Now if we want to add subcategories to these categories, then we can add subcategories in the column section. Now let us arrange it in ascending order. Here we can see which categories and subcategories have the highest profit and negative profit. And we can compare it with which one has the highest and which one has the lowest. Here also we can add colors to it by dragging profit to colors. The ones with less profit are lighter in shade, while the ones with more profit are darker in shade. And the one which is loss, that is negative profit, is marked in orange. So here also you can add labels to the columns, but this looks a little clumsy to me, so I'll rather let it be. So these are the three views that we have gotten. One is the region-wise, state-wise, and one is category-wise. Now let's make a dashboard with these three visualizations. So for making a new dashboard, one option could be go to dashboard, make a new dashboard, or we can also come here and select on this and get a new dashboard. We have this on the left pane, that is the dashboard, the layout, and the sheets that we have already created. While in a worksheet, we have data analytics and the table names and measure names. So that's the difference between a worksheet and a dashboard. So here in the dashboard, first we'll have to choose what size to select. So this is a very important step as it decides how it will be viewed in the front end. So here we have this option as default phone or default. So we are going to choose default because we are not going to visualize in phone. And then this is the size of the dashboard. This is the default size that is there. I can fix the size as well, or I can make it automatic. So I'll make it automatic. So it extends, like size of the dashboard is going to adjust with the visualization. So if we are making tiled, then our worksheets are going to be in tiles. Like we add this, these are getting added in tiles. Now if we make it floating, then we can just drag it and size it according to how we want it. Like there's no fixed. So I prefer using tiled because it gets arranged on its own and fits in the dashboard perfectly. So first we'll name the dashboard as profit performance. So to start with making the dashboard, we have to drag our visualization. Let's make it to tiled as that I find easy to work with. So we'll drag region-wise profit, then we'll drag the state-wise profit, and the last one category-wise profit. So now this is our dashboard. So in this dashboard, you can add filters for individual visualization. Like if we select this filter, then if we select central, it's going to show me the data for central for all the other visualizations. And we can also add filters and slices, like we click on this drop down and we choose filters. Now we can choose what kind of filters do we want. Do you want region-wise filters or sum of profit? I'll add region-wise. So here you can see the region-wise filter. So now from here also you can choose what kind of slicer you want. So you select on this visualization, you select on this drop down. Then you can see multiple values from list, multiple values from drop down. I'll choose multiple values from drop down. So here if you select, then you can select all, or you can select just one, or you can select two, and the visualization is going to change for just region-wise profit. So now we can similarly add filters for all the other visualization. Like from category-wise profit, we can add categories in the filter section. So here we go to filters, we select category. Then the categories got added. So we'll keep it as a list because it's a small list anyway. So if you want to select furniture, then it shows just for furniture like that. And similarly, if you want to visualize a state-wise filter, then from this state-wise profit worksheet, we can go to filters, select state, and you'll get the name of all the states. So here the visualization is that I have to type the name of the state. I'll rather change it to multiple values drop down. So where you can select all or just search which state you want and then select the state. So this was a basic dashboard. You can play around in a dashboard using your creative skills, analytical skills, where you can add more visualizations or more charts like a pie chart or a waterfall chart, and use actions between the worksheets to notice changes across every visualization. And there's a lot of things that you can do in Tableau. This was a basic dashboard that was discussed in today's session, but we'll have more content on Tableau dashboards where you'll get to learn more about making advanced Tableau dashboards.
Now Tableau generates some fields which can be visible in the data pane. Now these fields are generated in addition to the fields that are present in the data set. Now the generated fields are measure names, measure values, the number of records, and latitude and longitude. Now, measure names and measure values are two fields created in Tableau by default. Now these fields are created when a data set is imported into Tableau. So you can go into the data pane of the worksheet and view the fields, as I'm going to show you in a little while. A measure name consists of all names of a measure present in a data set and is always present at the end of the dimension. Whereas all the measure values present in a data set are kept together in the field called measure values, and it is also always present at the end of the measures list. It consists of all continuous values of all measures. And if we talk about number of records, for those of you who have worked with Excel sheets and Power BI before, your number of records is basically like a count variable. It shows the count of records present in a data set. It is also an auto-generated field in Tableau which assigns the value of 1 for each record present in the data set. It can be used to verify the count of records when joining multiple tables as well. Apart from that, we have the latitude and longitude, which are basically associated with geographical detail present in a data. A data set should consist of geographical details like city, country, or state for this particular generated field to be used. Alright, so let's see how we can use them.
Now I'm going to be opening a new sheet in Tableau. Alright, so let's see how measure names and measure values work first. So I'm going to pick up the highlighter to show you where you can find these. So here I have my highlighter. So here at the dimensions shelf you can find the measure names, and here at the measures shelf you can find the measure values. Alright. Now in the first case we're going to be using measure names and measure values, which can be used to see the aggregation of all measures present in a dataset. Now these fields can be shown as different types of visualization in Tableau as well. So what we're going to do first is we're going to drag the measure names into the columns and drag the measure values into the rows. Alright. Now if we turn the marks shelf into automatic, Tableau automatically gives us a bar chart, and if not, you can go into the marks card and select a bar chart. Now this visual is created for all measures present in the dataset. As you can see, we have discount, number of records, profit, profit ratio, quantity, and sales. Same thing we can see here. Alright, here we can see all the measure names and measure values. Moving on. Now you can do a bunch of things with this particular measure. For example, if you suppose want to delete a measure value, you have the option right here. I don't want to delete any. And also you can create an alias for measure names. It can be shown in the visualization for better identification. So if we go to measure names, there's an option known as edit alias. I'm going to select that. And in this example, I'm going to give the quantity volume sales and then click on OK. And as you can see, the name has changed right here in your graph. And these are just a few basic things that you can do with this. If you want to analyze multiple measures in a single visual, this can also be done using measure names and measure values. Alright, with that, let's go to our other generated fields. I'm going to create a new sheet for this, new worksheet, and we're going to talk about the number of records. So again, for this, I'm going to drag the number of records from the measures pane up to rows, and this basically gives us the number of records, which is 9994. Pretty basic. There's nothing much you can do about it. But when we are going to aggregate on the bigger numbers in the bigger data set, this is something which will be very useful to us. Alright, let's add another sheet and we're going to see how we can use the latitude and the longitude. Now, as I had mentioned before, these fields are associated with geographical detail present in the data. So you should have something like a city, country, or state in your data set so that you can use them. Now, unlike other BI tools like Power BI, where sometimes you have to mention that a latitude or longitude is in fact geographical data, here Tableau is smart enough to auto-generate these measures. So I'm going to take the latitude here and the longitude here. Okay, let's just switch it up. Let's put the latitude here and the longitude here. And you can already see a map appearing. Our second step will be to drag the state from the dimensions and put it on this detail present in the marks card list. And this creates a geomapping visual, as you can see on your screens right now. You do not have to select any visualizations. Just by dragging and dropping your latitude and longitudes, Tableau is smart enough to understand that it has to create a map. Now that was all about generated fields. With that, let's move on to understanding how and when to build different types of visuals. Now Tableau is known to create interactive visuals for easy data interpretation. So you can create various types of graphs in Tableau based on the purpose. Now the different charts that can be created using Tableau and their specific purposes is something that I'm going to show in the next segment of this session. So we're going to start with the bar chart. Let's go back to our Tableau desktop, create a new sheet for this and name it bar chart. Pretty basic. Now this is one of the very basic charts. All you have to do is take something on your x-axis and take something on your y-axis. And by default, it is going to be made into a bar chart using Tableau. So I'm going to take category of product in my columns, and I'm going to take, say, the profit into the rows. And as you can see, the automatic feature
will turn it into a bar graph. And if it doesn't, you can just go to the marks card and select bar graph. All right. The next basic chart we're going to see is the line chart. Again, I'm going to name this sheet. It's always good to be organized because in the end, we are going to use BI tools for organization and analytics, right? So here's my line chart. So a line chart basically is used to compare the data over different periods. A line chart is created by basically connecting a series of dots. Now these dots represent the measured value in each specific period. So again, this is pretty simple. I'm going to take the order date as I just mentioned. It shows data for a fixed period of time. So I'm going to take the order date in the columns and I'll be taking sales this time as my measure, and it automatically creates a line graph. Now Tableau is smart enough to figure out what kind of graph would you need for certain data, but even if it does not, you can always go into the marks card and select the kind of graph you want. Next is a kind of complicated graph, which is the Pareto chart. This is basically a combination of both the charts that I just showed. So Pareto chart consists of both bar and line graph. The same measure is used to create the graphs, but the measure values are manipulated differently. Now, the purpose of using a Pareto chart in Tableau is to identify the contribution of members that are present in a particular field. For example, the profit contributed by different subcategories of a product in a retail store can be analyzed using a Pareto chart. It can be used to show the top members and their contribution as well. So let's try doing that. I am going to be taking the subcategory of products, putting it in my columns. Then I'm going to take profit and put in my rows. Now stay with me because this is kind of a longer process than the other graphs, but it's pretty useful, I assure you. Now I'm going to right click the subcategory and select the sort option. It is going to open this sort of a window. I'm going to select the descending order and then I'm going to go to the fields and my field name is profit, aggregation sum. Okay. Then I am going to drag the profit measure again into the rows. It's going to create two separate graphs like this. But if I right click here, you can see an option called dual axis. I'm going to select this and it's going to turn this into circles. It's basically merged the x-axis of both the measures and has converted it into the visualization that you can see right now. Now, next, you have to go to the marks card and select sum profit. And as the drop down appears, I'm going to select bar here and I'm going to go for the color a lighter blue. Okay. Now I'm going to the other profit and I'm going to select the line graph here and I'm going to go for the color orange. Okay, maybe a darker orange. All right, this looks better. Now I'm going to select the sum of profit and the second one right here. And I'm going to right click here and choose add table calculation from the list. Now it opens this primary calculation type of a window. I'm going to select running total from the calculation type because that's what we want, right? We want a running total. And then select sum as the aggregation, which is already selected, and compute using table across. All right. Now I'm going to add a secondary calculation, and this is for our second graph. And here I'm going to select percent of total. All right, table across as we have done before. Now I'm going to be closing this window. As you can see, the line graph has changed and it's not on top of the bar graph anymore. That is because we have separate primary and secondary calculations. The line graph here is showing us the total running sum of profit as we had calculated and as you can see here. And now you can basically select and change colors that you want to make the graph look as you like. I'm going to keep it as it is. And this is the procedure to create a Pareto chart in Tableau. Next in our list, we have a bullet chart. I'm going to rename it. Now, a bullet chart can be used as a gauge or an indicator to show the performance of measures. Now, two measures can be compared to each other using the bullet chart. For example, if we are having to estimate say actual profit versus estimated profit, we can compare both of them using the bullet chart. Now this is going to be slightly different from the 3 charts that I showed before. Here we're going to start with the analysis option present in the menu bar. Alright, select create calculated fields. It opens this sort of a field window, and I'm going to just name it as estimated profit. We're going to type an estimated value. In this example, the profit is taken as the measure, so the calculated field is created for estimated profit. So I'm just going to type in a number. Let's just keep a 300,000. Now the good part about Tableau is that till your expression is valid, it is not going to let you apply the changes you have made in a calculated field, which is great for beginners because then you will know exactly where you have gone wrong. For example, if I remove this, you can see the field shows that the calculation contains errors. Not just that, it will even show you the syntax of what your expression should be. So here when I type a number, it shows that my calculation is valid and I can apply this, and there you are. Now go to the measures in the data pane, and you have to hold the control key on the keyboard because you have to select 2 different measures. So estimated profit and profit. Now click on this option called Show Me, which will show you the various graphs that you can apply here. Top right corner, this is the option. This is the option I'm talking about. And you can see the bullet chart option also being highlighted, which means we can use this particular option for the measures that we have input. So I'm going to select this and you have your bullet chart. Next in our list, we have text tables. So let's just add another sheet. Going to a new worksheet, going to do the same thing. So a lot of this is going to be dragging dimensions and measures and dropping them into columns and rows. Don't mind me not repeating it again and again. So after we've gotten a table like this, I'm going to drag this profit into the text box present in the marks card. And here you have it. It creates a text table by default. Next up, we have a heat map. Now this is basically a graph which can visualize the data in the form of size as well as colors on different measures. Now 2 different measures can be visualized simultaneously using a heat map. So one measure can be assigned to size, whereas another measure can be assigned to the color of the heat map. So let's go ahead and create one. Now again, I'm going to be holding the control key on the keyboard and select subcategory and sales from the data pane. So let me just select these 2. I'm going to go back to the Show Me button on the top right corner of the worksheet and select the heat map. And it's going to look something like this. It does not have any color now. I'm going to take this profit measure and drag and drop it in the color. And now I'm going to drag, let's say, region. Where did the region go? Yeah, all right. I'm going to drag the region and put it in the columns. And now this has created a heat map which can be used to visualize sales and profit across different dimensions in different regions. Next, I'm going to show you how to make a waterfall chart, which is also one of those charts which requires a little more work than the others. So let's see how it's made. Oh my god, we've got like 13 sheets right here. Let's rename this. All right. Now, waterfall chart is a chart that visualizes the cumulative effect of a measure over a dimension. It basically shows the contribution of growth or decline by each member of a dimension. Now, let's take for example, you can see the contribution of profit by each subcategory by using a waterfall chart. All right, so we'll start by making a basic bar chart. So we go to a new worksheet. What we had done for the bar chart thing, take the subcategory, put it in the columns, take profit and put it in the rows. By default, it creates a bar chart, as I had mentioned earlier in this session. Now I'm going to right click on the profit present in the measures pane. And I'm going to choose create and then go to the calculated field option, which opens up a window like this. Now you're going to take this and do exactly what I'm doing. So I'm going to name this negative of profit and I'm going to put a negative sign right here. I'm going to apply this. Now we're going to use this newly created calculated field negative of profit into the size option present in the marks card. Let's just drag and drop it. Now it shall give you a graph like this, after which you need to click on this sum of profit present in the rows and select quick table calculation and take a running total option. Now the reason why we are taking this negative ad hoc calculation is to fill in the gaps in our bars when we are going to turn it into a Gantt chart. So basically we're going to turn it into a Gantt chart right now in the marks card. And now this will create a waterfall chart as you can see on your screens. Now talking about the Gantt chart, let's see how we can create a separate Gantt chart. Now a Gantt chart is the one which shows comparison between data in different categories. So it's basically used to identify the time taken for each process. So let's try to make one. Now we're going to take the drop down button in the marks card and select Gantt bar from the list. Now we're going to drag order date and put it in our columns and then right click on it and select day. Now let's click on analysis on the menu bar and create calculated field like we had done earlier in the session. I'm sure all of you might be familiar with this window right here. We're going to type time for shipment and we're going to use this formula called date difference. Now as most of you might have noticed before, it shows the syntax right here. We're going to put in a date part, a start date, an end date and start of the week. So I'm going to put the date part as day in single quotes, comma, in square brackets, order date, which is a dimension, so it appears automatically. Next, I'm going to have ship date. Now the last start of the week you may or may not put because now that is an optional part of the syntax, so I'm going to choose to not put it and I'm going to apply it as is. Now I'm going to drag this time for shipment into the size part and I'm going to take ship mode and put it up in rows. And now this has created a Gantt chart. It shows the time taken for each shipment across different ship modes. Alright, now let's go back to something a little more old school, presenting the pie chart. Now a pie chart is something, as most of you might be knowing, it basically shows segment-wise data. It can show the contribution of measure over different members in a dimension, and the angle of the pie determines the measured value. And basically it's one of the most colorful charts. Different colors can be assigned to the pie to represent different members in a dimension. Now we're going to do this on a fresh worksheet. Not going to spend too much time here. We're going to just select segment and sales from the data pane and then go to the show me button and select the pie chart. And there you have it. Pretty simple. Let's move on to another very useful chart, which is a scatter plot. Now the relationship between two measures can be visualized using this particular plot. A scatter plot is designed by adding measures in both x and y axes. This basically shows the trend or the relationship between the measures that you select. Now we're going to try doing that. We're going to drag discount into columns. Here's the discount, put it in the columns. And we'll take sales and put it in the rows. Now this basically creates a scatter plot by default, as you can see. Now I'll be taking the subcategory into the color icon and dropping it right there. Now this basically has created a scatter plot showing the relationship between the discount and the sales for each subcategory. As you can see, multiple bubbles. With that, let's move on to the area chart. Now an area chart can represent any quantitative data over a different period of time. It's basically like a line graph where the area between the line and the axes is generally filled with color. Now we're going to hold the control key in the keyboard and select order date and quantity. Next, we're going to click on the show me bar right here and select the area chart icon. Now we're going to drag the region from the dimensions pane so that you can add it in the color icon here in the area tab. And this creates an area chart, as you can see. Pretty simple. With that, let's move on to another very basic chart called a dual axis chart. It's basically a chart which can be used to visualize two different measures in two different chart types.
A date column and two measures are kind of a basic necessity to build a dual axis chart. The different scales in this chart help the user to understand both measures. So again, I'm going to hold on to the control key and select order, date, sales, and quantity. So order, date, sales, and quantity. In the Show Me tab, I'm going to select the dual combination. And this creates a dual axis chart, as you can see. It's pretty simple. Now you can change the color, do anything you want with this chart. Me personally, I would like to keep it as is. I think blue and orange create a very good contrast, which makes your data visible and clear. Next, and the penultimate chart I'm going to talk about is the bubble chart. Now, a bubble chart visualizes the measures and dimensions in the form of bubbles. It's kind of like the scatter plot, but it contributes to a more effective visualization. It's as simple as that. All I had to do is click on the packed bubbles option, and it has created a bubble chart, as you can see. And finally, we have a very important chart, but also a very basic chart, which is a histogram. Now, a histogram shows the values present in a measure and its frequency. It basically shows the distribution of numerical data. As it shows both frequency and measure value by default, it can be used in many cases. For example, if you want to analyze the discount given by a retail shop, you can visualize the amount of discount and its frequency using a histogram. So we're going to go to a new worksheet, select discount from the measures and click on Show Me. And this is the histogram option. And this is our histogram. It was as simple as that. With that, I've come to the end of all the charts that I had to show. Let's move on to the features of Tableau. Now, as discussed before, Tableau is one of the most comprehensive business intelligence tools in the market right now. Since its inception, it has already witnessed a steady growth and has gained a wide market share in the BI and analytics space. So it's clearly one of the top choices in the BI space. So let's talk about a few features which has made it gain its wide market share in BI and analytics space. So first of all, it's amazing data visualization. Tableau BI is known to offer the most advanced data visualization options and is definitely a market leader. The users can easily perform complex data visualizations by using the drag and drop feature, and it has a slick interface which is both intuitive and fast for creating customized visualization. It is easy for any business user to create customized dashboards using the complex data and sources, which makes Tableau a preferred choice for business users. We have quality customer support, and since Tableau is a fast-growing company with very high customer retention ratio, most of Tableau BI users are satisfied with the product and the technical support provided. According to a survey conducted by Gartner, Tableau is ranked amongst the best BI tool with respect to customer satisfaction. Next up, and very important, it is very easy to implement. Tableau, though rich in features, is easy to deploy and upgrade. As per a survey conducted, more than 90% of Tableau users have the latest version installed, and running it clearly indicates the ease of use and upgrade. Next, we have data source integration. Now, Tableau offers a simple out-of-the-box solution for integrating with the most popular data sources and analytics languages like R and Python. They're also constantly adding support for new data sources as and when the need emerges. It also supports Hadoop and Google BigQuery API for robust data analytics. Next, let's talk a little bit about its excellent mobile support. Tableau has clearly understood the requirements of mobile users and has developed a robust mobile app which has a very rich user interface. It is a challenging task to showcase complex graphs and visualizations on a small mobile screen, but Tableau has mastered this art, and the visualizations adjust itself based on the screen size of the device which is being used. And finally, let's talk about the rich online resources and community. Now, Tableau has got an active and engaging user community which will help the fellow users to learn and master Tableau. Now, the community is so huge and is so always buzzing with ideas and solutions that it has a vast vendor base who also offer installation and customization services.
So what exactly is a parameter in Tableau? Think about it like this. What if you need a component for your visualization that is not exactly in your dataset? Parameters in Tableau will allow you to provide that value which you're going to pass to Tableau. Now, this particular feature will allow you to use aggregated values that aren't readily available in your dataset. It will help you incorporate these values into your dashboards and reports directly. Now, after creation, end users can control the input to see the results of the effect of the parameter. Easy, isn't it? So what exactly is a parameter? Now, any value that is passed to your program in order to customize it for a specific purpose is called a parameter. Now, it could be anything, say a string of text, a range of values, or any amount in rupees or dollars, just to name a few. Parameters will help you experiment with some what-if scenarios. Suppose you are unsure which fields to include in your view and which layout to not. What layout would work best with your viewers, giving them the choice. You can incorporate parameters into your views, your charts, your graphs, and your calculations to let your viewers choose how they want to look at your data. Now, when you use parameters, it is of utmost importance that you need to tie them to the view in some way. One way to do this is via calculations. You can use calculated fields which are incorporated in your visualizations in Tableau. Second, you can display the parameter control in the view for your users to select from the parameter. Now, finally, you can reference parameters in parameter actions, which basically means you can use them in your graphs and see the effect it has on your data. So now that you know a little bit about what parameters are, just theoretically knowing about this concept wouldn't obviously do you much good. So in the next few segments, I shall carefully guide you through the process of creating and using these parameters in Tableau. From this point onwards, we are mostly going to be on our demo machine, which is Tableau Desktop. So let's get started. So when you open your Tableau, it kind of looks like what you're seeing on my screen right now. What I'm going to do is I'm going to connect to the sample superstore that is already provided by Tableau. Now, why I'm doing this is so that you guys do not have a difficulty in finding the dataset that I'm using. You can directly go connect here and follow along. Now, this is what my dataset looks like. I have the sample superstore, which is basically a collection of many stores spread across the United States. It gives you the country, city, and state, the customer name, your shipping details, your order details, your categories and subcategories of your products, basically all your sale information, sales, discounts, profits, profit ratio, so on and so forth. This is what your data looks like. Now let's move on to our sheet. So by no means am I going to give you like a full beginning with Tableau tutorial. We already have a few of those kind, and we have one coming up pretty soon, an updated one. So you can go ahead and look at that in our playlist. So basically what I'm going to start out doing is I'm going to create a basic graph. So let's see, I want to create a sales according to the order date sort of a graph. It's going to be a line graph. So I'm going to put the order date in my columns, and there's a measure called sales that I'm going to put on my rows shelf. It gives me a graph like this, but this isn't very informative as we just have 4 years. Now I want a more elaborate graph, so I'm going to go ahead and click on this pill which says year. I'm going to go to the options, select more, and then go to custom. Okay, now this is the custom date dialog box. As you can see, it only has the option year selected. I'm going to go down and I'm going to go select month/year. So it's going to show me all the months through these 4 years. All right. So now, as you can see, we have all the months from 2015 through 2018. We have a much more elaborate graph, something more to work with. You shall basically end up with a graph along the lines of this. It should look something like this. Now we are going to be creating a parameter in Tableau. So basically, the scenario I am trying to create is a what if scenario, like I had mentioned before. So I'm going to say, for example, what if the sales has been hiked up by 3%? Now, this detail is not given readily to me in my data set. So I obviously have to create a parameter for it. So basically, this is a parameter which I'm going to be using in a calculated field. To create a calculated field, you go to Analysis and create calculated field, or alternatively, you could also go to this down arrow key near dimensions, and the first option you get is a calculated field. Now, before we make the calculated field, let us create the parameter that we are going to be using in the calculated field. So the second option from that was create parameter. So I have my dialog box. So I'm going to go ahead and name this like if, because it's an if scenario, if sales parameter. I'm going to move the data type to integer from the drop down menu. Current value I am going to keep as 0. Trust me, there's a reason why I'm doing this. Display format is automatic. Now I'm going to go ahead and select the range. Minimum I'm going to be keeping 0. Maximum the default is 100. And step size I am going to keep as 2. So with that, I have created my parameter. It's going to be an integer type parameter ranging from 0 to 100. Now, as you can see, in the bottom here in the parameters set, you can see an if sales parameter, the one that we have just created. Remember that I had told you that you have to use your parameter and tie it to your view in some way. And the first way that I had told you was to use your parameter in your calculation. And that is exactly what we are going to do. Now, in this scenario, we want to use our parameter and a few Tableau functions to create a calculated field to add to our graph. And then we are going to see its effect on our data. So we're going to go ahead and create a calculated field. Now I'm going to name it the same as my parameter, except for I'm going to name it calculation. And here I am going to be throwing in a formula, which if you want to know more about, you can go ahead and check a tutorial that we have on functions in Tableau so you understand what these functions do basically. So I'm putting in this formula here, and at the bottom it says calculation is valid. Now I cannot stress enough, so I'm going to say it one more time in this video. I've mentioned it many times in many videos and lives before, that this is something which shows that Tableau is a really, really smart software. If suppose I remove a parenthesis from here, in the bottom it is going to show the calculation contains errors, and if you hit the arrow button here, it's going to tell you what error it is. This way it prevents you from making mistakes right from the get-go. You do not have to go much further in your process. This is going to be a small process for demo purposes, but usually Tableau is used in an industry level, and there, once you have gone much further in your procedure, coming back and correcting mistakes will be troublesome. So I'm going to hit OK. And in your measures section, you can see your if sales calculation is here. Now what I want you to do is notice how your calculation, the parameter that we created, is going to interact with your sales measure in the segments that follow. Next, what we're going to do is parameter control. Now, coming back to the Tableau main menu, as I had just mentioned, you can see your calculation field in the measures pane and your parameter in the parameters pane. This is your data window. So I'm going to click on this and click on the option show parameter control. On the right, you see this particular option, which is your if sales parameter. This is your parameter control. Currently, it is there in this slider form, giving you your range 0 to 100, which we had selected. You can always go ahead and change it from slider form to your type and form. I prefer the slider form over the type and form. It's easier to operate for me. You can go ahead and make your choice. This is the top right of your view. And this is where, by default, your parameter control filter is always displayed. Now, I'm not going to show you how it is used right now. In the next segment, you will see what its use is. Now, finally, we are going to be using Tableau parameters in our visualization. This is the part most of you might already be waiting for. Okay, so starting out, what I want to do is I want to switch this for measure values. And I am only going to be keeping my if sales and the regular sales, which we had made the graph with before. Okay, now I have my calculated field if sales right here, and so I have my sales also right here. Okay, now because on your right you can see your parameter control is at 0, you might be able to see just one graph. But as we start moving the slider up, suppose I keep mine at 30, you instantly get two of your graphs. One of them is your if calculation, your if sales calculation, which is your calculation grown by 3%, your sales grown by 3%, right? And the other one is your regular sales. You see the difference? Once you click on your parameter control and set it to any number which is visible, like I would suggest go above 10, I have set it as 30, you can see your dual axis graph. You can go ahead and change the color if you want to, but I'd like to keep them in blue itself because I think it's pretty visible. But you can always go ahead and change the colors if you like. Now these lines represent the running values of sales from your data set and the calculated sales simultaneously. And you've successfully incorporated your parameter in your visualization, along with your control that you have on your right. And that is how you create and use parameters in Tableau. Now, parameters are dynamic and useful elements for you to add interactivity and flexibility to your dashboards and reports. It is a very versatile tool and can be used in way more than what I showed you in this demo. It can be used in various calculations, sets, equally well. Now, this is one of the many smart features that are there in Tableau, which is emerging as one of the hottest trends in business intelligence in 2019. And also, if I might add, it is one of the easiest data visualization tools to learn, one of the most interactive and smart softwares. And if you look at Google Trends, it seems like there can be no better time than right now to get certified in Tableau, to start learning Tableau. So first of all, we have number functions. Now, number functions allow you to perform computations on your data values in the fields. So these functions can only be used with the fields that contain numerical values. Pretty obvious, right? On your screens right now, you can see all the number functions that I'm going to be covering in this segment. We will start with the absolute function or the ABS and close using the ZN function, each of which I'm going to demonstrate to you using the Tableau desktop. So let's get started with our first function. So the first function in the number functions category is ABS or the absolute function. On your leftmost column, you can see the name of the function. In the column in between, you can see its syntax, and on the right, you can see the description. So what your ABS does is it returns the absolute value of the number or the parameter that you put in the bracket. So if I give like a negative number in there, like a -5, then an absolute function is going to turn it into a 5 and return it back to you. It's kind of like the mod of a number. In the example that I've given, you can see we are trying to get the absolute value of budget variance. So suppose you had a field called budget variance. The ABS function will return the absolute value for all the numbers that are contained in the field. So let me go to my Tableau desktop and I'm going to demonstrate how this works.
So this is my Tableau desktop, and currently I'm using the 2019.1 version. This is the Show Me bar. If you want to know more about this interface and how to use Tableau desktop, we already have a few videos, a few tutorials in our YouTube playlists. Please feel free to go ahead and check that out. This tutorial is specifically for functions in Tableau, so we are going to dive straight into that. So as you can see, I have already pulled in the data from the sample data set that is available in Tableau. It's called the Sample Superstore. Now this is only available in the desktop version and not in the public version. So make sure if you're trying to follow through with this tutorial, you are using the actual Tableau desktop. So what I'm going to do is I'm going to navigate to Analysis and create a calculated field. This, what you see, is the calculation editor that opens. You're going to name it absolute, as we are going to try the absolute function right now. And I'll show you something simple in the beginning. It's as simple as this. You're going to go ahead and do ABS. And suppose I put in -5, which is the number. At the bottom, it shows my calculation is valid, which is a great thing about the calculation editor in Tableau. It prevents you from making further mistakes, helps you correct them immediately, because at the bottom it is going to prompt you whether your calculation is valid or not. Then I'm going to apply it and OK. So basically, if I bring this here, let me do the attribute. Yes. So it'll give me the absolute number. Instead of -5, it's going to give me 5, because absolute is kind of like your modulus. It's going to give you the absolute value of the number that you have produced. So let's try it with a field that we have here. So let's go down. So we have this sales field here. So let me remove this and we can go make some changes. So I'm going to edit this field, and instead of placing just the number, I'm going to put in sales. It's automatically going to appear to you. That is how smart this tool is. All right. So when I bring this here, it's going to automatically show a number here. Now what I'm going to do is I'm going to divide this by state. All right, so we can see all the absolute values over here. Now what I'm going to do is I'm going to go to Show Me and put it into a map. So now we can easily go to each state and see the absolute sales in all of these states. We have South Dakota, North Dakota, Montana, and all the other states. As you can see, it shows us the absolute value of the sales in that particular state. All right. And as you can see on your right, it will show you the gradient of color, which basically means that the lighter the colors, the lighter blue there is, the lesser the sales are in that particular state, as opposed to the darker the color. As you can see, in the state of California, or it may be New York, the sales are the maximum. No rocket science there. Let's go back to our presentation and look at our next function. So our next function is the arc cosine, or 𝐴cos. It basically returns the arc cosine of the given number. And the result will always be in radians. So if you give an arc cosine of -1, you're supposed to be getting something in lines of 3.1415926. As simple as that. So let's go back to our Tableau desktop and run this and see. Again, we're going to go to Analysis and create a calculated field. You go and type 𝐴cos -1 and apply it. And like the absolute measure that we had discussed about the previous time, this also appears under measures in the data pane, just like your other fields, and you can use it in one or more visualizations. So I'm going to bring this here, and it shows 3.142, which is just the rounded off version of 3.14159, and that was all about arc cosine. Next, we have arc sine, which, as the name explains, returns the arc sine of the given number in radians. I'm quickly going to show that here again. And it gives you the answer 1.571. Next we have the arc tangent, which is given in radians again. It is atan, which is the number function. I will go through this section pretty quickly, as these are not the functions which are used very regularly in Tableau, but they were kind enough to provide us with these functions, so we are going to use them. So I'm going to make an edit in this again. Just quickly going to go through. And you're supposed to be getting 1.565. Next we have ceiling. Now basically what it does is when you pass a decimal number to ceiling, it is going to round it off to the nearest integer of equal or greater value. So if I give it 3.26 or something, it's going to round it off to straight up 4. Now these are available in a couple of data sources like Microsoft Excel and text file and statistical files, but they are also not supported by a few popular sources such as Microsoft Access and Action Vector or Amazon Aurora, so on and so forth. So here again, I'm going to go to create calculated field and I'm going to name it ceiling. And then I'm going to put on 9.1265, just any number. So as you can see, the ceiling, what it did was it rounded off that number to 810, right? Let me try to. Okay. So that's all about ceiling. Next we have cos. Now cos or cosine of an angle, it's pretty self-explanatory. Most of you, I'm sure, would have studied this in school. It basically returns the cosine of an angle if you give your angle in radians. So what I'm going to do again, so as you all might have studied in school, cos pi by 4 is 1 by root 2 or 0.707. So we're going to apply this. Alright, so as you can see, it gives you 0.7071, which is 1 by root 2, which is again cos pi by 4. Next you have cot or cotangent of an angle, same as cos, that you're going to, I repeat, next you have cotangent or cot, and we are going to implement it the same way as we did cos. I don't think these trigonometric functions need a lot of explanation. We've all done these in school, so let's just get this over with. So again, I'm going to go with a pi by 4 because I'm lazy and I'm not going to think of any new angles. So as we all know, cot pi by 4 is 1. And as you can see, the value immediately changed to 1. The next function we have is degrees. Now what this does is it converts a given number in radians to degrees. And as you can see, pi by 4, as we all know, pi is 180. So your pi by 4 naturally is 45 degrees. And that's what it was supposed to do, and that's what it did. Moving on, we have div or division. So what it does is it's going to return you the quotient, where your integer 1 is basically your dividend and your integer 2 is your divisor. And it's going to give you the integer part of your quotient. So if I do 11 by 2, it's not going to give me a 5.5, but only a 5. As you can see, Your quotient is 5. Next you have the exponent or exp. Basically it returns e raised to the power your given number. So basically if we start with something simple, like we'll just put on a digit, say e raised to 2, it's straight up going to give you e raised to 2, which is 7.3. But you can also use these to put in fields and formulas, such as your growth rate into time, so on and so forth. Next you have floor. Now this is kind of the counterpart of the ceiling function, where it rounds a number to the nearest integer of the lesser value. So like in ceiling, if I had to put in 3.1415, it would give me a 4. A floor, on the other hand, would give me a 3. So as you can see, I have used ceiling right here. So let's see, what had we done for ceiling? Okay, so I had put in the number 9.1265 for ceiling. Now let's try putting in the same number for floor. So I'm just going to make an edit in this. I'm going to put floor. Okay, apply and okay. And as you can see, immediately it went from 10 to 9. Our decimal has been rounded off to the lower number. Now again, like ceiling, it is not supported by Microsoft Access, your Action Vector, and your Amazon Aurora, Redshift, so on and so forth. But it is supported by your Microsoft Excel and text file and statistical files. There are many other files which support and also do not support ceiling and floor, but popular ones like Google Analytics and Google BigQuery support both of these functions. Next we have 𝐻EXBIN. Now basically what it does is it maps an X and Y coordinate to the X coordinate of the nearest hexagonal bin. Now these bins have side length 1, so the inputs may need to be scaled appropriately. Now the 𝐻EXBIN X and the 𝐻EXBIN Y are binning and plotting functions for hexagonal bins. Now these bins are efficient and elegant options for visualization of data in the XY plane, such as your maps or visualizations dealing with geographical data, your scatter plots, your hex plots. Now because these bins are hexagonal, each bin is closely approximated to a circle, and hence it minimizes variation in the distance from the data point to the center of the bin. This makes clustering both accurate and more informative. Next we have the natural logarithm of a number. Basically you type ln and then your number, and it's going to return the natural logarithm. If your number is less than or equal to 0, it's going to return a null value. As we know that the natural log of 1 is 0, so that is what we get. That's the only one I remember from school, and that's the reason I put that in as my input. Now something very similar is logarithm with a base, which we usually take as 10. So if the base value is omitted, you decide to not put in a base, it's by default going to use base 10. So we're going to put in, say, 100, and ideally we're supposed to get 2, and that is it. Log 100 base 10 is 2 because 10 raised to 2 is 100. Pretty simple. Next we have max, which as the name suggests, it returns the maximum of the two arguments which are passed. Now the arguments must be of the same type, and this function returns null if either of the argument is null. So max can also be applied to a single field if it is used as an aggregate calculation, which I'm going to cover in the later segment of this particular session. So it can be as simple as, say, two numbers. So if I put it right here, show by attribute, 7 is larger a number than 4, so here you have 7. Or you could go ahead and put in 2 fields over there. Let's say profit and sales. And when we take the sum of it, now this I remember is the value of sales. Obviously, sales is going to be more than the profit. The sales field is going to have a higher number than the profit. So that's about it. Now the other half of this particular set is the minimum function, which is like the maximum function, but it returns the minimum of the 2 arguments of the same type. So if I just went ahead and edited this particular function, instead of max, let's name it min. And here again, instead of max, let's name it min. Let's put in the min function. I'm going to apply it, and this, I'm sure, is the profit field. As you can see, the number has changed. Next, we have pi. As the name might suggest, it is going to return the value of pi. .142, which is the rounded off value of pi. Next, we have power. So again, we are back at our Tableau desktop, and we're going to try and create a power field. So here I'm going to just go for power and then our base, which let's take 10, and then the power, so we'll take that as 3. And ideally our answer should be 1000. So if I drag it to rows, bring it to its attribute, we can see powers is equal to 1000. Next, we have radians, which basically does the opposite of degrees. It converts the number given in degrees to radians. So I'm going to go here again. So earlier we had converted pi by 4 into 45 degrees. So here I'm going to put 45 degrees, and let's hope we are getting pi by 4. So I'll take this rad calculation, put it here, and we get 0.7854, which is also pi by 4. You can do the math, use the calculator, take this moment, pause this, you can go check. Then we have round. So basically what this does is it rounds a particular number that you put in to a specified number of digits, right? The decimals argument specifies how many decimal points of precision to include in the final result. Now, if that part you decide to not fill anything in, the number is rounded to the nearest integer, right? Now, before I move on to my Tableau server, some databases such as SQL Server allow specification of a negative length where -1 rounds to the tens place, -2 rounds to the hundreds place, and so on. This is not true for all the databases, of course, such as Excel and Access do not follow through with it. So with that, let's go to our Tableau desktop and see how this functions. So what I'm doing here is I'm going to round up every sales value to an integer. That's why I did not put anything in the decimals place. If I take a subcategory, all right, as you can see, everything has been rounded up to an integer. No matter what the sales in dollars is, there might be some decimals in there, but all of it has been turned into integers using the round. Next, we have sign, which returns the sign of a number. Now, the possible return values are -1 if the number is negative, and 0 if the number is a 0, and 1 if the number is positive. So I'm going to run this particular example, which I have given here. I'm going to run that itself on my Tableau desktop. So I'm going to be taking the average of the profit field, profit, and apply. Now, because the profit is positive in our given sample set, okay, this looks better. Now, what was I saying? Yes. Now, because our profit is positive in the given sample set, our answer turns up to be 1. If it were negative, it would have been a negative of 1. Alright? After sine, we have sine, which is the trigonometric sign again. So it basically returns to you the sine of an angle. All we have to do is specify the angle in radians. So let's just So again, I'm going to take sine pi by 4, which is 1 by root 2. So it comes up to be 0.707, same as your cosine. Then we have the square root of a number, which, as the name suggests, returns the square root of a number. So as we can see, the square root of 100 is 10. Next, we have the opposite of square root, which is the square of a number. Pretty self-explanatory. I'm just going to edit this, name it square. I'm going to do the simplest thing, and you might just think this is a lazy woman, which you're right, my friend. So I'm going to square 10 so we can get 100. And there you have it. It's 100. No big surprise there. With that, we have tan. Okay, so here we have the sine. What I'm going to do, I'm just going to edit this. Not going to create any extra sheet here. Just going to put tan and change this into tan. Tan pi by 4 is 1 for those of you who do not remember from school. And here we have the answer as 1. And with that, it brings me to the final of the number functions. We have Zn, which returns the expression if it is not null. Otherwise, it returns 0. Now, we basically use this function to use 0 values instead of null values. So this is how it works. I'm going to put in a field which I know does not have a 0 value. So I'm going to put in profit. So here I'm going to put in the average of profit. It's in the sum mode now. I'm just going to take the average. And I know for a fact it's not a non-zero value, and it's returned to me the average of profit, which is 28.66. With that, we come to the end of this segment. Let me head back to the presentation to start with the next module. The second segment is string functions. Basically, string functions allow you to manipulate string data. Now, you can do all sorts of things with it, like pull out all the last names from your customers into a new field. One member might be, say, Shubham Sinha, and then you can pull out all the customers with the surname Sinha and then put them in a new field using the string functions. So again, on your screens are all the string functions that I'm going to discuss, which is all the string functions that are available in Tableau. This by no way is an advanced tutorial. I'm just going to show you how each syntax works. So let's start with the first one. We have ASCII. As most of you know, there is an ASCII code for every character of the string, and what this function does is it returns that ASCII character. Now, as we all know, the string A has the ASCII code of 65, and that is what this returns. Next, we have char, which is kind of like the counterpart of ASCII. Here, it's going to return the character that is encoded by the ASCII code. Here, you have to put in the number, and it will return to you the character. And as you can see, it returns A. Next, we have contains, which basically returns true if a given string contains the specified substring. And as you see, it returns true. Next, we have ends with, which returns true if the given string ends with a certain substring. Next, you have find, which returns the index position of the certain substring that you're trying to search for in the string, or 0 if the substring isn't found. If the optional argument, which is start, as you can see at the end of this argument bracket, is added, then the function ignores any instances of the substring that appear before that index position start. The first character in the string is position 1. As you can see, it said that the substring 𝐸𝐾𝐴 that I was searching for starts from index number 5. Now let's see what happens if we put in our last argument. Let's put a 7. As you can see, because till the 6th index it was not asked to search, it returns a 0, which means it could not find the substring. Next, we have find nth, which basically returns the position of the nth occurrence of a substring within a specified string. So n is where the argument has occurred. So here in find nth, I've changed the word. I've put in learning here, and I'm going to search for when does n, the alphabet n, occur for the second time in the word learning. All right? So if I bring it to text, you see the answer is 7 because learning, it's an 8-letter word where the second time n occurs is at the 7th position. Now, left returns the leftmost number of characters in the string. So you put in the string and then you put in the number till which you want your substring to be. Let's see, what do I like? I'm going to put it in Matador and then 3. So it's going to print the leftmost 3 characters from the string. Then we have a pretty common one called length. If either of you have used Excel or Word or Access or any of these common databases and apps, you know what len does. It returns to you the length of the string. So what I'm going to do is, there you go, it returns the length of Matador, which is 7. Then you have a function called lower. Basically, you put in a string here and it will return you the string with all characters in lowercase. So I'm just going to randomly capitalize. Okay. So next we have ltrim. Now this basically returns the string without any spaces on the left. So if I try to ltrim space matador space, it is going to remove the space at the left hand side of your string. And here you can see the space on the right is there, but the space on the left is gone. Then we have max, which returns the maximum of A and B, which must be both strings. Now this function is usually used to compare numbers, but it also works with strings. Basically what it does is it finds the value that is highest in the sort sequence defined by the database for the column. It returns null if either argument is null. So I'm going to put apples and bananas, just expression 1 and 2. You can put anything. and then it returns bananas because obviously more number of characters. Next we have mid, which returns the string starting at the index position start. So the first character in the string is position 1. If the optional argument length is added, then the returned string includes only that number of characters. So what I'm going to do is I'm going to use the word learning, and then I'm going to start with the second index number, which is supposed to be E, and then I'm going to give a length, say 5. So 5 characters, then I'm going to apply it and OK. And as you can see, 5 characters starting from position 2. Next we have min, which is the counterpart of max. It basically reverses what we got in max. It's going to give you the string with the minimum number of characters. So we're going to do the same thing, apples and bananas. You can also put in a field in here and it'll give you the least value from that certain field. So as you go, apples having the minimum number of characters. Then we have right, which returns the rightmost number of characters that you have specified in your syntax. So if I put in learning and for, it should ideally give me ning. And there we have it. Then we have the R trim, which is kind of like the L trim, but from the right. So if I put in a string with spaces on the right, it's basically going to clear out the spaces. You're going to type the same word, spaces on the left and right both. And when we get it, you can see there is a space on the left, but not on the right, which is the opposite of L trim, where we deleted the space in the left and we kept the space in the right. Next you have space, which basically returns a string that is composed of the specified number of repeated spaces. So space 1 is going to give you 1 space, 2 is going to give you 2 spaces, so on and so forth. Then we have split. Now this is an interesting one. It returns the substring from a string using a delimiter character to divide the string into a sequence of tokens. Now the string is interpreted as an alternating sequence of delimiters and tokens. So let's see how this works. And I am going to C and D. Let's put these quotes on both sides. And then I'm going to put in what my delimiter is, which is the hyphen. Now I could have also used slash. The only thing you had to do is specify it in the delimiter part of the syntax. And then I'm going to put in the token number 2, which otherwise should have been my delimiter, this one, the hyphen. But because we've specified the delimiter, it's supposed to be returning a B. And as you can see, it returned B. Now the split and the custom split commands, which are kind of the same commands, are available for a few data types and they're not available for a few data types. So Tableau data extracts, Microsoft Excel, text file, PDF file, Salesforce, all of these support the split, and some data sources impose limits on splitting string. And there are these ones which support negative tokens, where there is a limit on the number of splits that is allowed per data source. Next we have trim. Now basically trim is the combination of L trim and R trim. It is going to remove spaces from both left and right. So I'm going to again use, as you can see, space and Matador and another space. And as we can see, it has no spaces in the beginning or the end. And here we are at the final string function, which is upper, which returns the string with all characters in uppercase. So I'm going to go here and go with upper and randomly capitalize like I had done earlier. Let's see. And it returns to us Matador in all caps. So with that, we come to the end of string functions. The next segment is on date functions. Now, as the name suggests, the date functions allow you to manipulate dates in your data source, such as year, month, date, or time. So let's go to our first function. We have the date add. Now, the date add returns a specified date with the specified number interval added to a specified date part of that date. For example, if I put in month as the date part, 3 as the interval, and a date as the date, this expression would add 3 months to the date 15th of April 2004. So let's try this. Now this expression adds 3 months to the date. So we had 04 as in April for this date, but if I change this to month, it has July, which is May, June, July, addition of 3 different months. Next we have date diff, which returns the difference between the 2 dates that you have input into this function. The start of the week parameter is the one which you use to specify which day is to be considered the first day of the week. It is optional, of course, but in a lot of countries, you consider Monday as the first day of the week, whereas in the other part of the world, you consider Sunday as the first day of the week. If this part is omitted, then the start of the week is determined by the data source. So let's see how that works. So as the date part, I am putting in week, then I'm going to put in 2015, say 2015 October, and let's say 23rd. And then I am going to put 2015 and the same thing on the 11th month, November. I'm going to put in the start date as Sunday. All right, I think with that we're done. And we're going to change this and it shows that the difference is 5 weeks. Next we have date name, which returns the date part of the date as a string, and the start of the week parameter, again like the previous function, you can use to specify which day is considered the first day of the week. It could be Sunday or Monday or Tuesday, depending on what you like. So if I put in the date part as year, and I put in the year and the starting date of the week, which in this case is not really necessary, it returns a string 2004, which is the name of the year that we had put in. Next we have date part, which kind of does the same thing as the date name, but it returns the date part of the date as an integer instead of a string. So if I made that edit here, it will return to me the same thing, but it is not a string, but an integer. Next we have date trunc. Now, as a lot of you might have guessed, this basically truncates the specified date to the accuracy specified by the date part. So basically this function returns a new date. For example, when you truncate a date that is in the middle of the month at the month level, this function will return the first day of the month. Again, this has the start of the week parameter, which you can use to specify which day is considered to be the first day of the week, so on and so forth. So I've put in this date and I've specified quarter. So it's supposed to truncate this part of the date completely and bring me to the beginning of the month. So when I bring this here, so as you can see, it has brought me to the beginning of the month July, and has truncated that part of the month from half the month, 15th of July, to the first part. Then we have a day, which returns the day of the given date as an integer. As you can see, it's 15. Next we have isDate. Now this returns true if a given string is a valid date. So if I put in February 30th, 2015, it returns false because there is no 30th in February. On the other hand, if I go ahead, edit it, and put in like a 28th of Feb, it returns true because 28th of Feb exists in every single year. Next we have a makeDate, which returns a date value constructed from the specified year, month, and date. So if I make date with 2015, 3, and 15, I'm supposed to be getting 15th of March 2015. This is a slight derivative of the previous function. Now this is basically an extension of makeDateTime, and along with the date it adds the time as well. Next we have makeTime, which is exactly like makeDate except for it's for time. So it returns an hour, minute, and second of the time that you put in. Not going to spend much time here as they're all pretty similar in nature. Next we have max that we have used 2 times before, so I'm not going to demo this as well. Again, you will put in 2 dates and it is going to return the maximum of the 2 dates. Next we have min. Again, you're going to put in 2 dates and it's going to return to you the minimum of those 2 dates. Next we have month, which returns the month of the given date as an integer. So if I put in 2005-09-23 and close this, it gives me back 9, which was the month I'd put in. So this is an interesting one. This is called now. This returns the current date and time. Now what it returns varies depending on the nature of the connection. So for a live unpublished connection, now returns the data source server time, and for a live published connection, now it returns the data source server time. So I'm assuming that it is going to give you my system time. So just gonna go with now. It gives you 2019. If I bring it down to the date, it's going to show 7th of May 2019, which is the day in which I'm recording this video. Another one like now is today, and basically what it does is it returns to you the current date. So instead of now, we're going to put in today, and it gives you today. Nice, isn't it? And finally, the last date function we are going to do is year. So basically, it returns the year of the given date as an integer. And if I bring this here, it gives me 2014, which is the year I had put in, and it's given it back to me as an integer. Next, we have type conversion functions. Now, why do you use these functions? Now, type conversion functions allow you to convert fields from one data type to another. So basically, you can convert numbers to strings, such as age values, so that your Tableau will not try to aggregate them. So let's move on to our first type conversion function. The first one is date. Now basically, this returns a date given a number, string, or date expression. So if I go in and put an order date, basically has given me a list of all the order dates that are there in the data set. Now I can obviously filter this by year. And bring it down to these many dates. Next we have date time, which is kind of like date, but it returns a date time given a number or string. Now this I'm not going to show you the demo because it is very similar to the date function. Now we have date parse. Now what this does is it converts a string to a datetime in the specified format. Letters that appear in the data and do not need to be parsed should be surrounded by single quotes. And for formats that do not have delimiters in between them, suppose hyphens and slashes and dots, verify that they are parsed as expected. So the format must be a constant string, not a field value. And this function returns null if the data does not match the format. So let's see how this works. So this is my format. And this is my date, 15 September and 2005. And this is exactly how it's going to show it to me. This is the same in the table. Next we have float. So basically if I enter a float 3, it is supposed to give me 3.00. Next we have int or integer, which again, opposite of float, is going to cut down the decimal part of the number and give me only the integer part. And finally, we have a string expression. Basically, you're going to pass in an argument through it and it's going to convert it into a string and give it back to you. So that's all about type conversion. Now let's go back here. For the string, I'm going to give you a demo. Rest all is kind of the same how we had done before and how you do it with other tools. So basically what I'm going to do is I'm going to edit this and str, and I'm going to put in the postal code. Now as we all know, postal code is in numbers. So as you can see, this is our postal code and it comes under dimensions. Why? Because it is currently number. As we can see, it's a whole number. Now what we're going to do is we're going to edit this str string and put in postal code and OK. Now, as you can see, the type conversion, which is basically the same thing as the postal code, has a string data type. The postal codes will remain the same, but their data type is going to change. That's what the string function does. And with that, we come to the end of type conversion functions. Let's move on to aggregate functions. There are a few more than the type functions here. So basically what aggregate functions let you do is that they allow you to summarize or change the granularity of your data. For example, if you want to know exactly how many orders your store had for a particular year, you can use the count_d function to summarize the exact number of orders your company had, and then break the visualization down by year. So there are a bunch of aggregation function out here, most of which we have already used as number functions before. And if we haven't used them as number functions before, while we have dragged it to our marks panel, most of you have seen how they work. So let's start with the first one. The first one is attribute. You might have seen through the course of this video how I have changed the default aggregate from sum to attribute many times over in this video itself. It basically returns the value of the expression like it has a single value for all the rows. So it is like one standard value. The null values hence are ignored. Next, as the name suggests, this is the average expression. It returns the average of all the values in the expression. Since I haven't used it before, I am going to show how this works. So suppose I bring in my sales here. As you can see, the default measure is sum. I can break it down to the average and it shows average sales. Nothing new, no rocket science. Next, we have correlation coefficient, which basically returns the Pearson's correlation coefficient for two expressions. Now, the Pearson correlation measures the linear relationship between two variables and results range from -1 to +1, where 1 denotes an exact positive linear relationship, as when a positive change in one variable implies a positive change of the corresponding magnitude in the other. Now 0 denotes no linear relationship between the variance, and negative of 1 is the exact negative of a relationship. Now what I'm going to do is I'm going to use a table scoped level of the detail expression. So I'm going to go ahead and this is what it gives. It's between negative of 1 to positive of 1, and this is how far the relationship is linear. So you can say that the relationship between profit and sales is fairly linear because it's on the positive side. And with a level of detail expression, the correlation you can run all over the rows, and the view would show the correlation of each individual point in a scatter plot. If you want to do that. Next, we have count, which returns the number of items in a group. Null values are obviously not counted. And then we have count D, which returns the number of distinct items in a group, which basically means that if a certain item is there twice in a certain group, count D is going to count it as one item. Then we have the covariance expression. This basically returns the sample covariance of two expressions. Covariance basically quantifies how two variables change together. A positive covariance indicates that the variables tend to move in the same direction, when a larger value of one of the variables tend to correspond to a larger value of the other variable on an average. Now the sample covariance is the appropriate choice when data is random and it is being used to estimate the covariance for a larger population. Like we found out the correlation between sales and profit, we can also find out the covariation between sales and profit. Next, we have covariance of the population. It basically does the same thing as covariance, but this time of the entire population. Next, we have max, which we have tried thrice before. It returns the maximum expression across all records. We have median, which returns the median expression across all records. And then we have the min, which returns the minimum expression across the records. Next, we have percentile. What it does is it returns the percentile value from the given expression corresponding to the specified number. Now the number must be between 0 and 1, obviously, and this function is available in Microsoft Excel and text file connections, Google Analytics or Salesforce, Cloudera Hive, Oracle 10, and the later data resources of Oracle, Access Solution 4.2 and the later versions, and Sybase. Next we have standard deviation, which returns the statistical standard deviation of all values in the given expression based on a sample of population. Now the same thing for the entire population and not the sample is the standard deviation of population. It basically returns the statistical standard deviation of all values in the given expression based on a biased population. Next you have sum, which is also the default aggregate, which is allotted to all the measures and dimensions that you use. It returns the sum of all values in an expression, and of course it can be used only with numeric fields, and null values will be ignored. Then you have variance, which returns the statistical variance of all values in the given expression based on the sample of your population. And finally we have the population variance, which gives the statistical variance of all the values based on an entire population and not just a sample. We're finally at our last segment, logical functions. Now, why should you be using logical functions? Now, this is basically used to calculate Boolean logic. If you don't know what that is, it basically means you give a certain condition and it tells you whether it's true or false. There is no other output than true or false. Now, most of these things we've already seen through the many functions that we have covered today, and the rest are very common logical functions if you are from any coding background. So what I'm going to do for this particular segment is that I'm going to go through all of these functions first and then go to my Tableau desktop to show you a tiny demo. So first of all, AND function. Now basically this performs a logical conjunction of the two functions. So basically it's the logical AND. If you look at the given example, it says if your market equals to Africa and the sum equals sales, both are greater than emerging threshold, then it should give the output well performing. Notice how both of these conditions have to be true for Tableau to give you an output of well-performing. That is what a logical AND does. For logical AND to work, both of the conditions need to be true. Next, you have case. If anybody of you are from the coding background, you can relate it with the switch case. It performs a number of logical tests and returns appropriate values. The case functions evaluates expressions, compares it to a sequence of values, and returns a result. When a value that matches the expression is encountered, case returns the corresponding return value. If no match is found, then the default return expression is used, and if there is no default return and no values match, then null is returned. Case is often easier to use than if, else, and statements like that. Typically, if you use an if function to perform a sequence of arbitrary tests, you can use a case function to search for a match to an expression. But a case function can always be rewritten as an if function, although the case function will generally be more concise. So many times you can use a group to get the same results as a complicated case function. We'll learn more about if in the later parts of this logical functions segment. Next, we have else. Now, this is the counterpart of if. So if something, then a condition has to be either fulfilled or not fulfilled. It will give you an answer. Else, it will give you another answer. It's as simple as that. It tests a series of expressions, returning the then value for the first true expression. Then you have else if. If you have a number of if statements before your default else, then you use else if. It tests a series of expressions, returning the then value for the first true expression again. Then you have end, which as the name suggests, it marks the end of an expression. Then you have if, as we have already discussed. If basically tests an expression and then returns a corresponding value. Then we have if null, which returns the expression 1, if not null, otherwise returns expression 2. It is basically like a regular if function, except for it just checks for one condition. If the expression you've put in is null or not. Next is if, which checks whether a condition is met and returns one value if true, another value if false. It's basically like a test case and an optional third value or null if unknown. Next we have isDate, which returns true if a given string is a valid date. It's no big deal. Then we have isNull, which returns true if the expression does not contain valid data, which is if your expression is null. Then we have max, which we have discussed many times before. It returns a maximum of all the records or maximum of 2 expressions for each record. Then we have minimum, which does just the opposite. It returns the minimum of all records or the minimum of 2 records. Then you have the logical not, which performs logical negation on an expression. So basically, if the field you have put in does not fulfill the condition, then it gives you the corresponding result. Then you have the logical OR, which basically means that if you have put in 2 conditions, either or of them have to be true, then it will give you a result. Then we have then, which we have discussed before. If a certain field fulfills a condition, the corresponding then part is then fulfilled. Now here we have a when function, which finds the first value that matches the expression and returns the corresponding return. It's kind of like if and then case, except for there is no if. Then you have zn, which returns your expression if it is not 0 or null. We have discussed this before. Now let's go to our Tableau desktop and create a logical calculation to see how you can use this. So now again, come back to our Tableau desktop one last time for this session. So again, I am from the data pane, drag state to the rows shelf. As you can see, a table like this should ideally appear. Then I am going to take category, place it at the rows as well. This is nice. I'm going to analysis, as I've done many times before in this session. Create calculated field. Here I'm going to name this KPI, which is Key Performance Index. Basically shows you how your company is doing internally and externally. Internally as in different departments and externally as in the market. going to do a simple sum profit. We can see this here. Now, this calculation quickly checks if a member is greater than 0. If so, it will return true. If not, it will return false. It's kind of like the if and then statement. So when finished, you can go ahead and click OK. As you can see, this new calculated field appears under the measures in the data pane. Just like your other fields, you can use it on this visualization. So I'm going to drag this to the color on the marks card. And I'm going to turn this whole thing into, so I'm going to take the sales and put it in the columns. You can now see which categories are losing money in the states. So all these orange ones are the ones in profit, and the blue ones are the ones at loss. And that's the simplest use of the logical functions. You can use this for way more because Tableau is capable of not just pretty graphs, but a good drill down of data.
What are context filters? You can think of a context filter as being an independent filter. Any other filters that you set are defined as dependent filters because they process only the data that passes through the context filter. Now, you can create a context filter for either of these reasons. First of all, to improve your performance, which is the main objective of having a context filter in the first place. If you set a lot of filters or have a large data source, the queries can be extremely slow. You can set 1 or maybe 2 context filters or more context filters to improve the performance. Next, to create a dependent numerical or top N filter. Here I'm talking about determining the top 5, top 10 of a certain category. You can set a context filter to include only the data of your interest and then set a numerical filter on top of it. For example, suppose you're in charge of stationery products for a very large stationery shop chain. Your task is to find out the top 10 pencil brands that sell by profitability for all stores. Now, if the data source is extremely large, you can basically set a context filter to include only pencils or products categorized under pencils. Then you can create a top 5 filter or a top 10 filter by profit and net profit as a dependent filter, which would then process only the data that passes through that context filter. If your Tableau desktop version is post Tableau 9.0, the context filter here no longer creates temporary tables except for generic ODBC data sources and a few other customized data sources. So now let's directly move on to creating a context filter on our Tableau desktop. So this example basically walks you through how to create a context filter. Now simply put, to create the context filter, you have to select Add to Context from the context menu of an existing categorical filter. The context is computed once to generate the view, and all other filters are then computed relative to the context. Now this example is going to walk you through how to create a context filter, but for that first you'll be needing to filter a view to show the top 10 products by sales. So we are using the sample superstore data source so that it will be easily available to everybody to follow this tutorial. So firstly, we are going to be creating an initial view, which is going to display the sales for all subcategories sorted from the highest sale to the lowest sale. Yes. So we are going to be taking sales measure, and that's going to be our column. And then we're going to take subcategory from our dimension. That's going to be a row. And right now it's in a very haphazard order. We are going to go ahead and order it in a descending order. Yes. So now we know phones make maximum sales and fasteners make minimum sales. So now what we're going to do, we're going to create a top 10 filter to just show the top selling products. You can create this filter by first dragging this subcategory into the filters shelf right here, and then you will get this filter subcategory dialog box. where you can go to this top tab and define what you need from the filter. Yes. So what we're going to do is we're going to filter the top 10 by sum of sales. So we are going to select by field, top and 10. All right. You're going to apply this and click on OK. All right. So right now we have our top 10. And now you can see when you click OK that the view is filtered to show the top 10 product subcategories in terms of sales. Now let's go ahead and add another filter to show only furniture products. So what I'm going to do is, where is category? Yes, it's here on the top of the dimensions. So I'm going to drag that to the filter shelf. And here when the dialog box comes up, I am going to go ahead and check only furniture. When finished, I'm going to click on OK. Yes. Now the view is filtered, but instead of 10 products, it only shows 3. Now this is because by default, all filters are evaluated separately and the view shows the intersection of the results. So the view shows that 3 of the top 10 overall products are furniture products. Now to find out what the top 10 furniture products are, we need to make the category filter a context filter. So what I'm going to do is I'm going to right click the field on the filter shelf. And here I have the option of adding to context. So I'm going to click on add to context. And now as you can see, this filter is marked as a context filter and the view updates to show the top 4 furniture products. Now why not 10? Because only 4 of the subject categories contain furniture. But we now know that the top 10 filter is being evaluated on the results of that particular context. Now here's a couple of tidbits you need to know about context filters. Firstly, they're going to appear at the top of the filters shelf as you can see and are identified by a gray color as again you can see. Now see if I try to rearrange this. It cannot be rearranged in the shelf. In our scenario, the furniture dimension is set to be the context for the view and the subcategory filter is computed using only the data that passes through the furniture category. Next, let's look at a few ways to improve the performance of context filters. Let's look at a few ways to speed up our context filters. Now, especially on large data sources, there are a few general rules that we usually follow. First, using a single context filter that significantly reduces the size of the dataset is usually much better than applying many context filters. In fact, if a filter does not reduce the size of the dataset by 1/10 or more, it is actually worse to add to the context filter because of the performance cost of computing the context. Next, remember to complete all of your data modeling before creating a context. Changes in the data model, such as converting dimensions to measures, will require recomputing the context, which again will slow down the performance of the view. Next is to set the necessary filters for the context and create the context before adding the fields to the other shelves. Doing this work first makes the queries much faster that are run when you drop the fields on other shelves. And finally, if you want to set a context filter on a date, you can use continuous date. However, if you're using date bins like year of date or context filters on discrete dates, these are usually very effective. Now understand that if your data is heavily indexed, context filters may not provide the best performance improvement and may actually cause slower query performance. Context filters can adversely affect any query performance improvements when you use the Assume Referential Integrity option in the data menu of the data source. Now that we got a knowledge overdose, let's go back to our demo machine and look at how we can modify a context filter. Now there are 2 ways in which you are going to modify your context filter. One of them is if you want to edit the filter and second one if you want to remove it. But both of them are done exactly the same way. Now it's fairly simple. All you have to do is go to the filter shelf, check your context filter, which is in gray. You're going to click on this little drop down arrow right here on the right
and there you get a drop down menu where you have options such as edit filter, show filter, clear filter, remove from context, so on and so forth. Now if I go on edit filter, here instead of furniture I can choose office supplies, and on applying you can see it basically edits my context filter. Okay. Now the second thing is removing from context. In such a scenario, the filter remains on the shelf as a standard filter, and if there comes a situation where other context filters remain on the shelf, a new context is computed. But this category no longer is a context filter, it's a simple filter. And finally, you can remove the field completely from the filter shelf by again clicking on the same arrow and then clearing the filter. Yes? With that, you know all the three ways in which you can modify a context filter. So what are table calculations in Tableau? Table calculations are basically this special type of field that computes on local data. They are transformations you apply to values in a visualization. They're calculated based on what is currently in the visualization and do not consider any measures or dimensions that are filtered out of the visualization. You can use your table calculations to transform values, including but not limited to rankings, running totals, and percentage of total. Now, for all charts in Tableau, there is a virtual table that is determined by certain dimensions in the view. This table is not the same as the tables in your data source. Specifically, the virtual table is determined by the dimensions within the level of detail in a Tableau worksheet. Now that you know what table calculations are, let's move on to the fundamentals of table calculations. Now, when you add a table calculation, you must use all the dimensions in the level of detail, either for partitioning or scoping, or for addressing or direction. Now, to do so, you need to understand what partitioning fields are. Now, the dimensions that define the scope of data it is performed on are called partitioning fields. The table calculation is performed separately within each partition. Now, partitioning fields break the view up into multiple subviews or subtables, and then the table calculation is applied to the marks within each such partition. Now, the remaining dimensions upon which the table calculation is performed are called addressing fields. These determine the direction of the calculation. Now, the direction of the calculation is slightly tricky to understand, which we shall also cover in the later part of this tutorial. Basically, the direction in which the calculation moves, for example, in calculating a running sum, that direction is determined by addressing fields. So when you order the fields in the specific dimension section of the table calculation dialog box from top to bottom, you are specifying the direction in which the calculation moves through various marks in the partition. Basically, you add a table calculation using the compute using option, and Tableau identifies these dimensions automatically as a result of your selections. But when you want to determine which dimensions are for addressing and which are for partitioning, you need to use specific dimensions. Now, if the whole table calculation and the direction in which your calculation moves part has confused you a little, I know for sure it confused me for the first time, the next segment is going to clear that section out. So let's understand how does computation work in table calculations. First of all, there are a couple of different directions in which these calculation moves, starting out with across table. In this particular table, the calculation moves across the length of the table and then restarts after every partition. In the table that you see in front of you, the calculation is computed across columns, year order date, and for every row, which is the month order date. Next is similar, but it goes downwards. We have table down. Now, this particular calculation moves down the length of the table and restarts after every partition. In the table that you see in front of you, again with the same measures and dimensions, the calculation is being computed down the rows for every column. Next, we have across then down. It's as the name suggests, this table calculation happens across the length of the table and then down the length of the table. If you see the table in front of you, calculation is being computed across the year column and then down a row, and then across the columns again for the entire table. Here your partition is basically your entire table. Similar, we have down then across, where you might have guessed it, the calculation goes down the length of the table and then across the length of the table, as you can see in the table in front of you. Then you have something known as a pane, and here the calculation goes down an entire pane. In the table in front of you, for example, the calculation is computed down the month rows for a single pane. Then again, even in panes, we have something known as across and down, and here it goes across the entire pane and then down the pane. The likes of which you see in the table in front of you, the calculation is computed across the year column for the length of the pane and then down the month row and then across the column for the length of the pane again. The same thing you have with down then across. Here the calculation goes down an entire pane and then across the pane, like you see in the table in front of you. I don't think that requires much explanation, as I've done it around a couple of times before. Then you have one which goes within a single cell, not very difficult to understand. You can see the calculation, the orange box surrounding one cell only. Apart from that, you also have a few wildcards. One of them is specific dimensions. Here the calculation occurs only within the dimensions you specify. In the visualization that you see in front of you, the dimensions month of order date and quarter of order date are the addressing fields, and we have selected them. And the year of order date is the partitioning field since it is not selected. So the calculation transforms the difference from each month across all quarters within a year, and then the calculation starts over for every year. Also, if all the dimensions are selected, then you can understand that the entire table is in scope. Apart from this, you also have the add the level option, which is only available when you select specific dimensions in the table calculations dialog box. And when more than one dimension is selected in the field immediately below the compute using options. Basically, this is the option you get when more than one dimension is defined as an addressing field. With that, let's move on to building, editing, and removing a table calculation in Tableau. For that, we'll have to go on to our demo machine, which is the Tableau desktop app. Here we have our Tableau public desktop app. It's a great way if you're just, dabbling into various BI tools and you don't want to invest in something already. This is also a great tool to learn how to use Tableau, as this has a capacity of computing on 1 million rows, which is not all that bad for a free application. So let's get building a table calculation. So I have already opened the Tableau desktop and connected to the sample superstore. The dimensions and measures to which you can see on my left or on your left, and I'm already on a new sheet. Now this sample superstore is available to you if you download any version of Tableau desktop. Apart from this, you also have a dataset known as global indicators. You can try this with that as well. In the data pane under dimensions, what I'm going to start out with is I'm going to drag order date to the row shelf. All right. As soon as I dragged order date into the row shelf, you might have seen it automatically updated to the year of order date. On the row shelf next, I'm going to right click on this and select quarter. On the same shelf, I'm going to click on this plus icon over here on quarter of order date, and the month of order date is added on its own. Now from under the dimensions, again, I'm going to drag order date to the column shelf. Okay, let's do that. The dimension automatically updates to the year of order date as it had done before. Now we're going to go to measures and drag, let's see, sales to this text marks card over here. And now your screen should look like mine right now. You have your rows and columns of quarter versus year of order date. Now step 2 is adding the table calculation. Now on this marks card that you see right here, I'm going to right click on the sum of sales and select add table calculation, which will be an option at the bottom right here. Something like this is going to appear on your screen. This is the table calculation dialog box. For calculation type, I'm going to select difference from, which is already selected by default. For compute using, I'm going to select table across. And when finished, I'm going to exit the dialog box and check my work. Now what I can do is I can go around from every year to every quarter, and I can see the difference in sales from the previous along the table. So congratulations, you've built your very first table calculation on Tableau. Now basically, to edit a table calculation, we are going to right click here. This is the measure in the view which the table calculation is applied to, and select edit table calculation. Here I can change the calculation type to difference from to percentage difference from, and then compute using across, and then close it. And as you can see, instead of difference in sales from previous year, right now I get percentage difference in sales from the previous year. And all of these numbers have turned into percentages. You can make as many changes or as few changes as you like. Feel free to play along, because that is how you're going to learn how to use this tool. Now, to remove a table calculation is pretty simple. Basically, again, we are going to right click on this measure. This is the measure again to remind you. This is the measure in the view which the table calculation is applied to. And then we can select clear table calculation. Here, this option. This removes the table calculation from the measure, and the visualization updates with its original values. So click on it, and it's back to where we started from. Here, see? No difference in sales, no percentage difference in sales, no nothing. Also, the little triangle right here on the right that you can just go back 5 seconds and notice, which is a sign of having a table calculation, is gone.
So what are sets in Tableau? So Tableau sets are basically custom fields which are used to hold the subset of data based on a given condition. In real time, you can create a set by selecting members from the list or from a visualization. You can also do the same by writing custom conditions or selecting top or bottom few records in a measure. So basically, a Tableau set is a field which holds certain parts of your data to which you can apply a certain condition. Simple? Now there are two kinds of sets that you can create in Tableau. Number one is a dynamic set. Now the members of a dynamic set change when the underlying data changes. It basically updates automatically. So dynamic sets can only be based off of a single dimension. Now apart from that, you also have your fixed sets. Now the members of a fixed set do not change. A fixed set can be based on a single dimension or a multiple dimension. Since it is not going to update on its own, you can have multiple dependencies in this situation. Now that you know just enough to begin with sets in Tableau, let's move on to our Tableau desktop so you can understand how to use these things better. Alright, so now in front of me I have opened the Tableau desktop. This is the Tableau public workbook, which is pretty much like your Tableau desktop except for it's free. Now, I have already connected it to the sample superstore, which you have access to if you have Tableau desktop or Tableau public desktop. So to create a dynamic set, which is the first one I'm going to create, I'm going to navigate to the data pane, which is here on the left hand side of your screen. And there I'm going to select a particular field. In my case, I'm choosing country or region. I'm going to right click on it, go to create, and it extends to a couple of options like calculated field, group, set, and parameter. I'm going to select set. It's going to take a while. Now, in front of me and in front of you, those of you who are following, you will find something called the create set dialog box. This is the dialog box and how it looks like. Now you can basically configure your set. So you can configure your set using a few tabs. You can use the general tab, which we are on right now, to select one or more values that will be considered when you are computing the set. Alternatively, you can also select the use all option, which is right here at the bottom, to always consider all the members even when new members are added or removed. So I'm going to go ahead and select all. Now we can move ahead to the condition tab. Here we can define rules that determine what members to include in our set. For example, you might specify a condition that is based on the total sales that only includes categories with sales of over $100,000. So I'm going to go to sales, and then sum is already selected, and let's say $100,000. Now you need to understand that set conditions work the same as filter conditions. So we can also make use of the top tab here. Now this tab we are using to define the limits on what members to include in the set. So for example, you might specify a limit that is based on the total sales that only includes the top 5 products based on their sales. So again, I'm going to go select by field, select sales, and by default it says top 10. Let me go ahead and change it to top 5. Now when you're finished, you can go ahead and click OK. Now in the bottom here, you can see the new set is added. It's here at the bottom of the data pane under the sets section. Now a set icon looks something like this, which is two intersecting bubbles. And now you've created a set. Now this was all about creating a dynamic set. What about fixed sets? So for that, we need a visualization. So what I'm going to do right now is I'm going to drag the measure profit up to columns, and I'm going to drag, say, sales to the rows. Then I'm going to go to profit ratio and bring that to the marks card, add color, then okay. Now that we've created a visualization, we can select one or more marks. You can see all these orange and blue marks. We can select one or more of these marks or headers in the view. So basically what I'm going to do is I'm just going to select a couple of these marks, yes. And then I am going to right click on one of these marks and select to create set, which is the last option here. So here I can see my categories and my subcategories. There are 13 members in total. What I'm going to do is I'm going to add to filters shelf to automatically move the set to the filters shelf once it's created. And when finished, I can click on OK. Now optionally what I could do is, by default the set includes all the members listed in the dialog box. So basically I can go ahead and select the number of categories or subcategories that I can exclude. So when we exclude, the set will include all the members that I didn't select. You can also remove any dimensions that you don't want to be considered. So if suppose there is art, I don't want it to be considered, I'm going to just remove it. Binders I'm going to remove, and things like that. When you hover over it, you will definitely get this red cross or the remove option. Now also, if the marks that we've selected represent multiple dimensions, each member of the set will be a combination of those dimensions. So you can specify the character that separates the dimension values, and to do that you can do so by separate members by here and enter the character of your choice. Like the example given here is furniture, chairs, which you can also see here. So when you've finished all of this, you can go ahead and click OK. And here you can see only the categories that you had selected. Now what you need to note is that if you created a set using specific data points, you can add more data to or subtract data from the set using the tooltip that appears. All you have to do is click the Sets drop-down icon and select the Add or Remove option. So basically, I hover on top of this spot, and then you see options such as Keep Only, Exclude, and here is the Sets icon. And then you can add to set to or remove from set to. Yes? And after you create a set, you can see it at the bottom of the data pane of the set section like we saw for the previous one. Here, you can drag it into any visualization that you would like in any other field. So after you create a set, you can see it at the bottom of the data pane in the set section right here. And how you basically use it in a visualization is pretty simple. So here I can see the set. I can just drag it into the visualization and see it has worked. Or I can drag it to the filters. Then I can see the bubbles which are included in set 2. And when I remove it from the filters, I can see my original visualization again. If I select in and then keep only, you can only see the ones which are in set 2. And if I select out, which are the ones in square, I can see only the bubbles out of set 2. Basically, what I wanted to show is that when you drag a set to a visualization into Tableau Desktop, you can choose to show the members of the set or aggregate the members into in or out categories. In Tableau Server, one can only aggregate the members of the set into in or out categories. You can use set actions to give your audience more control over their analysis of your visualization, and that is the purpose of sets. With that, let's move on to something known as set actions. Now, what are set actions? Set actions basically take an existing set and update the values contained in that set based on a user's action in the visualization. So basically, as an author, you can use a set or multiple sets that you have already created to define the scope of a set action. You can use set actions to let your audience interact directly with your visualization, even your dashboard. It gives them more control over the aspects of their analysis. Now you can define the set action to include any of these. First, the source sheet or sheets it applies to, the user behavior that runs the action, basically how you hover, select, or menu, the target set, the data source, and the set that has to be used. And finally, what happens when the selection is cleared. Now, these are the 4 things that you can define the set action to include. With that, let's go back to our Tableau desktop to see how to create set actions. Now, to create a set action, first we are going to go to a worksheet, the option here up top, and select actions. For this, we can also use the keyboard shortcut Ctrl Shift and A. Then you'll be met with this dialog box, which is the actions dialog box. Here we are going to go ahead and click add action and then select change set values, which is the last option. Now, what you're going to do is that you're going to specify a meaningful name for the action in the add or edit section. So I'm going to name it set action demo. Now we're going to select a source sheet or a data source. The current sheet is selected by default. So here, sheet 1 is the one which is selected by default. If you can select a data source or a dashboard, you can select individual sheets in it. So I'm going to go and select sample superstore, and the one sheet I've made is the one sheet that has been selected. Then you can select how your users will run the action. You have 3 options as I had mentioned before. Hover, the first one, runs when a user hovers the mouse cursor over a mark in the view. Select runs when your user clicks a mark in the view, and this option works well for set actions in my opinion. Finally, you have menu, which runs when a user right-clicks a selected mark in the view and then selects an option on the context menu. So I'm just going to select because, again, as I said, in my opinion, this works well for me. You can go ahead and select hover or menu depending on your choice, and as you keep using sets more and more in Tableau, you will definitely reach a point where you have favorites. Then you have to specify target set. Here by default it is the sample superstore because that is the one that I've selected. Then I'm going to go ahead and select the set. So I'm going to select set 1. Now, the sets available in the target set lists are determined by the data source that you select and the sets that you have created in the workbook. Now, these are the sets which are associated with that data source. In this example, I'm using set 1, which was the first set that I created. Then you're going to go ahead and specify what happens when the selection is cleared in the view. You can do it by clicking on any of these bubbles on the right. First one is keep set values, which basically makes the current values in the set remain in the set. Then you have add all values to the set, which adds all the possible values to the set. And finally, remove all the values from the set, which removes previously selected values from the set. I'm going to select keep set values and click on OK. This is going to save my changes and return to the view. After this point, you can test your set action by interacting with the visualization. You can tweak some of the settings for the action to adjust the behavior as needed. A few ways in which you can do it is by proportional brushing, asymmetrical drill downs, color scaling, relative dates, so on and so forth. Next, let's move on to how to combine sets. Now, combining sets allows you to answer complex questions and compare cohorts to your data. You can combine two sets to compare the members, and when you combine sets, you basically create a new set containing either the combination of all members, just the members that exist in both, or members that exist in one but not the other. One thing you need to understand is that to combine two sets, they must be based on the same dimension. This means you can combine a set containing top customers with another set containing top customers from last year. But you cannot combine top customers set with a top product set. Is that clear? So let's go back to our demo machine and let's create another set. So I'm going to duplicate this set and then probably edit that set. Now to combine these sets in the data pane under sets, we select the two sets that we want to combine. Now we're going to right click on the sets and select create combined set, which is the fourth option from the top. And now you will be met with this create set dialog box. So we are going to type a name. Let's name it combined set. Here we have verified the two sets, which is basically one duplicated the other. Now basically, since one is a duplicate of the other, no matter what I share, it is going to be the same result. But still, let's select one of the options for how to combine sets. So the first one is all members in both sets, which basically enables the combined set to contain all the members from both the sets. Now by default, that is the one that is selected. Then you have shared members in both sets, which is the intersection of both the sets. So it enables the combined set to only contain members that exist in both the sets. Now, both of these have an accept shared members option, which basically enables the combined set to contain all members from the specified set that don't exist in the other set. These options are equivalent to subtracting one set from the other. So I'm going to take one of these in random. Optionally, you can also specify a character that will separate the members if the sets represent multiple dimensions. Again, this block, and when finished, you can click on OK. And here you can see the combined set in the sets pane. Okay, with that, let's move on to the applications of Tableau sets. Now, there are many ways in which you can use sets to answer complex questions and compare cohorts of data. A few of these questions of yours I'm going to answer in my presentation. First, how do members of a set contribute to total? Now, you may have all kinds of questions surrounding how the members in a set contribute to the overall total. For example, what percentage of total sales come from repeat customers? You can answer these types of questions by using in or out mode for the set. Next, you can also answer how many members of a set exist in another set. This is another very common use of sets, basically to compare subsets of data of cohorts. If you wonder how many customers that purchased last year also purchased this year, or if a customer purchased a specific product, what other products did they buy? You can answer these types of questions by creating multiple sets and then combining them. You can also use hierarchical set filters to the selected members of all their descendants. Now, they are unique to the multidimensional or cube data sources and are defined within the data source prior to connecting to Tableau Desktop. Now, when you create sets in Tableau from a cube data source, descendants and any hierarchical structures are automatically included within the selected members. Sets are dynamic and useful elements for you to add interactivity and flexibility to your report. It is a versatile weapon in your arsenal and can be used very well in calculations and visualizations.
So what is a Pareto chart? A Pareto chart is basically a dual axis combination chart in Tableau. On its primary axis, as you can see, bars are used to show basic raw quantities for each dimension, usually sorted in a descending order on a secondary axis. A line graph is then used to show the cumulative total in a running percentage format. Now, while this chart type serves a variety of purposes, it is most known for being a part of the 7 basic tools of quality control. That is where it majorly dominates. It is traditionally used to identify the biggest opportunities for improvement. Now that we know what it does, let's go ahead and see how it does it. So for that, we are going to go straight to our Tableau desktop. I'm going to be sticking with the quality control scenario, and this session will be using the sample superstore, which is already available to you on your Tableau desktop. We shall use the dataset to look at which product subcategories contribute the most returned items. But before we begin, I'm on this page and I have imported the data. But before we begin, first of all, this tutorial requires 2 additional steps to prepare the data. First, we need to left join the returns table to the orders table. So let's go ahead and do that. I'm going to drag the orders table and the returns table as well. Here I'm going to click on this icon and select left join. And then I'm going to go ahead and close it. Next, what we're going to do is we're going to go straight to our sheet, all right, and create a calculated field to count the number of returns, all right. So we're going to go to analysis on the main title bar and select create calculated field. Let's name this returns, which will be true to its purpose. And we're going to use a function known as count. Here we're going to count the returned subcategories. And now it shows us at the bottom that our calculation is valid. So now we are all set to build a Pareto chart. Now you can see that our returns measure is available in the measures pane. We're going to first start by creating a bar chart that looks at the number of returns per product subcategory, and then we are going to sort it in descending order. So I'm going to bring the subcategory to the columns and return to the rows. And then I'm going to sort it in a descending order. Next, what I'm going to do is go ahead and create a dual axis combination chart, which I'm going to do in my rows. For that, I'm going to drag the returns measure again to my rows shelf, bring it over here, and click on the drop down button and select dual axis. I'm also going to go on the left and select bar chart. And for the next, I'm going to change the mark type again from automatic to a line chart. I'm also going to go ahead and change the color to orange so that it is more visible. At this point, your visualization will look something like the one you see on the screen. I'm also going to go and change the color of the bar chart to something deeper for visibility purposes. Okay. Yeah, this color looks good. Okay. Now the step that makes a Pareto chart is basically adding a table calculation and a secondary table calculation to this returns bill. This shall display the cumulative percentage of returns across products in different subcategories. Now, to do that, first, upon right-clicking on the second pill, we get quick table calculation option, and I'm going to choose running total. At this point, your chart should look something like this. Now, with the table calculation for running total, you can add a second table calculation to the result, and that is how we are going to be calculating the raw running total number for each product subcategory. And then we'll add a secondary calculation to determine the cumulative percent total. Now, for addition of a second table, I'm going to go back to the returns bill, go to edit table calculation, and check this box in the bottom which says add secondary calculation. Okay. I'm just going to move it a little bit to the center. Okay. Now this is my secondary calculation type, and here I'm going to switch it from difference from to percentage of total, percent of total. All right. At this point, if I move this dialog box, your graph should look something like this. This is basically the cumulative percent of total. Okay. Now after changing the axis tick marks for a cleaner look, you will be left with this following visualization that you see in front of you. It wasn't that difficult, was it? You know for a fact now by hovering over this, you'll get your subcategory, the percentage of total running sum of returns, and the total number of returns per subcategory. So as we can see right now, 17% of all binders come back, which is terrible for a company and will bring a lot of loss for a company dealing with office supplies. Now, this Pareto chart in Tableau can now be used for drawing insights such as the business's 3 most returned product subcategories, causing about 40% of the total returns, which you can see are binders, papers, and phones. Pareto charts are usually a very effective way to quickly highlight potential for improvement and give enterprises a scale for how urgently a quality control problem should be treated. So what is a donut chart? Now to understand what a donut chart is, we need to first know about its predecessor, the pie chart. So what is a pie chart? Now a pie chart is a circular statistical graph or visualization that is divided into slices, basically to illustrate numerical proportion. As you can look at it, it looks pretty much like a pie that's been cut into separate sections, unequally though. Now in a pie chart, the arc length of each slice is proportional to the quantity it represents. But there's a little bit of a problem. Now, pie charts are often criticized for attracting too much focus of its viewers on the proportion of the areas of the slices. Now, this obviously incites comparison of one slice to another, and then ultimately the comparison of one slice to the chart as a whole. Now, this makes it very tricky to see the differences between slices, especially when you try to compare multiple pie charts together. Now we need a chart which somehow remedies this problem by de-emphasizing the use of this area. Behold the donut chart. Now a donut chart somehow remedies this problem, and again it de-emphasizes the use of that area. A donut chart is essentially a pie chart that you saw previously, except for it has a hole in the center, or the central area has been cut out. A donut chart basically invites the readers to focus on reading the length of the arcs rather than comparing the portion sizes between the slices. Also, this chart is more space efficient than a pie chart because you can pretty much use the central hole to fill in with data or information if you like. But what we need to understand about the donut chart, or rather both of these charts, is what brings about this stark difference in performance. In one word, the answer is perception. So let's go ahead and discover what is the difference between a pie chart and a donut chart. To make it easier for you all, I'll switch to my demo machine, which is the Tableau desktop app. If you want to look at a tutorial solely concerning the Tableau desktop app, we have a bunch of them on our playlist and a particular tutorial video if you like. I'd happily link that in the description box below as well. So moving on. You've probably all seen a pie chart before. It's a big circle cut into pieces, can't really miss it. We saw it a few minutes ago in our first section. And a donut chart, as we also just saw, is essentially the same thing except for that it has somewhat a smaller circular cutout in the middle. So it turns this very filled heavy pie into a somewhat hollow donut. But I've decided to make it easier for you all, and here's a side-by-side image of them both. Now there may seem like a fairly minor difference between the two, but something important happens upon this timbit removal that illuminates the complexities of the human brain and the visual perception. And my main intention of this session is mainly to make you guys understand what goes on in the human brain to perceive these two so differently. So let's go ahead and look at a pie chart first. So this is a pie chart. Now first, when you guys looked at it, notice how you did. Chances are your eyes directly went to the center of this pie chart, at least at first. Now, because pie charts are filled in, you view them as a whole. You see the circle and judge the pieces according to its areas. It's pretty simple. And then there is this donut chart. Now, because donut charts are hollowed out, there is no central point to attract your attention. So where do your eyes go instead? I'd like to leave your answers in the comments. Okay. So if you're like most people, at least I'm like most people, I'm pretty ordinary, your eyes travel around the circumference and judge each piece according to its length. As a result, you can also think that a donut chart is almost like being a stacked bar chart which has been curled around itself. Can't visualize it? Let me help you. Here is a stacked bar chart, which is the corresponding chart to the previous donut chart you just saw. Now can you picturize it? Very well then. So why does it matter whether you read something by area or by length? Well, our brains process these two properties very differently, and we as humans are only good at one of them. So humans are exceptionally good at judging linear distances. Let's take an example. If you want to throw something at a tree in a distance, okay? I don't know why you're doing that. Maybe you're anti-green, but let's just take that example. If you want to throw something at a tree in a distance, the gray matter in your brain, which is the part of your brain which processes information, will run all the calculations to get the right trajectory and fulfill this weird anti-tree vendetta agenda of yours. You can easily tell if something is taller, wider, longer, or shorter. Basically, what I'm trying to say is single dimension comparisons are pretty straightforward. Now, areas to human brains aren't so easy. Unless the difference is blatantly obvious, it may take you a moment to compare objects of different sizes. And if you're anything like me, you'll cheat and use the linear distances anyway. Because what I do is I check the height and width and estimate the rest. So when a reader sees a circle subdivided into sections, they are going to want to compare section sizes anyways. Even if a comparison isn't your goal and it has got nothing to do with the graph's core message, comparing sizes is sort of like an automated reaction when you see a pie chart. So what is it that the donut chart has to offer? Simplistically, two things: clarity and spatial efficiency. Okay, consider this particular donut chart. Now, pie chart actually offer three separate options. You compare ratio of angles, ratio of areas of each wedge or slice, or at least you can use the length of the outer circumference. Now, the donut chart only offers the last one. Though it gives you both an inner and outer edge to work with, it basically only gives you the length of the outer circumference or the arc to utilize as your record size. Now, this particular complexity of the pie chart is rarely a benefit. A typical audience will contain individuals who will prefer each of the three methods. This makes the distortion of a pie chart far more common than people realize. Now, people who prefer pie chart over donut chart often do so because pie chart offers more stylization. You can make a pie 3D, you can tilt it, you can explode it, you can fill it with interesting patterns or skins. You can even make different shapes out of it. But all of these options will mostly just distort your graph. At least a portion of your audience will not be able to understand it. Now, I'm not saying that a donut chart cannot get distorted. It is just much easier to avoid in the case of a donut chart. So as long as the edge lengths remain fixed, which basically means you're not getting a tilted view of the chart, the graph should remain very true to its data. Now, the second point I had to come to was spatial efficiency. Now, for fans of Edward Tufte, this is a major theme of what he writes. Tufte rails most against wasted ink. Then there's too much white space. But both can be issues. Filling a page with meaningless color creates clutter and slows down comprehension. While white space that is not purposely put there in your graph is equally troubling. Now, the pie chart suffers greatly from the first problem. By definition, there is nothing you can do about it. Any effort to limit that extra ink will only leave you with a donut chart instead. But the donut chart suffers from the latter. So why trade too much ink for too little? The answer is focus. The white space of a donut chart draws the eyes of the audience. As we mentioned before, it is always the center of the circle where you look at first. So use that space. That space is perfect for a total, a lift comparison, or a trend arrow. Honestly, in my opinion, you should be able to cleanly fit all three as I've done in this chart in front of you. Now that we know why you need to use a donut chart, let's move on to our Tableau desktop and see how you can build one. So I'm basically aiming to recreate this particular donut chart, which is based upon the categories of products of the superstore and the number of sales made by each product. Now, as I've just mentioned, I'll be using the sample superstore provided by the Tableau service to be creating this particular graph. So now let's start by opening up a new sheet. As you can see, this is the sheet 25. Now, while there may be many ways to create a donut chart, this method is my favorite because it is more efficient and it is more goof proof. So let's start with this marks card. This particular card here is known as the marks card. What I'm going to do is I'm going to select pie chart here because again, pie chart is the predecessor of the donut chart. We are going to start out with a pie chart. Then we're going to select the category and bring it to color. As you can see, there's a different color for office supplies, technology, and furniture. And the legend is here on the right. The legend is here on the right. And there are the three colors right here. And I used this card from the marks card to make sure that each category is represented in a different color. You can also go ahead and change the colors if you like, but I'm pretty fine with these as it does not hamper the visibility of any of the categories. Okay, next I'm going to take the sales, the number of sales, and I'm going to put it on two things. First is the size. So basically, the bigger the size of the sector, the more the number of sales. The next thing I'm going to put it on is the label. So now you can see an exact number that is represented by each of these sections. So what I'm going to do is I'm going to make this slightly bigger, a little bigger, and I'm going to bring this to the center for better visibility. Let me just resize it so you guys have a better view. Okay, done. Okay, so now that I have done this, I have already made my pie chart. Now let's start turning it into a donut chart. So I'm going to go to this measures column and pick out number of records. This is basically the total number of records that there is. And from sums, I am going to pick I'm going to change the measure to minimum. Now I'm going to do that one more time for the inner circumference of my donut chart. So I take this, drag it to rows, and again select minimum. Now as you can see, we have two different pie charts. Let me just reduce. Okay, now it's really big, so let me just reduce the size of these. Yeah, well then. Now what I'm going to do is I'm going to pick this second green pill and I'm going to choose the dual axis option, as we are trying to merge both of these into one. And if you look properly into the marks card, you can see that there are two sections for both of these pie charts. Right now they're overlapped on top of each other, but here you can see there is a section called minimum number of records, that is the first one, and then you have minimum number of records in bracket 2, which is the second one. So I'm going to go to this second section and I am going to remove all of these pills from here. And then I'm going to go to size and reduce it. Not very good at this, pardon me. And then I'm going to go to color and select white to match the background. It's at full opacity. And here you have a donut chart. Finally, I'm just going to go up here and I am going to uncheck this show header option. All right, now you have your donut chart. Now try and understand this. Visualization is perceived more like a science, but visualization is an art. Honestly, this is not an opinion piece of mine. Really, my opinion on pie charts and donut charts shouldn't matter to anyone. Too many reports and visualizations are already built on opinion and subsequently are quite flawed. That is not to say that nobody's opinion or the opinion of the audience is not important. Visualization is an art and the only limitation to this is your mind. So with that, let's go back to our presentation where we can discuss a few drawbacks that are there in donut charts as well. Now, as I mentioned, donut charts have their drawbacks, of course. Now, while they are easy to read, they're still not the greatest for comparisons within the same graph. And if I might say, they're downright terrible for comparisons with two different graphs. Now here, I was trying to show a daily percentage of something. I can't tell you what for privacy reasons. And it increased after the October break. I thought I'd be all avant-garde and go nuts with these donuts. That was a bad pun, I'm really sorry. And this was a really bad decision. The one thing this monstrosity does do well, though, I have to give it credit, is illustrate how hard it is to compare between donuts. For example, let me pick out a handy spotlight here. Can you tell me, as the audience, if you look closer, which one of the blue segments is larger? Is it 11:15 or 11:16? These two I'm talking about. Is this larger or is this larger? Well, unless and until you have like a 30/20 vision, it is really hard to tell. So what could I have done with this data instead? Well, since I wanted a before and after comparison, I could have easily used a bar graph. This bar graph makes it much easier to see how dramatically the percentages rose after the October break. Of course, the graph here still invites the reader to look at each date individually. So if I add two annotations for the before and after averages to draw the attention to the changing trend, the individual bars can still be a little distracting. If I instead wanted the readers to focus only on the change in averages, I could have just done a simple bar graph. This so easily compares the two numbers. Simple yet effective. Now you can see the pre-break average and the post-break average. It isn't flashy, but it gets right to the point. It would have been the most efficient, effective way for me to convey my message. So let's just take this oath to, I don't know, live and learn and cringe at our past faults, I guess. Now, to compensate for this deficiency, I usually prefer to use charts like this, which is a single pie or a donut in a complete set, where your audience is only looking at it for a quick visual, for information distribution. But the lone chart will never be able to convey a depth of information that is very actionable or very satisfying. Let me explain to you on Tableau. Now, to compensate for this deficiency, I prefer to use these charts in sets. A single pie or a donut chart may be all you need when your audience is only looking for a quick visual distribution. But that as a lone chart will not be able to convey a depth of information that is very actionable or satisfying. A set or a cluster of charts like the one you see in front of you, this is a dashboard with the executive overview profitability in all states of America, basically will help you compare and contrast changes. It effectively adds an additional dimension to your graphic. This could be across time, population, sales, and so on. It will also allow you better leverage the legend, in which case you will need just one legend, and then you can use this particular graph to cross-highlight other graphs. Now that is a great feature for this particular graph. The color palette will now serve as a connector as well to other graphs. And for the donut, you can exploit multiple central focus points to convey a message or call out important information. And this is where a donut chart looks best. Now, I hate to write off an entire category of graph, but more often than not, donut is a better option than a pie. When a reader sees a circle subdivided into sections, they're going to want to compare section sizes, even if the comparison isn't your goal. If you do want your reader to compare segments, other types of graphs are a much better option. To be honest, you can talk about your stack bar graphs or your donut charts, and if you don't want the comparison, these round charts make the wrong choice anyway. Aside from stylistic reasons, I can't really think of a good reason to use the pie chart instead of a donut chart. Can you now? If you can, let me know in the comments section below. Which one do you prefer, the pie chart or the donut chart, and why?
When we should use calculated fields. So you can use calculated fields to create a new data from an existing data in your data source. When you construct a calculated field in your data source, you're essentially adding a new field whose values or members are determined by a calculation that you control. This new calculated field will be saved to your Tableau data source and can be used to build more complex visualizations. But don't worry, your original information is going to be saved. So calculated fields can be used for a variety of purposes. Here's a few examples, like to easily segregate your data in new ways, to test a notion such as a new dimension or metric before making it as a permanent field to the underlying data. Other than that, it can also help you aggregate the data using aggregation formulas, exclude unnecessary data in order to conduct more thorough analysis, to save database processing and storage resources by calculating ratios across several different variables in Tableau. So let's go ahead and understand with an example. So the manager of the store wants to know the region-wise sales data, which is not clear from the available data set, as we don't have a column for total sales. So as we can see the data, we can see that we don't have a column for total sales. Instead, we have per unit price and quantity of units sold. So now looking into the data and while visualization, we can see that we'll be needing another column called total sales, which will have the product of per unit price and quantity. But adding a new column in the data set and again importing the refresh data set can be cumbersome and time consuming. Also, it is going to change the raw data set. Rather, if we can make a new column in Tableau itself without making any changes in the raw data and add that in our visualization instead, it can ease our task. So for that, we have to use a calculated field in Tableau. So in calculated field, we can calculate any extra column or any extra calculation that we require. So here we need this total sales value, for which we need to multiply the per unit price with the quantity. So here we have named the calculated field as total sales and the calculation is the multiplication.
But you should get questions on how it was done on Tableau, right? For that, you need to stick around and we will get to learn how it is done as we get ahead in the session. But before that, let's understand what are calculated fields. So by definition, a calculated field does one of these two things. It either calculates database fields to produce a value that isn't directly recorded in the database, or it selects values in database fields based on some customized criteria. So now let us see how we calculated the total sales using calculated fields as we discussed in the example before. So for that, we need to go to Tableau. So here we have imported the global superstore data. But in this data, we don't have the total sales value. We have the per unit price, profit, and quantity. But we require the total sales value. For that, what we can do is multiply the quantity or the number of units sold with the per unit price. But how to do that? We can do that using calculated fields. So for using calculated fields, either we can go to this arrow where we have this create calculated fields, or we can also go to analysis and here we have create calculated field. Here we get this pop-out box where we can write the name of the calculation. So here we are calculating the total sales. So that's the name of the calculation. Now for the calculation, what we are doing is multiplying the per unit price with the quantity. Now we'll select OK and we can see there's a new field added in the measures list. So we'll drag the total sales and we need to see the total sales according to region. So from dimension, we'll choose region. And now we can get this bar chart which shows us the region-wise total sales. And now if we want to add labels according to the number of sales, we can just drag total sales to labels. And there we can see the labeled bars in our bar chart diagram. So that's an easy calculation with calculated fields in Tableau. Now we'll see the different types of calculated fields that are there. So there are mainly three types of calculations you can use to create calculated fields in Tableau. So the first one being basic calculations. Basic calculations are aggregate calculations where you can transform values or members at the data source level of detail. That is a row level calculation or at the visualization level of detail. Whereas in LOD expressions or level of detail expressions, on the other hand, can be carried out at a more granular level with syntaxes like include or a less granular level like exclude or a completely independent level like fixed. And the third one being table calculations. Here you can only transform values at the level of detail of the display using functions like window max, window sum, index, etc. Now let us get started with the next hands-on where we'll see different types of calculated fields. Since we do not live in a perfect world with a perfect data source, our data sources are often unfinished and disorganized. Or sometimes you need a few additional data points for better understanding of the data derived from logic or business ideas. So here comes the role of calculated fields. Calculated fields help you create new data points, or it helps you to clean existing data without making any changes in the original data. So here we will look into a few more examples of Tableau calculations. In our previous example, we used a basic row level calculation. Now we will see another example of the same. Row level calculation means that a value is going to be derived from every value in every row in the same data source. So in our data set, we have a customer ID, which starts with the initial of the customer name. Like we can see Rick Hansen, it starts with RH and then the ID. So we want a new column which will have only the ID. So for that, we can create a new calculated field called ID. So for that, we go to this drop-down arrow, create calculated fields, and we want to name it as ID as we are deriving the ID from the customer ID. So we'll use the split function, and for string, we are deriving it from customer ID. The delimiter, we have to write it within single quotations. So we are writing hyphen within single quotes. And for token number, we are writing 2 since we want the second part after the delimiter. So now let's press OK. Now we want to see the ID against each customer ID. So here we can see that we have the unique IDs without the initials of the customer name. So this is one way to use row level calculation, that is split. Next, we can see how to use
calculated fields for, so let's name this sheet as IT. Now let's make another sheet called average profit. So in our data set, we don't have a column for average profit, but we do have profit. So we want to see the category wise average profit. So we'll drag the profit here, but here we'll write average. So we can see the change in the chart. So if you open this calculated fields box, then here you can see all the different syntaxes available. So here you can also see the aggregate calculations where you have average or collect, count. You can count the number of sales. We also have calculations for different dates. Let's try using the logical calculation as well here. So let's have a new sheet called profitability. Let's make a new calculated field called profitable to know whether it is profitable or not. So for that, the profit has to be greater than 0. And if the profit is greater than 0, then profitable, else not profitable. And we end the syntax with end. Okay, now let's see for each order the profitability. So here we can see against each order if it's profitable or not. So this way you can keep adding new measures and new fields and new columns in the data set using calculated fields.
Why we use actions? Well, by using actions in Tableau, you bring interactivity in your data. Be it a dashboard or a worksheet, users are redirected to specific actions that you set up by merely hovering or clicking in your visualization. So let's take a use case scenario. Suppose we have 4 different worksheets or reports with 4 different visualization like sales data, profit data, revenue data, and demographic data. Now, if we want to see the changes in visualization for a particular parameter, suppose a specific state, then how do we do that? Like if you want to look into the sales, profit, revenue data based on one specific region, how would you do that? So without using actions, the first step would be to filter on each visualization, like to put filter on sales data, profit data, revenue data, and demographic data. So that way, when we put filter on sales data, we'll get the highlighted column for that specific region. And similarly for profit, revenue, and demographic data, we have to individually filter out that region and get the data for that specific region. But alternatively, in Tableau, if we can use actions, we can see the changes across all the visualizations for a particular selected parameter, which is region here we are talking about. So once we select a specific state in sales data, it would show us the highlighted data in all the chosen visualizations. So that's basically the purpose of using actions, where we can see the changes in visualization across all worksheets or in the dashboard for a particular selected parameter. Now let us quickly understand what are actions in Tableau by definition. So by definition, a dashboard action is an interactive element on a Tableau dashboard that is driven from the worksheets within that dashboard. So action basically adds context and interactivity to your data. Users can interact with your visualizations by selecting marks or hovering or clicking a menu, and the actions you set up can respond with navigation and changes in the view. So to talk about actions, there are different types of actions that we can see in Tableau. But mainly we use the first 3 to mention, which are filter, highlight, and go to URL. So in filter, what happens is we use the data from one view to filter that data in another view or in the dashboard to guide with the analysis. Next, when we talk about highlight, in highlight we highlight the marks of interest by coloring specific marks and dimming all the other factors. Next, in go to URL, you can create hyperlinks. So hyperlinks will take you to external sources such as web page or a file or another Tableau worksheet per se. So these 3 are widely used and are helpful in the visualizations. Other than that, we have 3 more actions, which are go to sheet, change parameter, and change set of values. So in Go-To Sheet, it simplifies the navigation to other workbooks and other dashboards or stories. While in Change Parameter, it lets the user change the parameter values by directly interacting with marks on a visualization. And lastly, in Change Set Values, it lets users change the values in a set by directly interacting with marks on a visualization. So we will get to learn about a few actions in hands-on. So for that, let us go to Tableau. Here we have imported the global superstore data. So this is how it's going to look. So we are taking month-wise profit, country-wise profit, and category-wise profit, and putting all the worksheets in a dashboard where we'll see the changes reflected according to the selected parameter. So let's start from scratch. We'll repeat the process by making a new worksheet. So let's see how we have made the first few worksheets and then understand how we can incorporate actions in them and then how we can visualize that in a dashboard. So first we will make a worksheet called month-wise profit. So for that we will drag the date, which is the order date here, to columns and select month from here from the drop down. Now since we want to look into the month-wise profit, we'll drag profit in rows. So this is how it looks. Now if you want to change colors, you can drag profit to color. Then by double clicking on colors, you can edit color. And I want to choose green for the profit. And I also want to add legends to profit. So I'll drag profit to label. And here we can see the data for each point. So this is giving us month-wise profit. Now let us make the country-wise profit. For that, let's name the sheet first as country-wise profit. Now what we have to do is drag profit to rows and countries to columns. So this is a plain bar chart, but we want to see it in a map. So I'll select the geo dimension here and we can see it on the map. So which countries have the highest profit, which has loss, which has less profit. We can see it in a map visualization. And if we want the legends, then here also we can add that by dragging profit to label. But this kind of looks a little clumsy, so I'll let it be. Next, let us make a sheet on category-wise profit. Category-wise profit. So here, same again, we drag profit to rows and categories to column. So there are 3 categories and we can see office technology. Now if you want, you can also add region to columns. This will give you a region-wise, category-wise profit. So here we can see that for each region, how it is showing. So we'll let this be. Now let us make a dashboard. For making a new dashboard, we can click here or we can go to dashboard and make a new dashboard. So now we have these visualizations. The first few were already made, so I'll rather choose the ones that we made now. So we have the month-wise profit, we'll have the country-wise profit and the category-wise. So let's enlarge the size of the sheet like this. So we have the month-wise profit, country-wise profit. Now we have to add the category-wise profit. We'll add it here. So this is our dashboard with month-wise profit, category-wise profit and country-wise profit. So we have dragged all the worksheets in here. So we go to worksheet and select actions. There's also a shortcut key which is Ctrl+Shift+A to get actions. Here we will select this workbook since we want to see the reflection on the dashboard and not this sheet specifically. So now we go to add action. We go to filter. Now here we can choose the name of the filter. Let's choose from here. So let's name it market analysis. And for run action, we have selected select. And there's an option like hover or menu, but we want to select from the visualization. And here we are choosing, we'll unselect all of them and select the source sheet as month-wise profit. Since these were already done, so it's showing twice. And now in month-wise profit, we will choose dashboard 2 and we want to see all values. So we'll select show all values. Now we'll press OK. So if we select April, this is showing us the April data for category-wise profit, country-wise profit, and even month-wise profit. So all we have to do is just go here and select a specific date or a specific point on the line diagram, and it can just show the change in data across all visualization. So similarly, when we go to country-wise profit and go to worksheet, actions, add action, filter, and here we will choose country-wise profit, select the target sheet as dashboard 2. So we want to see the changes across all visualizations. Now OK. So when we are selecting Russia, this is showing us the data for Russia in all the visualization. Similarly, if we want to create a highlight, now we go to worksheet, go to actions, add action. We want to use highlight. So let's add countries. We want it across all visualization, dashboard 2, country-wise profit, all fields, because we want it across all fields. Now press OK. So here, if we are selecting Russia, it's showing us the highlighted Russia. If we select Oceania, then it's showing us the highlighted Oceania in the visualization. So you can play around with actions using it in different ways across your worksheets. Next, we'll see the go to URL type. So here we go to action, go to URL. Now here they've asked for a hyperlink. So hyperlink is basically any link that can redirect you to a web page or another Tableau sheet or another Excel file or some file. So what we can do is we can add generalized web page link for an example. So let's take country details. Let's name it as country details. Here also let us select run action to be select. And now for the URL target, we are choosing a new browser tab. So for the URL, we'll select a generalized URL, which let us take it as a Wikipedia link. So we will copy this link and paste it here. So this is a generalized link. Now what we need to filter on is country. So from here we insert country. So whenever you're selecting one country, it is going to lead us to a web page of that specific country. So let's see how it's working. Now we press OK. Now let's go to our dashboard and select China. So when we select China, it's leading us to the web page of Wikipedia where we have the details of China. So similarly, you can make your own URL or you can make your own page and give the URL of that specific page or even a Tableau worksheet if you want. So that's about actions that we usually use. There are more actions, but those are not used at a daily level. I think this would help you get an overall idea of how actions work in Tableau.
Now let us discuss BI analyst interview questions and answers. As already mentioned, they are divided into two categories, general questions and technical questions. First, let's have a look at the general questions that you may be asked. For example, you may be asked about your experience in business intelligence. Here, you should talk about your educational specialization if it is related to BI, your expertise in it, your career experience with it, and if so, you mention the field of business intelligence in which you specialize. Then describe briefly your career journey. Also remember to show a keen interest in the company's business sphere. Then you may be asked about your opinion on agile software development for BI projects. Firstly, you should define agile. Agile software development refers to the software development methodologies that involve iterative development, where requirements and solutions evolve through collaboration between self-organizing cross-functional teams. It advocates adaptive planning, evolutionary development, early delivery, and continual improvement. The benefits of Agile are that it is more collaborative, saves on time, and since the teams directly work with the client, it provides a clear outcome in an incremental way. So it is being preferred these days. But many companies still prefer using waterfall methodology, especially for projects with concrete timelines and well-defined deliverables. If you have worked in Agile, talk about your experience. Then you may be asked about your experience in SDLC. SDLC refers to Software Development Lifecycle. You should define SDLC. Software Development Lifecycle is the process used by the software industry to design, develop, and test high-quality software. It consists of a detailed plan describing how to develop, maintain, replace, and alter or enhance your specific software. You should talk about your experience in SDLC. If you don't have experience in it, you can talk about your interest in working more with it. Now, let's have a look at some examples of technical questions that you may be asked. The first, you may be asked to define business intelligence. Business intelligence is the field that aims to extract meaningful and useful insights from data. BI analysts analyze data sets and represent their insights in the form of reports, graphs, maps, summaries, cards, and other such formats. They help make strategic and tactical business decisions. Next, you may be asked about uses of business intelligence. The uses of business intelligence include that it helps improve decision making by gathering insights. It helps in studying market trends. It helps spot weak points in business operations, and it helps improve the internal efficiency of organizations. Next question, what is data flow? Data flow consists of the sources from where we extract the data and the destination where we load the data. It consists of transformations that modify and extend the data and the paths that link sources, transformations, and destinations. The three important categories in data flow are data sources, transformations, and destinations. Next question, what is control flow? A control flow consists of the tasks and containers that execute when the package runs. To control order or define the conditions for running the next task or container in the package control flow, we use precedent constraints which connect the task and the containers in a package. SQL Server integration services provide three different types of control flow elements, which include containers that provide structures and packages, tasks that provide functionality, and precedence constraints that connect the executable containers and tasks into an ordered control flow. What is OLAP? OLAP is an online analytical processing. It is a computing method that enables users to easily and selectively extract and query data in order to analyze it from different points of view. OLAP business intelligence queries often aid in trends analysis, financial reporting, sales forecasting, budgeting, and other planning purposes. Next, you may be asked to differentiate between OLAP and ETL tools. ETL can extract, transform using various transformations that are available in the tool and aggregate the data. The output can be used as an input for the OLAP tool. ETL is the initial part of data warehouse. While OLAP supports online reports after performing certain join operations and creating some queues. OLAP consists of various applications for scorecarding, reporting, dashboards, consolidation, planning, analysis, master data management, workspace, and foundation. You may be asked about the tools used in MSBI. There are three tools, SSIS or SQL Server Integration Services. It is useful for integrating the data coming from different data sources in a data warehouse. The number of data sources together contribute form data. SSIS is generally responsible for bulk transactions. SSAS or SQL Server Analysis Services, which is an online analytical processing tool, online analytical processing, data mining, and reporting tool used in business intelligence. While SSRS stands for SQL Server Reporting Service. Once the data is in its final state, SSRS provides the tools necessary to create reports to better understand the data. Next, what is a workflow in SSIS? A workflow is a set of instructions tell the program executor how to execute tasks and containers within SSIS packages. Next, what is the difference between where and having clause in SQL Server? Now, there can be three differences. First, having clause can be used with group by clause, while where clause is used with constructs like select, update, delete, etc. The having clause is applied as a filter after the group by clause, whereas in where clause is applied to every row in the select, update, delete, etc. construct. When both having and where clauses are used, having clause is applied after where clause to further filter the output of the where clause, while the where clause is applied before the having clause to every row in the select statement. Next, what is the difference between view and materialized view? First is the definition. A view displays a query's output as a table, while a materialized view are schema objects which can be used to summarize, pre-compute, replicate, and distribute data. Example, to construct a data warehouse. Then, all operations performed on a view will affect data in the base table and so are subject to integrity constraints and triggers of the base table, while in materialized views provides indirect access to the data table by storing the results of a query in a separate schema object. A view can be used to simplify SQL statements for the user or to isolate an application from any future change to the base table definition. A view can also be used to improve security by restricting access to a predetermined set of rows or columns. One view can be based on another. A view can also join a view with a table. While materialized views, when used for query rewrite, improve the performance of SQL execution. Next, what are the differences between truncate and delete clauses in SQL Server? Firstly, truncate is a DDL, that is data definition language command, while delete is a DML, that is data manipulation language command. Truncate removes all the records from a table without making a log entry for individual row deletion, while delete removes all or selected records from a table by making a log entry for individual row deletion. Truncate is faster, while delete is slower. Truncate removes all the records from a table, and the where clause or filter condition cannot be used. While in case of delete, it can remove selected records or all records based on whether where clause, which is optional, is used or not respectively. Truncate cannot be used on a table if it is referenced by one or more foreign key constraints or it is marked enabled for replication, while delete can be used in these conditions. Finally, truncate resets identity in any of the columns in a table, while delete does not reset the identity in any of the columns in a table. Next, we have the intermediate level question. First, name the components of SSAS. Now, SSAS has 5 components. First is the OLAP engine. It is used to provide fast ad hoc queries by users. Then drilling, which is the process of exploring details of the data. Pivoting is the process of switching categories of data between rows and columns. Slicing is the process of placing data in rows and columns. And the fifth component, which is dimensional database, are used in OLAP. Next, you may be asked to describe the SSAS architecture. The architectural view of SQL Server Analysis Services is based on a 3-tier architecture, which consists of, first, the RDBMS. The data from different sources like Excel, database, text and others can be pulled with the help of ETL tools into the RDBMS. Second, SSAS, which aggregates data from RDBMS, is pushed into SSAS cube by using analysis service project. The SSAS will create an analysis database, and once the analysis database is ready, it can be used for many purposes. Third, clients. Clients can access data using dashboards, scorecards, portals, etc. Coming to the next question, describe errors in SSIS. Errors generally occur due to unexpected data values when a data flow component applies the transformation to column data, extracts data from sources, or loads data into destination. Types of errors are: they occur when the connection manager cannot be initialized the connection string in case of data sources, data destinations, and control flows that use the connection string. Data transformation errors occur while data is being transformed over a data pipeline from source to destination, while expression evaluation errors occur if expressions that are evaluated at runtime perform invalid. What languages are used in SSAS? The languages used in SSAS are SQL, which is structured query language. SQL lets you access and manipulate databases. Next is MDX, which is multi-dimensional expression. It is a query language for online analytical processing using database management systems. Like SQL, it is a query language for OLAP queries. It is also a calculation language with syntax similar to spreadsheet formulas. Next, DMX or data mining extensions is a language that you can use to create and work with data mining models in SSAS. You can use DMX to create the structure of new data mining models, to train these models, and to browse, manage, and predict against them. Next, we have the Analysis Services Scripting Language, ASSL, which is an extension to XML that adds an object definition language and command language for creating and managing analysis services structures directly on the server. You can use ASSL in custom applications to communicate with analysis services over the XML protocol. Next, what is write-back? Write-back is the ability to update source systems such as databases, to maintain systems of records while staying within the context of a BI application. This is essential to the concept of embedded BI. A good BI application will enable these data updates in a secure and managed way. Next, name the business analysis enhancements available for SSAS. The business analysis enhancements that are available in Microsoft SQL Server analysis services are time intelligence, account intelligence, dimension intelligence, custom aggregation, semi-additive behavior, custom member formula, custom sorting and uniqueness settings, and dimension write-back. You may also be asked to write an SQL query. Let's take an example. To write an SQL query to extract first tuple from a set. The SQL query for this will be select date dot calendar year dot members dot item 0 on 0 from AdventureWorks. Here AdventureWorks is the database. It will give the output of the first tuple from the set, as you can see. Next, what is a RAG hierarchy? Now, under normal circumstances, each level in a hierarchy in Microsoft SQL Server Analysis Services, that is SSAS, has the same number of members above it as any other member at the same level. In a RAG hierarchy, the logical parent member of at least one member is not in level immediately above the member. When this occurs, the hierarchy descends to different levels for different drill down paths. Expanding through every level for every drill down path is then unnecessarily complicated. Now let us come to the advanced level question. Firstly, what is the difference between DTS and SSIS? DTS stands for Data Transformation Services, while SSIS stands for SQL Server Integration Services. In DTS, there is limited error handling, while SSIS provides more complex error handling. The messages in DTS, the message boxes use ActiveX script, while in SSIS, the message boxes use .NET scripting. In DTS, there is no deployment wizard, while in SSIS, we are provided with an interactive deployment wizard. In DTS, there are limited transformations, while in SSIS, there are more transformations. Finally, in DTS, there is no BI functionality, while in SSIS, there is complete integration with BI. Which lookup cache modes are available in SSIS? Now, there are three lookup cache modes in SSIS. The first is the full cache mode, which is the default cache mode. Full cache mode will cause the lookup transformation to retrieve and store in SSIS cache the entire set of data from the specified lookup location. As a result, the data flow in which the lookup transformation resides will not start processing any data buffered until all of the rows from the lookup query have been cached in SSIS. Next, we have the partial cache mode. When using this, lookup values will be cached, but only as each distinct value is encountered in the data flow. Initially, each distinct value will be retrieved individually from the specified source and then cached. To be clear, this is a row-by-row lookup for each distinct key value. Next, the no cache mode will not add any values to the lookup cache in SSIS. As a result, every single row in the pipeline data set will require a query against the lookup source. Since no data is cached, it is possible to save a small amount of overhead in SSIS memory in cases where key values are not reused. No cache mode is not used much, but it may be used in the following cases. When the reference data is too large to reasonably be loaded into SSIS memory, the pipeline dataset is small and is not expected to grow, there are expected to be very few or no duplicates of the key values in the pipeline dataset. How to log SSIS execution. SSIS includes logging features that write log entries when runtime events occur. They can also write custom messages, although it is not enabled by default. Integration services supports a diverse set of log providers, giving you the ability to create custom log providers. The integration services log providers can write log entries to text files, SQL Server Profiler, SQL Server, Windows Event Log, or XML files. Logs are associated with packages and are configured at the package level. Each task or container in a package can log information to any package log. The tasks and containers in a package can be enabled for logging even if the package itself is not. How do you deploy SSIS packages? Now there are two ways in which the SSIS packages can be deployed. The first way is that the SSIS project build provides a deployment manifest file. After running this file, you can deploy it to either the file system or the SQL server. The second method is to import the package from SSMS from file system or SQL server. Next, to create a calculated member that intersects all measures, where do you put it and why? Now, in MDX, you can create a calculated member, which is a member based on other members. You can create two different kinds of calculated members, ones that are measures and ones that are not. Remember that a measure is considered to be a member of the measure's dimension. To create a calculated member that intersects all measures, you would put it in a dimension other than measures, because a member in a dimension cannot intersect its own relatives in that dimension. Next, what is the use of property called non-empty behavior while creating a new member in a cube? Non-empty behavior is used for ratio calculation. An MDX expression will return an error if the denominator is empty, just as it would if the denominator were equal to 0. By selecting one or more measures for the non-empty behavior property, we're establishing the requirement that each selected measure first be evaluated before the calculated expression is evaluated. If each selected measure is empty, then the expression is also treated as empty and no error is returned. How are cubes implemented in SSAS? As multi-dimensional cube or hypercube is a data structure in SQL Server Analysis Services, that is SSAS, which is built using OLA-based databases to allow near instantaneous analysis of data. The useful feature of an OLAP cube is that the data in the cube can be in an aggregated form. SSAS cubes are created in a step-by-step process using the cube wizard. This brings us to the end of today's session. I hope now you have a better understanding of business intelligence analysis and the interview questions that you may be asked.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!